126 Real-World Behavioral Questions for Modern Platform Engineers.
Modern platform engineer interviews are no longer just about Kubernetes, AWS, Terraform, or infrastructure commands. Interviewers want to know how you make decisions when reliability conflicts with delivery, security conflicts with developer experience. Costs are rising, teams disagree, migrations go wrong, and there is no perfect technical answer. This video is built around those situations.
This is not a generic behavioral question list.
These 126 questions are designed around the actual responsibilities of modern platform engineers. Building internal platforms, improving developer experience, automating operational toil, making reliability and security decisions, managing platform economics, leading cross-team initiatives, and influencing engineering organizations without direct authority. Every question is designed to test how you think, decide, communicate, and take ownership.
How to approach these 126 questions.
Do not memorize the answers word for word. Use each answer as a framework and replace the example with your own real experience. The strongest interview response explains the situation, the decision you made, the trade-offs you considered, the action you took, and the measurable outcome. The follow-ups then test whether you genuinely understand the decision, rather than simply memorizing a polished story.
From engineering execution to staff-level judgment.
We start with the foundations of platform engineering and progressively move into reliability, production problem solving, observability, infrastructure practices, developer experience, automation, prioritization, leadership, security, and finally, the judgment required to operate platforms at organizational scale. By the final category, the focus shifts from simply asking how would you build it to should we build it, what does it cost, what are the risks, and what happens 5 years from now.
Your platform engineering journey starts here.
We are going to take these questions category by category. For each one, you will get the main behavioral question, a concise interview-ready answer, 2 targeted follow-ups, and a final curveball designed to test deeper engineering judgment. By the end, you should not just have answers. You should understand the thinking pattern behind strong platform engineer responses.
Here is how these 126 questions are divided into 11 categories.
We are going to master these 126 questions progressively across 11 areas of modern platform engineering. Category 1, ownership and accountability. Category 2, production incidents and reliability. Category 3, failure, mistakes, and learning. Category 4, developer collaboration and experience. Category 5, conflict and technical disagreement. Category 6, platform as a product and internal developer portals. Category 7, automation, operational toil, and AI integration. Category 8, prioritization, trade-offs, and build versus buy. Category 9, leadership, culture, and organizational influence. Category 10, security, compliance, and software supply chain. Category 11, modern platform judgment, FinOps, and scale. Your goal is not to memorize 126 answers. It is to build the judgment needed to answer almost any platform engineering behavioral question. Let's start our journey with Category 1.
Category 1, ownership and accountability.
Interviewers evaluate your ability to drive platform initiatives from inception to delivery, take responsibility for inherited technical debt, and stand by your architectural choices when things go wrong. In Category 1, we cover high-stakes ownership and accountability scenarios. When answering these questions, you must show how you drive projects end-to-end, own technical mistakes without making excuses, and step up to fix broken legacy systems.
Category 1, ownership and accountability, the 10 questions you must know.
Here are the top 10 ownership and accountability questions that you are going to master in Category 1. 1. Tell me about a platform project you owned end-to-end. 2. Tell me about a production problem where you took ownership. 3. Tell me about a time you took responsibility for something outside your team's scope. 4. Tell me about a platform decision where you were personally accountable for the outcome. 5. Tell me about a time you inherited a poorly designed platform. 6. Tell me about a time you had to make an important decision without your manager. 7. Tell me about a time you made a mistake that affected other engineering teams. 8. Tell me about a time you had to admit that your technical decision was wrong. 9. Tell me about a time you prevented a problem before it became a major incident. 10. Tell me about the most difficult platform problem you have personally owned. Let's dive into question 1.
1. Tell me about a platform project you owned end-to-end.
Answer. During our migration from virtual machines to Kubernetes for 40 microservices, I owned the core platform rollout end-to-end. I designed the Terraform infrastructure modules, built self-service deployment templates, and established observability baselines. Rather than forcing a sudden cutover, I partnered with application leads on a phased rollout over 6 months, resulting in zero unplanned downtime and significantly reduced operational overhead.
Follow-up 1. What was the hardest architectural decision you made during this project, and how did you validate it?
Answer. The hardest choice was choosing between multi-tenant clusters and dedicated clusters per team. I built a decision matrix comparing cloud cost, operational complexity, and security isolation. The analysis showed that namespace isolation with strict network policies met our required security controls while costing roughly half as much as dedicated clusters.
Follow-up 2. What did you personally do when application developers complained that your new pipeline broke their local testing workflow?
Answer. I held direct pairing sessions with their team lead within 24 hours. I realized our local container emulator lacked production volume mounts, so I updated our local development CLI tool to bridge the gap and restored their workflow velocity.
Follow-up 3 curveball. 2 weeks before the final migration deadline, your lead security architect vetoed your cluster networking setup. How did you handle that meeting?
Answer. I did not get defensive or argue during the meeting. I asked the security architect to map their compliance concerns directly against our architectural diagram, identified 2 missing policy as code rules, applied the fix overnight, and secured sign-off without slipping our launch date.
2. Tell me about a production problem where you took ownership.
Answer. I noticed silent API latency creep during Black Friday load testing, which I traced to connection pool exhaustion in our core microservice template. Rather than just alerting individual application teams, I pushed a hotfix, updated our platform golden path template, and coordinated a global patch that prevented a major holiday outage.
Follow-up 1. How did you specifically trace the latency to the connection pooling?
Answer. I analyzed distributed tracing telemetry alongside connection pool and application metrics. I saw the connection pool saturating during concurrency spikes, while application threads were waiting for available connections. That correlation explained the latency increase and intermittent timeouts under heavy load.
Follow-up 2. Why did you update the platform template yourself instead of making the application team own their service code?
Answer. Platform engineering requires systemic problem solving. The application team could have hotfixed their own app, but 40 other engineering teams relied on that exact template. Fixing it at the platform level eliminated the reliability risk globally for everyone.
Follow-up 3 curveball. The application team lead refuses your patch because they are under a strict deployment freeze, but you have 2 hours before peak holiday traffic. What do you do?
Answer. I do not force the deployment unilaterally. I schedule an immediate 10-minute emergency sync with the team lead and our engineering VP, present the load test failure data, and offer a staged rollout to a single canary node first to minimize risk.
3. Tell me about a time you took responsibility for something outside your team's scope.
Answer. A legacy payment service kept crashing due to memory leaks, causing frequent off-hours paging for the billing team. Although it was outside my platform scope, I volunteered to investigate. I profiled the issue, isolated the memory leak to an obsolete parser, and collaborated with the billing team to test and co-author a fix rather than modifying their domain logic independently.
Follow-up 1. How did you safely profile a fragile production monolith without causing further degradation?
Answer. I attached a lightweight diagnostic agent during off-peak traffic hours on a single canary instance. I captured incremental heap dumps specifically when garbage collection latency spiked, ensuring performance overhead remained completely unnoticeable to live traffic.
Follow-up 2. Did stepping out of your designated platform bounds cause you to drop the ball on your own team's sprint commitments?
Answer. No. I communicated clearly with my product manager beforehand. I time-boxed my investigation to 2 hours a day and temporarily delegated a routine documentation task to a peer, ensuring my core platform deliverables were completed on schedule.
Follow-up 3 curveball. The billing team lead tells you that infrastructure engineers should focus on pipelines instead of meddling in application code. How do you respond?
Answer: I do not take it personally. I validate their domain ownership and explain that my goal is simply to eliminate the midnight pager noise affecting both our teams, offering my profiling data as a tool for their team to use as they see fit.
4. Tell me about a platform decision where you were personally accountable for the outcome.
Answer: I made the decision to enforce immutable infrastructure by globally disabling SSH access to production worker nodes. It initially created developer friction because teams relied on live container debugging. I took accountability for the disruption, prioritized building ephemeral debug tools, and eliminated node drift across our clusters.
Follow-up 1. How did you replace the critical live debugging capabilities that developers lost when you revoked access?
Answer: I deployed a secure ephemeral container plugin into our orchestration layer. This allowed developers to attach a temporary debug pod with required diagnostic tools to a failing service without ever granting root access to the underlying host node.
Follow-up 2. What hard metrics did you use to prove to leadership that this initial developer friction was worth the outcome?
Answer: I tracked mean time to resolution and node configuration drift alerts. Over the following 3 months, node drift alerts fell to 0, and incident recovery times improved by 40% because infrastructure state was consistently tracked in version control.
Follow-up 3 curveball. A VP of engineering demands temporary SSH access during a critical midnight outage, threatening your job if you refuse. What do you do?
Answer: I hold the line on our security compliance policy, but I immediately offer to join their incident bridge. I use our secure break glass telemetry tools to extract the exact runtime diagnostics they need, without violating zero trust protocols.
5. Tell me about a time you inherited a poorly designed platform.
Answer: I inherited a custom, undocumented deployment pipeline that failed randomly and contained hard-coded credentials. Rather than attempting a risky immediate rewrite, I stabilized the system first by moving secrets to a vault and adding telemetry, then led a phased 9-month migration to Argo CD.
Follow-up 1. How did you safely extract hard-coded secrets from a brittle, black box system without breaking it?
Answer: I utilized transparent proxying to intercept its network calls. Once I mapped out the downstream authentication endpoints, I modified the execution environment to inject dynamic secrets via environment variables, completely avoiding changes to the legacy binary code.
Follow-up 2. Why did you not just rip and replace it immediately if it was that unstable?
Answer: an immediate rewrite would have halted all developer feature delivery for months. Stabilizing the legacy pipeline ensured business continuity while we meticulously built, tested, and onboarded teams to the modern continuous delivery platform in parallel.
Follow-up 3 curveball. The original architect of that legacy platform returns to the company as your new director. How do you explain why you replaced their system?
Answer: I focus on business growth rather than criticizing past architectural choices. I explain that their original platform successfully scaled the company to its initial milestone, and our migration to cloud-native tooling was the natural next step for our current scale.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
6. Tell me about a time you had to make an important decision without your manager.
Answer: during a weekend database incident, our primary cluster became unstable while replication lag on the asynchronous replica exceeded 45 minutes. My manager was offline, so I paused non-essential batch workers and initiated the documented failover procedure to our synchronous standby, which was fully caught up. I coordinated the traffic switch, verified application rights, and restored normal operations without waiting for managerial approval.
Follow-up 1. How did you validate that the failover would not result in data loss before executing it?
Answer: I fenced the unhealthy primary to prevent split brain rights, verified the standby's replication state, and only then promoted it. This gave us a controlled failover while keeping the risk of data loss within our documented recovery objectives.
Follow-up 2. How did you document and communicate this autonomous decision to leadership and affected teams?
Answer: I immediately posted the decision and current database state in the incident channel, including why waiting for approval would increase customer impact. I recorded each action and timestamp in the incident timeline, then walked my manager through the decision and evidence during the post-incident review.
Follow-up 3 curveball. On Monday, your manager is upset that you paused worker queues, claiming it breached a partner reporting SLA. How do you handle that discussion?
Answer: I would acknowledge that pausing the queues affected the partner SLA, then explain the priority decision using the incident evidence. Protecting transactional integrity took precedence over a delayed reporting workload. I would also use the incident review to clarify these priorities in the off-hours runbook, so future engineers can act consistently.
7. Tell me about a time you made a mistake that affected other engineering teams.
Answer: I updated a core Terraform module for our ingress controller to optimize keep alive settings, but inadvertently lowered the connection timeout threshold. This caused persistent gRPC connections from 3 product microservices to drop periodically. I immediately rolled back the change, published a transparent incident report, and added automated integration tests for long-lived gRPC connection in our platform pipeline.
Follow-up 1. How did you isolate the connection drop issue when application teams were only reporting vague gateway errors?
Answer: I correlated the timing of their error spikes with my module deployment timestamp. I then reproduced the connection reset behavior in staging using synthetic long-lived gRPC traffic while monitoring proxy connection state logs.
Follow-up 2. How did you rebuild technical trust with the affected product teams after causing these connection drops?
Answer: I attended their team stand-up and explained the root cause candidly without making excuses. I invited their senior engineers to review the integration test changes with me, incorporated their feedback, and demonstrated that the failure mode was now covered before the module was released again.
Follow-up 3 curveball. An affected tech lead demands that all future platform team changes receive manual approval from app teams before deployment. How do you respond?
Answer: I empathize with their frustration, but explain that manual approval gates severely slow down overall engineering velocity. Instead, I propose adding automated canary deployments with automated rollback triggers to protect their services without creating manual bottlenecks.
8. Tell me about a time you had to admit that your technical decision was wrong.
Answer: I championed migrating our internal service routing to a complex service mesh to achieve fine-grained traffic splitting. After 4 months, the operational overhead and sidecar memory consumption far outweighed the benefits for our scale, creating developer debugging friction. I publicly admitted the architecture was over-engineered, presented a simplified cloud-native ingress plan, and led the decommissioning effort.
Follow-up 1. What specific metrics forced you to acknowledge that the service mesh was the wrong technical choice?
Answer: the sidecars consumed roughly 20% of our cluster memory capacity, while developer onboarding time had doubled because of the added configuration and debugging complexity. At the same time, we were using only a small portion of the mesh capabilities. Those metrics showed that the operational cost was outweighing the benefits at our current scale.
Follow-up 2. How did you pivot the team without making engineers feel like 4 months of work was completely wasted?
Answer: I framed the effort as an empirical evaluation that tested our scale limits. We extracted valuable telemetry patterns and security policies from the mesh configuration and successfully integrated them into our simplified ingress architecture.
Follow-up 3 curveball. A senior engineer who originally opposed the service mesh says, "I told you so" in a public retrospective. How do you react?
Answer: I stay humble and publicly give them credit for their early foresight. I redirect the energy toward capturing our shared lessons learned, using their feedback to refine our RFC evaluation framework for future technology decisions.
9. Tell me about a time you prevented a problem before it became a major incident.
Answer: while reviewing weekly telemetry trends, I noticed a subtle linear increase in wildcard TLS certificate renewal failures on our edge proxies, hidden behind silent retry logic. The certificates were due to expire in 2 weeks, which would have dropped public HTTPS traffic globally. I investigated the renewal hook, fixed an IAM permission boundary misconfiguration, and successfully renewed the certificates long before any service outage occurred.
Follow-up 1. Why did standard alert rules fail to flag these silent certificate renewal retries earlier?
Answer: The background script returned exit code 0 on retry attempts, masking underlying authentication failures. I updated the script to emit explicit metrics on first failure attempts and wired alerts directly to our primary monitoring channel.
Follow-up 2. How did you ensure similar silent configuration failures would not recur in other automated security workflows?
Answer: I audited our critical scheduled automation and certificate management pipelines across the accounts. We enforced explicit failure reporting, validated exit codes, and added dead man switch monitoring for scheduled maintenance tasks, so silent failures would become visible.
Follow-up 3 curveball. Security refuses to give your certificate manager automated IAM permissions, requiring manual approval for every renewal. How do you resolve this?
Answer: I schedule a sync with their compliance lead. I demonstrate that manual renewals introduce human error risks and partner with them to draft a scoped, least privilege policy as code rule that satisfies their audit requirements while preserving automation.
10. Tell me about the most difficult platform problem you have personally owned.
Answer: our production clusters experienced intermittent, sub-second packet drops causing random 504 gateway timeouts under peak traffic. The issue was non-deterministic and spanned cloud networking, Linux kernel parameters, and container networking behavior. I took ownership of the investigation, spent 3 weeks analyzing eBPF traces, identified connection tracking table exhaustion as the bottleneck, and tuned contract capacity and connection timeouts to eliminate the packet drops.
Follow-up 1. What technical tools and methodology did you use to trace sub-second network drops at the kernel level?
Answer: I utilized eBPF tracing scripts to hook into kernel TCP drop points, tracking connection table insertion rates alongside socket buffer allocations to isolate the exact point where packet drops occurred under high concurrency.
Follow-up 2. How did you maintain leadership confidence during 3 weeks of investigating an intermittent, hard-to-reproduce bug?
Answer: I published daily status logs summarizing eliminated hypotheses, shared raw telemetry charts with engineering leadership, and built a synthetic staging environment that reliably reproduced the load conditions.
Follow-up 3 curveball. Management pressures you during week 2 to execute a nightly node reboot script as a temporary fix. How do you respond?
Answer: I present data showing that scheduled reboots actually spike connection churn and elevate failure risks during pod rescheduling. I offer a safer connection draining script as an interim mitigation while keeping full focus on the permanent kernel fix.
Category 1. Key takeaways for platform engineers.
Before moving forward, remember these core principles for ownership and accountability. 1. End-to-end delivery: never leave a platform change half-finished. Own the architecture, deployment, and operational stability. 2. Blameless accountability: own your technical mistakes immediately without making excuses or shifting blame to application teams. 3. Systemic fixes when resolving issue workarounds. Fix the shared platform template or pipeline so no other team encounters the same bug. Now, let us transition to Category 2.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 1 ownership and accountability to Category 2 production incidents and reliability.
Moving from individual ownership into Category 2 shifts the focus to high-pressure operational environments. Here, interviewers test how you maintain composure during live SEV1 outages, diagnose complex system failures under time constraints, and build long-term reliability into the platform.
Category 2 production incidents and reliability.
Interviewers test your operational composure, real-time troubleshooting, and root cause analysis during active outages. In Category 2, we cover production incident scenarios. When answering these questions, you must highlight fast mitigation, clear leadership communication, and long-term systemic fixes.
Category 2 production incidents and reliability, the 12 questions you must know.
Here are the top 12 production incidents and reliability questions that you are going to master in Category 2. 11. Tell me about the most serious production incident you handled. 12. Tell me about a production outage caused by a platform change. 13. Tell me about a time you had to troubleshoot an incident with incomplete information. 14. Tell me about a time you had multiple production incidents simultaneously. 15. Tell me about a time you disagreed with the proposed incident resolution. 16. Tell me about a time you made a wrong decision during an incident. 17. Tell me about a production incident where communication was as important as the technical fix. 18. Tell me about a recurring incident you eventually eliminated. 19. Tell me about a time you identified a reliability risk before customers noticed it. 20. Tell me about an incident that changed how your platform was designed. 21. Tell me about a time you defined or evolved SLOs/SLIs/error budgets for a platform service. 22. Tell me about improving observability that meaningfully reduced MTTR or prevented incidents. Let's dive into question 11.
11. Tell me about the most serious production incident you handled.
Answer. During a global traffic surge, a deadlocking database query in our core service template caused connection pool starvation across 50 microservices. As the incident commander, I ordered an immediate feature flag deactivation for non-essential background workloads, isolated the blocking query, and drained active connections. This restored database responsiveness in 18 minutes, preventing a multi-hour global platform outage.
Follow-up 1. How did you identify which non-essential feature flag to toggle without triggering unintended cascading failures?
Answer. I referenced our predefined workload criticality matrix and first disabled recommendation feeds and background analytics. This immediately reduced connection demand by roughly 40% while keeping checkout and other transactional workloads running. I monitored database connection utilization before disabling any additional workloads.
Follow-up 2. How did you handle communication with executive leadership while actively directing technical containment on the bridge?
Answer. I designated a dedicated communications lead to handle executive updates every 10 minutes. This kept executive status requests off the main technical incident bridge, allowing engineering leads to focus purely on connection draining and system recovery.
Follow-up 3 curveball. An executive joins the incident bridge and demands an immediate full database cluster reboot while you are halfway through draining connections. How do you respond?
Answer. I explained that an immediate reboot would interrupt active transactions and force crash recovery, while our controlled drain is already improving the situation. I share telemetry showing connection recovery is at 70% and ask for 3 minutes to complete the graceful drain. If recovery stalls, I am prepared to reassess the reboot option.
12. Tell me about a production outage caused by a platform change you deployed.
Answer. During a routine ingress controller upgrade, an unannounced configuration deprecation broke traffic routing for our order processing services. I immediately initiated the rollback, restored traffic within 4 minutes, and then investigated why staging had not detected the incompatibility. I added version compatibility validation and production, like routing tests, to our CI and CD pipeline to prevent the same regression.
Follow-up 1. What exactly did you change, and why did you believe it was safe prior to deployment?
Answer. We upgraded the ingress controller from version 1.22.0 to version 1.24.0. It passed all staging tests because our staging environment lacked synthetic traffic mimicking production API header routing.
Follow-up 2. What did you personally do within the first 5 minutes of realizing your platform change broke production?
Answer. I did not waste time debugging in production. I immediately declared a SEV1, hit the automated Canary rollback trigger, and communicated on the incident channel that the platform team was reverting the change.
Follow-up 3 curveball. Your manager publicly tells leadership the incident was caused by your inadequate testing. You disagree, and no staging lacked production parity. How do you handle that conversation?
Answer. I handle it privately after the incident and avoid turning it into a blame discussion. I show that staging tests passed but did not exercise production like header routing, which exposed a test coverage gap. I then propose closing that gap with production traffic shadowing and compatibility tests.
13. Tell me about a time you had to troubleshoot an incident with incomplete information.
Answer. During a midnight outage, worker nodes were failing health checks, but log aggregation had stalled due to network buffer saturation on the logging daemon. Facing 0 live logs, I used host-level system metrics and cloud provider network interface counters to isolate packet drops to a specific subnet, rerouted traffic to a secondary availability zone, and restored service in 22 minutes.
Follow-up 1. How did you verify that the secondary availability zone had sufficient capacity before swinging live traffic over?
Answer. I checked our cloud provider capacity metrics and auto-scaling group limits. I scaled up the secondary zone worker node count by 50% prior to shifting DNS traffic, preventing a secondary capacity bottleneck.
Follow-up 2. What steps did you take post-incident to ensure logging pipelines remain resilient during network saturation?
Answer: I configured the logging daemon with disk-backed local buffers, so logs could survive temporary network disruption. I also isolated telemetry traffic where possible and added monitoring for buffer utilization, giving us visibility into logging health before the buffers approach saturation again.
Follow-up 3 curveball. A senior network engineer insists your subnet isolation theory is wrong and refuses to assist with traffic rerouting. How do you proceed?
Answer: I do not argue over theories during a live incident. I present the cloud interface packet drop metrics, demonstrate that rerouting traffic via feature flags carries low risk, and take responsibility for executing the route change myself.
14. Tell me about a time you had multiple production incidents simultaneously.
Answer: during a major deployment window, our primary DNS provider suffered regional latency spikes, while an automated backup script simultaneously filled the root volume on our primary database host. I triaged the risks, designated a co-lead to handle the database disk cleanup, and focused my efforts on switching our edge proxy DNS fallback to a secondary provider, resolving both incidents in under 25 minutes.
Follow-up 1. What triage framework did you use to decide which incident to tackle personally versus delegating?
Answer: I prioritized based on customer impact, blast radius, and time to failure. The DNS degradation was already affecting a large portion of public API traffic, while the database disk issue had an estimated 15-minute buffer before becoming critical. I therefore kept DNS mitigation as my primary focus and delegated the database cleanup.
Follow-up 2. How did you prevent crosstalk and confusion between the two incident response channels?
Answer: I created 2 dedicated incident channels with designated technical leads for each, maintaining a single master bridge channel where co-leads provided concise 5-minute status updates to executive stakeholders.
Follow-up 3 curveball. Halfway through, a third SEV1 alert fires for payment gateway timeouts. How do you reevaluate your capacity and response structure?
Answer: I assess our available incident responders, pull in an on-call secondary engineer, and assign them payment gateway mitigation. I maintain overall incident commander command to ensure resources are balanced across all 3 streams.
15. Tell me about a time you disagreed with the proposed incident resolution.
Answer: during a severe database deadlock, the lead DBA proposed a hard node reboot to clear the blocked workload quickly. I disagreed because abruptly terminating the node could trigger unnecessary recovery and increase the risk to active transactions. I proposed pausing new worker requests and terminating the specific blocking database session through the supported database controls, which cleared the deadlock while preserving transaction integrity.
Follow-up 1. How did you quickly prove to the team that a targeted session termination was safer than a hard node reboot?
Answer: I used the database lock and transaction views to show which sessions were blocking the largest number of active transactions. That evidence gave us a targeted mitigation option, instead of restarting the entire node and forcing every active transaction through crash recovery.
Follow-up 2. How did you maintain constructive collaboration with the DBA after overriding their proposed solution during a high-stress outage?
Answer: I framed the disagreement around risk management rather than technical competence. Post-incident, I invited the DBA to co-author our updated database incident runbook, incorporating their feedback on automated lock monitoring.
Follow-up 3 curveball. The DBA executes the hard reboot anyway while you are explaining your alternate proposal. What is your immediate next action?
Answer: I immediately pivot from debate to mitigation. I focus on monitoring the database crash recovery process, prepare our team to verify transaction integrity logs, and communicate updated timeline estimates to stakeholders.
16. Tell me about a time you made a wrong decision during an incident.
Answer: during an API latency spike, I misdiagnosed the bottleneck as CPU starvation on worker pods and scaled the replica count from 20 to 80. This instantly flooded our downstream database with 400 new connections, crashing the connection pool entirely. I immediately recognized my error, scaled the pods back down, implemented connection pooling limits, and restored stability.
Follow-up 1. What specific telemetry metric did you miss during your initial triage that led to the misdiagnosis?
Answer: I focused on high pod CPU utilization metrics without checking downstream database connection pool saturation, failing to realize that the CPU spike was actually caused by worker threads spinning while waiting on database sockets.
Follow-up 2. How did you communicate this misstep to the incident bridge without losing leadership trust?
Answer: I stated transparently on the bridge that scaling the pods exacerbated the outage. I announced the immediate reversion order, provided updated connection metrics, and outlined the correct mitigation path clearly.
Follow-up 3 curveball. Post-incident, a peer uses your mistake to argue that platform engineers should not have manual scaling authority during SEV1 seconds. How do you respond?
Answer: I agree that unvalidated manual interventions carry risk. I advocate for building automated safety guardrails and connection pool limits into our deployment templates, rather than revoking operator permissions during operational crises.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip: whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
17. Tell me about a production incident where communication was as important as the technical fix.
Answer. During a payment gateway degradation affecting global checkouts, technical mitigation required a 15-minute read-only maintenance window. Because customer support and executive teams were making conflicting public statements, I established a dedicated communications lead, published status updates every 10 minutes, and aligned customer support scripts before triggering the maintenance window, preventing customer panic.
Follow-up 1. How did you structure your status updates so both technical stakeholders and non-technical executives understood the impact?
Answer. I used a standard template containing 3 sections: current user impact in business terms, technical mitigation steps underway, and estimated time to next update, ensuring clarity without overwhelming non-technical readers.
Follow-up 2. How did you manage pressure from sales executives demanding to skip the 15-minute maintenance window?
Answer. I presented the evidence that continuing without the maintenance window would likely extend intermittent transaction failures for several hours. The controlled 15-minute window gave us a much more predictable recovery path, so I aligned sales and support around that option, rather than debating it as a purely technical decision.
Follow-up 3 curveball. An internal team leaks an unverified incident root cause on social media while you are mid-mitigation. How do you handle the fallout?
Answer. I notify PR and engineering leadership immediately. I refrain from arguing publicly, post an official update on our status page confirming our active mitigation timeline, and address the internal team privately after service restoration.
18. Tell me about a recurring incident you eventually eliminated.
Answer. Our Kubernetes worker nodes suffered recurring disk pressure evictions every Sunday at midnight, causing transient job failures for months. Previous on-call engineers cleared the issue by manually deleting old logs or rebooting nodes. I took ownership, audited the scheduled jobs, and identified an uncompressed log rotation process that caused the root file system to fill rapidly. I fixed the rotation configuration, enforced log retention limits, and added file system growth monitoring, eliminating the recurring evictions.
Follow-up 1. Why did previous on-call engineers fail to catch the root cause during their shifts?
Answer. Previous engineers focused on restoring capacity quickly by deleting logs or rebooting the affected nodes. The alerts cleared after the immediate disk pressure disappeared, which masked the scheduled Sunday log rotation trigger. The recurring timing pattern was only visible when we correlated incidents across several weeks.
Follow-up 2. What automated testing or monitoring did you implement to ensure log rotation jobs never caused disk pressure again?
Answer. I added automated checks for log retention and rotation settings during node image validation, and monitored file system utilization by workload. I also added alerts for abnormal log growth, so the platform would detect disk pressure risk before Kubernetes began evicting workloads.
Follow-up 3 curveball. Engineering leadership refuses to allocate sprint capacity for your refactoring fix, telling you to keep rebooting nodes. How do you convince them?
Answer. I calculate the cumulative engineering hours and customer SLA impact caused by the recurring Sunday incidents over 6 months. I compare that cost with the small amount of engineering effort required to fix the rotation process, giving leadership a clear reliability and business case for the change.
19. Tell me about a time you identified a reliability risk before customers noticed it?
Answer: while analyzing synthetic canary metrics, I detected a slow, compounding 2% daily increase in memory consumption across our ingress proxies. Memory was still below alert thresholds, but the trend showed that the proxies could exhaust their limits during an upcoming high-traffic product launch. I traced the growth to an inefficient connection configuration, corrected it, and updated baseline memory alerts 3 weeks before the launch.
Follow-up 1. What statistical method or anomaly detection approach did you use to detect the subtle memory growth trend?
Answer: I utilized linear regression, trend lines on 30-day telemetry metrics in Prometheus. This highlighted a steady memory growth pattern that standard static alert thresholds completely failed to flag.
Follow-up 2. How did you prioritize patching this subtle risk against competing high-priority feature delivery deadlines?
Answer: I presented the memory extrapolation model to the release team, showing that the projected launch traffic could trigger node kills within 3 hours of release. That evidence helped us secure immediate sprint priority for the patch.
Follow-up 3 curveball. The proxy vendor says the memory growth is expected under your traffic pattern and recommends no configuration change. How do you mitigate the risk while continuing to investigate?
Answer: I would treat the vendor's response as input rather than proof that the risk is acceptable. I would bound memory growth with controlled rolling restarts, increase capacity headroom for the launch, and continue collecting evidence while evaluating a longer-term configuration or proxy change.
20. Tell me about an incident that changed how your platform was designed.
Answer: a major cloud availability zone outage exposed a single point of failure in our platform because the central authentication service depended on one primary database instance. I took ownership of the redesign and introduced regional redundancy, local caching, and automated failover for the authentication layer. We then validated the design through controlled failure testing, so a localized cloud failure would no longer bring down the entire platform.
Follow-up 1. How did you handle cache consistency across the regional authentication architecture?
Answer: we used event-driven cache invalidation and short time to live values for locally cached authentication data. This reduced stale authorization information, while still allowing regional reads to continue during a database or network failure.
Follow-up 2. How did you validate that your new multi-region architecture actually survived a zone outage without testing in production?
Answer: we executed controlled failure tests in staging by injecting network latency and simulating availability zone loss. We verified that authentication traffic was redirected to the healthy path and measured recovery time against our defined availability and recovery objectives.
Follow-up 3 curveball. Finance rejects your multi-region architecture proposal because running active-active read replicas increases cloud spend by 30%. How do you negotiate?
Answer: I quantify the hourly cost of the recent outage in lost revenue and SLA penalty credits, showing that the 30% cloud spend increase is significantly cheaper than a single hour of global platform downtime.
21. Tell me about a time you defined or evolved SLOs, SLIs, and error budgets for a platform service.
Answer: our platform team was judged on arbitrary 99.99% infrastructure uptime, which ignored real developer build latency and service degradation. I led an initiative to redefine our SLIs around end-to-end API response time and deployment success rate. We established realistic error budgets, allowing us to freeze risky platform deployments whenever the error budget was exhausted.
Follow-up 1. How did you select the exact mathematical percentile thresholds for your latency SLIs?
Answer: we analyzed 90 days of production traffic, historical incidents, and user-facing latency patterns. We evaluated both the 95th and 99th percentiles and selected thresholds that represented meaningful customer impact rather than simply matching our historical averages. We then validated the targets with application and product teams before making them our SLOs.
Follow-up 2. How did you get product development teams to respect and adhere to error budget policy freezes?
Answer: we partnered with engineering VP leadership to establish explicit governance policies. When an error budget was exhausted, sprint capacity automatically pivoted from feature work to reliability engineering until the budget recovered.
Follow-up 3 curveball. A product team demands an exception to bypass an error budget freeze to ship an urgent business feature. How do you handle the request?
Answer: I require the product lead to submit a formal risk acceptance request to the VP of Engineering, outlining the business value versus the reliability risk, ensuring exceptions are deliberate executive decisions rather than informal bypasses.
22. Tell me about improving observability that meaningfully reduced MTTR or prevented incidents.
Answer: our incident response was slowed by fragmented logs across 15 separate monitoring tools, resulting in an average MTTR of 45 minutes. I spearheaded the implementation of unified distributed tracing and standardized open telemetry instrumentation across all platform services. Correlating traces, metrics, and logs in a single dashboard reduced our average MTTR from 45 minutes down to 12 minutes.
Follow-up 1. How did you manage telemetry sampling rates to control storage costs while maintaining high-fidelity tracing?
Answer: we implemented tail-based sampling so error traces and high-latency requests received much higher sampling priority than healthy low-latency traffic. Successful requests were sampled at a much lower rate, allowing us to preserve useful diagnostic fidelity without allowing telemetry storage costs to grow with traffic volume.
Follow-up 2. How did you train and onboard 100-plus application developers to effectively use the new distributed tracing tools during incidents?
Answer: I hosted hands-on workshop sessions, embedded open telemetry templates into our internal developer portal Golden Paths, and created cheat sheets mapping common error traces directly to incident runbooks.
Follow-up 3. Curveball. A major telemetry vendor outage removes your centralized observability during an active SEV1 incident. What is your fallback observability strategy?
Answer: we maintain lightweight local diagnostic tools and host-level logging agents that operate independently of the third-party telemetry vendor. During a vendor outage, engineers can still inspect node health, container state, local logs, and core Kubernetes metrics through the cluster and host-level tooling.
Category 2. Key takeaways for platform engineers.
Before moving forward, here are the key takeaways from Category 2. Operational composure. Stay calm during SEV1 outages. Prioritize fast mitigation over immediate deep debugging, and maintain clear communication. Evidence-driven decisions. Use live telemetry and data to resolve technical disagreements rather than debating opinions during active incidents. Systemic reliability. Eliminate recurring failures by fixing underlying platform templates, enforcing resource quotas, and building resilient observability. Now, let us transition to Category 3.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 2 to Category 3.
We just wrapped up Category 2, where the focus was entirely on keeping the platform alive during critical outages. But what happens when the dust settles and you realize you were the one who caused the outage? That brings us to Category 3. We are leaving the incident bridge behind and entering the postmortem room to talk about failure, mistakes, and learning.
Category 3. Failure, mistakes, and learning.
In Category 3, we cover failure modes, technical mistakes, and postmortem learning. We will break down how to handle failed platform changes, recover from automation bugs, address missed requirements, and turn architectural mistakes into long-term system improvements.
Category 3. Failure, mistakes, and learning, the 10 questions you must know.
Here are the top 10 failure, mistakes, and learning questions that you are going to master in Category 3. 23. Tell me about your biggest technical mistake. 24. Tell me about a platform change that failed. 25. Tell me about a deployment that didn't go as planned. 26. Tell me about a time your automation caused a problem. 27. Tell me about a time your monitoring failed to detect an issue. 28. Tell me about a time you underestimated a platform project's complexity. 29. Tell me about a time you chose the wrong technology. 30. Tell me about a time you missed an important requirement. 31. Tell me about a failure that initially looked like someone else's fault but wasn't. 32. Tell me about something you would architect differently today. Let's dive into question 23.
23. Tell me about your biggest technical mistake.
Answer: I accidentally executed an automated cleanup script without scoping it to staging, which deleted static asset caches across our production edge proxies. Origin servers were immediately overwhelmed by the resulting cache misses, causing severe latency spikes for 10 minutes. I stopped the script, rate-limited non-critical origin traffic, and launched a controlled cache warming job for the highest traffic routes. I then implemented strict environment boundary checks, so unscoped executions are blocked automatically.
Follow-up 1. How did you halt the cache purge and stabilize origin server traffic within 10 minutes?
Answer: I immediately killed the cleanup process and temporarily updated our origin rate limits to prevent cascading backend server crashes under the sudden load. I then executed pre-scripted cache warming requests specifically targeting our highest traffic routes, which successfully restored cache hit ratios toward their normal baseline within 10 minutes.
Follow-up 2. How did you handle the postmortem with leadership without making excuses for running the unscoped script?
Answer: I owned the mistake completely without shifting blame to ambiguous documentation or confusing tooling. During the incident review, I presented a clear root cause analysis, demonstrated the new hard guardrails I built into our scripts, and showed how automated environment checks now block unapproved production execution.
Follow-up 3 curveball. A senior director wants to revoke CLI execution rights for all junior engineers as a reaction to your mistake. How do you respond?
Answer: I would respectfully advocate against revoking individual permissions, as that simply creates bottlenecked approval queues for senior engineers. I would demonstrate that by building hard environment guardrails and automated approval workflows directly into our CI and CD pipelines, we can safely prevent accidental executions without destroying developer velocity.
24. Tell me about a platform change that failed.
Answer: I deployed an updated auto-scaler policy, specifically designed to reduce cloud costs by tightening our node scale down thresholds. Unfortunately, the policy reacted too aggressively to transient CPU bursts, causing nodes to continuously provision and terminate every 15 minutes. Once I noticed the thrashing, I reverted to the baseline policy within 30 minutes, stabilized the cluster, and added damping cooldown timers to prevent any future scaling loops before attempting the cost optimization.
Follow-up 1. What specific metric threshold caused the auto-scaler to enter a continuous scale-up and scale-down loop?
Answer: the scale-down evaluation window was set to just 3 minutes without a sufficient stabilization period. Short, unexpected traffic bursts correctly triggered scale-ups, but as soon as the traffic normalized, that aggressive 3-minute evaluation window triggered premature node terminations before the new pods could even handle requests.
Follow-up 2. How did you test the updated cooldown timers before redeploying the auto-scaler policy to production?
Answer: we built a specialized load testing harness and staging that reproduced representative bursty traffic patterns and sustained traffic lulls. We used it to validate the new 15-minute stabilization window and confirmed that premature node terminations were eliminated, while the autoscaler still reduced capacity during sustained low traffic.
Follow-up 3 curveball. Finance complains that reverting the auto-scaler policy increases monthly cloud spend by $10,000 while you fix the bug. What is your response?
Answer: I would present telemetry data showing that continuous node thrashing was causing deployment instability and increasing the risk of SLA penalties. I would explain that taking a week to thoroughly validate the cooldown timers gives us a much safer path to long-term stable auto-scaling without risking customer-facing platform outages.
25. Tell me about a deployment that didn't go as planned.
Answer: during a major platform release, a database schema migration script executed before an updated API service was fully deployed due to a missing step dependency in our pipeline. This mismatch caused transient 500 errors for users hitting the updated endpoints. I immediately paused the pipeline, applied a backwards compatible schema patch, and completely restructured our CI and CD workflows to enforce strict schema migration ordering logic across all future deployments.
Follow-up 1. How did you maintain backwards compatibility while patching the database schema during the active deployment?
Answer: I used an expand and contract approach, so the schema remained compatible with both the old and new application versions. I first added the new fields with safe defaults, deployed the application changes, and allowed both versions to operate during the transition. Once the new version was fully deployed and validated, we completed the data migration and removed the legacy dependency.
Follow-up 2. How did you update the pipeline definition so missing dependency bugs are caught during pull request validation?
Answer. I created automated pipeline linter checks that deeply validate directed acyclic graph dependencies inside our deployment manifests. This mechanism effectively ensures that database migrations will always require explicit service dependency gates and successful health checks before the pipeline runner allows execution to proceed.
Follow-up 3 curveball. The product team demands to proceed with the release, despite active schema errors to meet a marketing deadline. How do you handle the pressure?
Answer. I would present the live error metrics and explain that proceeding with an incompatible schema creates a known customer impact risk. I would recommend the short delay required to apply and validate the backwards compatible patch, while giving the product team a revised deployment time they can communicate against.
26. Tell me about a time your automation caused a problem.
Answer. I wrote a cron automation to streamline TLS certificate renewals, but the script directly restarted all edge proxy pods instead of using the daemon set's controlled rolling update mechanism. That caused a 2-minute global drop in HTTPS connections. I immediately stopped the automation, restored the proxy pods through the controller, and redesigned the renewal process to use controlled rollouts with canary validation before broader restarts.
Follow-up 1. Why did the automated script execute a global restart rather than inheriting the daemon set rolling update policy?
Answer. The script directly deleted or restarted the proxy pods instead of invoking the daemon set's standard rollout mechanism that bypassed the controller's availability controls and allowed too many replicas to disappear simultaneously. The fix was to make the automation operate through the supported rollout path rather than manipulating individual pods.
Follow-up 2. What automated safety checks did you add to ensure scripts cannot bypass cluster rolling update policies again?
Answer. I added policy as code controls that restrict automated pod deletion for protected workloads and require approved rollout mechanisms for certificate-related restarts. I also added CI validation, so automation scripts cannot introduce direct destructive operations against protected namespaces without an explicit exception.
Follow-up 3 curveball. Your team lead suggests disabling automated certificate renewals completely and returning to manual updates. How do you convince them otherwise?
Answer. I would demonstrate that reverting to manual renewals introduces human error and increases the risk of missed certificate expirations. I would show that fixing the rollout logic, adding canary validation, and monitoring the renewal workflow gives us a much safer automated process while preserving the operational benefits of automation.
27. Tell me about a time your monitoring failed to detect an issue.
Answer. Our edge monitoring showed 100% HTTP 200 success rates, but users actively reported being unable to load their account data. An API gateway fallback handler was returning HTTP 200 with empty JSON payloads whenever internal database timeouts occurred, completely hiding the failure from our availability alerts. I updated our synthetic probes to validate actual payload schema content, rather than just relying on HTTP status codes to determine system health.
Follow-up 1. How did you identify that the fallback handler was masking true database connection timeouts?
Answer. I inspected live user session telemetry and correlated front-end client errors with the back-end gateway access logs. I discovered that the gateway systematically swallowed downstream database timeouts and emitted empty HTTP 200 responses back to the client, creating a dangerous false positive for our uptime dashboards.
Follow-up 2. How did you update your alert strategy to monitor semantic payload correctness alongside HTTP status codes?
Answer. I introduced deep health check endpoints alongside synthetic transaction monitoring that aggressively validate response body JSON keys and specific payload sizes. Our platform now alerts immediately whenever empty fallback responses exceed normal baseline thresholds, catching silent data failures instantly before customers notice.
Follow-up 3 curveball. Application developers resist adding payload validation to health checks, arguing it increases endpoint latency. How do you negotiate?
Answer. I would propose running these synthetic payload validation probes at a lightweight 1-minute interval from dedicated monitoring workers, rather than on every single live user request. This architectural compromise ensures health check accuracy without negatively impacting actual end user request latency or consuming excessive compute resources.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
28. Tell me about a time you underestimated a platform project's complexity.
Answer: I estimated a 3-week timeline to migrate our secret management to HashiCorp Vault, assuming services used environment variables uniformly. In reality, secrets were hard-coded across 60 legacy repositories in custom configuration files, requiring extensive code refactoring. I communicated the scope change transparently, built an automated secret scanning CLI tool to assist app teams, and successfully completed the complex migration in 8 weeks without disrupting ongoing feature delivery.
Follow-up 1. How did you build the automated secret scanning tool to locate hard-coded credentials without generating massive false positives?
Answer: I combined credential pattern matching with entropy analysis and repository context to prioritize likely secrets. I also excluded known test fixtures and approved dummy values, then routed uncertain matches for review rather than automatically treating every match as a credential. This gave us higher precision without hiding potentially valid findings.
Follow-up 2. How did you keep engineering leadership informed when your original timeline expanded from 3 weeks to 8 weeks?
Answer: I proactively published a revised milestone roadmap detailing the comprehensive repository audit findings. I then presented a phased migration plan to leadership that prioritized high-risk production services first, ensuring we maintained executive trust, transparency, and operational momentum throughout the extended 8-week project timeline.
Follow-up 3 curveball. A product manager refuses to allocate developer time for secret refactoring, stating it delays their quarterly roadmap. How do you handle it?
Answer: I would partner with the security lead to explain the compliance and credential exposure risks, and offer a supported migration path with reusable Vault integration templates. I would help their developers with the first migration and automate as much of the repetitive work as possible, while keeping ownership of their application changes with their team.
29. Tell me about a time you chose the wrong technology.
Answer: I initially selected a complex distributed key-value store to handle global API rate limiting, expecting massive, rapid-scale needs. However, managing cluster quorum, consensus overhead, and frequent node maintenance created severe operational toil for a relatively simple rate-limiting use case. I publicly acknowledged the architectural over-engineering, migrated our rate-limiting layer entirely to Redis, and reduced our platform's operational overhead significantly while maintaining strict latency requirements.
Follow-up 1. What operational friction metrics proved that the distributed key-value store was unsuited for your workload scale?
Answer: Our platform team was spending roughly 15 hours a month managing cluster node rebalances and chasing false positive quorum loss alerts. Meanwhile, our latency benchmarks showed that Redis delivered much faster lookup times at a fraction of the operational complexity and infrastructure cost for our specific needs.
Follow-up 2. How did you execute the live migration of rate-limiting state to Redis with zero drop in API protection?
Answer: I deployed a dual write transition layer, so new rate limit events were written to both systems, while we compared their counters and decisions. We ran the 2 implementations in parallel, monitored discrepancies, and only shifted enforcement fully to Redis after the results remained consistent under representative load. We then decommissioned the legacy cluster in a controlled sequence.
Follow-up 3 curveball. An engineer who advocated for the original key-value store resists decommissioning it, claiming it degrades future scale readiness. How do you respond?
Answer: I would review our measured scale requirements with them and show the load test results demonstrating that the Redis design has sufficient headroom for our projected peak traffic. I would acknowledge the future scale concern, but avoid paying today's operational cost for capacity we have not demonstrated we need.
30. Tell me about a time you missed an important requirement.
Answer: I built a fully automated self-service tool for developers to provision Kubernetes namespaces, but I missed a critical regulatory requirement for European data residency. The automated template defaulted all persistent volumes to U.S. cloud regions. Upon discovering the compliance oversight, I immediately paused multi-region provisioning, updated the tool to strictly enforce region-aware storage policies, and migrated the affected volumes to approved EU regions while preserving data integrity.
Follow-up 1. How did you discover the compliance oversight before regulatory auditors flagged the U.S. volume storage?
Answer: during a routine internal security architecture review, I proactively audited our storage volume region tags against active application deployment manifests. This allowed me to uncover the geographical discrepancy and remediate the issue internally before any external regulatory audit took place or resulted in fines.
Follow-up 2. What changes did you make to your platform design process to ensure compliance requirements are captured upfront?
Answer: I integrated a mandatory compliance and data sovereignty review step directly into our platform architectural request process. I also engineered robust policy as code templates utilizing Open Policy Agent that automatically block resource provisioning at the API level if developers select unapproved or non-compliant cloud regions.
Follow-up 3 curveball. Legal demands a complete shutdown of the self-service portal until a full external compliance audit is finished. How do you negotiate?
Answer: I would work with legal and security to define the approved operating boundary for the audit period. I would restrict the portal to pre-approved compliant templates and disable any configuration that has not been cleared, allowing compliant developer workflows to continue while the external audit proceeds.
31. Tell me about a failure that initially looked like someone else's fault but wasn't.
Answer: an application team's microservice was repeatedly hitting container memory limits, and we initially assumed their code had a severe memory leak. I investigated the runtime memory profile and found that our platform sizing template only accounted for the application's expected heap usage and did not provide enough headroom for native and off-heap allocations. I took responsibility for the platform side sizing error, corrected the resource recommendations, and restored stability for the affected services.
Follow-up 1. How did you prove that the platform sizing model was the true root cause?
Answer: I compared the application's heap usage with its total container memory consumption and found a significant gap outside the managed heap. Runtime memory profiling showed native and off-heap allocations were consuming the remaining headroom until the container hit its memory limit. That showed us the platform sizing model was too narrow for the runtime's actual memory profile.
Follow-up 2. How did you apologize to the application team and rebuild trust after initially blaming their application code?
Answer: I proactively attended their team stand-up, publicly acknowledged our platform misdiagnosis, and presented the corrected resource sizing model and memory findings. I then worked directly alongside their engineers to verify memory stability across their deployed services, rebuilding trust through transparency and joint validation.
Follow-up 3 curveball. The application team tech lead uses the incident to publicly criticize platform team competence in an engineering forum. How do you handle it?
Answer: I would absolutely not respond defensively in a public forum. I would reach out to the tech lead one-on-one, validate their frustration over the wasted debugging hours, and invite them to collaborate directly on our upcoming container template review board to ensure their perspective is integrated.
32. Tell me about something you would architect differently today.
Answer: early in our cloud migration, I architected our Terraform infrastructure as a single repository with large shared state boundaries across engineering teams. As we grew to 50 engineers, state lock contention and increasingly large plan graphs created deployment bottlenecks. Knowing what I know today, I would separate infrastructure into smaller, independently owned state boundaries while publishing reusable, versioned modules through a central registry. We eventually moved toward that model after a significant refactoring effort.
Follow-up 1. What technical bottlenecks emerged in state locking and plan execution times as team size grew to 50 engineers?
Answer: Terraform plan runs were taking more than 20 minutes because the shared configurations produced increasingly large resource graphs. Frequent state lock contention also prevented independent teams from applying infrastructure changes concurrently. The combination created significant deployment delays during peak engineering activity.
Follow-up 2. How did you execute the transition from the monolithic Terraform repository to decentralized version modules without breaking active pipelines?
Answer: we carefully refactored the massive state files incrementally using targeted Terraform state move commands. We deliberately isolated core network modules first, and then methodically onboarded application teams to the new versioned registry, templates one domain at a time to avoid pipeline disruption. 2. Daily business operations.
Follow up 3 curveball. A senior architect argues against decentralizing Terraform modules, claiming it increases module version fragmentation across teams. How do you respond?
Answer: I would acknowledge the real risk of version drift, then show how automated dependency pull requests, semantic versioning, and compatibility testing can keep module versions controlled and reviewable. The goal is not unrestricted decentralization. It is independent state ownership with a governed, reusable module layer.
Category 3. Key takeaways for platform engineers.
Before moving forward, here are the key takeaways from Category 3. 1. Blameless accountability. When you make a technical mistake, own it immediately and focus on the systemic fix rather than making excuses. 2. Adaptability over ego. If you choose the wrong technology or miss a requirement, pivot quickly based on data instead of defending a flawed design. 3. Platform humility. Assume platform sizing or tooling could be at fault before blaming application developers for unexpected system behavior. Now, let's transition to Category 4.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 3 to Category 4.
We just wrapped up Category 3, where the focus was entirely on admitting failures and learning from architectural mistakes. But building a resilient platform is meaningless if developers hate using it. That brings us to Category 4. We are shifting our mindset away from infrastructure incident rooms and focusing entirely on developer collaboration and developer experience.
Category 4, Developer Collaboration and Experience.
In Category 4, we cover developer experience, or DevEx. We will break down how to handle difficult engineering teams, overcome resistance to platform standards, build self-service golden paths with guardrails, and say no to requests without destroying your internal relationships.
Category 4, Developer Collaboration and Experience, the 12 questions you must know.
Here are the top 12 developer collaboration and experience questions that you are going to master in Category 4. 33. Tell me about a difficult developer team you had to support. 34. Tell me about a time developers resisted your platform solution. 35. Tell me about a time you had to understand a developer team's pain point before designing a solution. 36. Tell me about a time you improved developer productivity. 37. Tell me about a time you simplified a complicated developer workflow. 38. Tell me about a time you had to balance developer freedom with platform standards. 39. Tell me about a time a development team bypassed your platform. 40. Tell me about a time you convinced developers to adopt a new platform capability. 41. Tell me about a time you received negative feedback from developers. 42. Tell me about a time you had to say no to a development team's request. 43. Tell me about building or improving self-service capabilities with appropriate guardrails. 44. Tell me about measuring and improving developer satisfaction, or NPS, for the platform. Let's dive into question 33.
33. Tell me about a difficult developer team you had to support.
Answer. I supported a data science team that constantly requested custom infrastructure and complained about platform rigidity. Instead of fighting their requests, I embedded with their team for a sprint. I discovered our standard container templates lacked native GPU binding support, which severely slowed their model training. I collaborated with them to build a specialized machine learning golden path, reducing their wait times while keeping their workloads within our platform compliance boundaries.
Follow-up 1. How did you build the GPU binding template securely without allowing them to monopolize cluster resources?
Answer. I used Kubernetes device plugins for GPU scheduling and created a dedicated Helm-based golden path with explicit GPU resource requests, namespace quotas, and scheduling constraints. This allowed the team to access specialized hardware dynamically, while preventing a single workload from consuming the shared GPU capacity.
Follow-up 2. How did you handle the friction before the template was built, so the relationship did not completely deteriorate?
Answer. I stopped saying no exclusively through ticketing systems and established a weekly pairing session with their lead engineer. Shifting my posture from a strict gatekeeper to a collaborative partner quickly reduced the tension and helped us build mutual engineering trust.
Follow-up 3. Curveball. The team demands root access to the nodes because the new template is still too restrictive. How do you respond?
Answer. I would firmly deny root access to maintain our zero-trust security posture and cluster stability. However, I would immediately ask them to demonstrate the exact shell commands they are trying to execute, offering to safely package those specific capabilities into their automated pipeline.
34. Tell me about a time developers resisted your platform solution.
Answer: we rolled out a centralized CI and CD pipeline template to standardize deployments, but several product teams actively resisted, citing that the new pipeline doubled their build times. I investigated and realized our generic security scanning stages were downloading massive dependency trees sequentially. I acknowledged the friction publicly, parallelized the scanning steps, implemented layer caching, and ultimately reduced their build times below their original baseline.
Follow-up 1. How exactly did you optimize the scanning stages to eliminate the build time bottleneck?
Answer: I optimized the pipeline by reusing dependency and Docker build caches between runs and parallelizing independent security scans. We also avoided rebuilding unchanged layers and configured the scanners to reuse their vulnerability databases where supported. This reduced redundant work while preserving the required security coverage.
Follow-up 2. Why did not you catch the build time degradation before mandating the rollout across the entire organization?
Answer: we only tested the new pipeline template on small platform microservices, completely missing how it would perform on massive legacy monoliths. It was a failure in our rollout strategy, teaching me to always run pilot programs with our largest, most complex tenant applications first.
Follow-up 3. Curveball. A senior developer writes a widely circulated internal blog post calling your platform team a blocker. How do you handle it?
Answer: I would comment directly on the post, thanking them for raising the visibility. I would publicly acknowledge the valid build time issue, link directly to the active pull request fixing it, and use the opportunity to demonstrate that the platform team is responsive to feedback.
35. Tell me about a time you had to understand a developer team's pain point before designing a solution.
Answer: leadership directed our team to build a custom internal developer portal to improve developer onboarding times. Before writing any code, I interviewed engineers across multiple product teams. I discovered that onboarding was not their actual pain point. It was the tedious manual process of requesting cloud IAM roles, which often took days. I pivoted the project, built an automated IAM self-service workflow via Terraform, and significantly reduced the biggest source of onboarding friction.
Follow-up 1. How did you automate IAM role provisioning without violating strict security and least privilege boundaries?
Answer: I created a scoped Terraform module that only allowed developers to attach pre-approved, managed policies to their specific namespace roles. I paired this with automated policy as code checks that strictly blocked wildcards or administrative access before allowing the pull request to merge.
Follow-up 2. How did you convince leadership to abandon the developer portal project they specifically asked your team to build?
Answer: I presented the interview data, showing that a portal would just be a shiny interface over a broken underlying process. I calculated the cumulative engineering hours wasted on IAM tickets, proving that fixing the core workflow had a much higher return on investment for the business.
Follow-up 3. Curveball. Security audits the new IAM self-service tool and finds a team provisioned excessive permissions. They want to shut it down. What do you do?
Answer: I would immediately revoke the excessive policy, but strongly argue against shutting down the entire automation tool. Instead, I would work with security to identify the specific gap in our policy as code rules and add a new constraint to prevent that combination of permissions from passing again.
36. Tell me about a time you improved developer productivity.
Answer: our microservice bootstrapping process required developers to copy-paste boilerplate code, configure Helm charts manually, and submit separate IT tickets, taking days to get an application to production. I consolidated this workflow into a Backstage software catalog template. Developers could simply input a service name, and the template generated the repository, deployment pipeline, and Kubernetes manifests automatically, reducing bootstrap time to 20 minutes.
Follow-up 1. How did you ensure the generated code stayed compliant as platform security standards evolved over time?
Answer: I separated the generated application code from centrally maintained deployment components and used versioned Helm charts with an explicit upgrade path. New services received the current supported chart version automatically, while existing services could adopt newer versions through controlled dependency updates and validation.
Follow-up 2. How did you measure the actual productivity gain across the engineering organization to prove the tool's value?
Answer: I tracked lead time from repository creation to the first successful production deployment and compared the results with the pre-platform baseline. I also measured ticket volume and manual setup steps per service. Together, these metrics showed a substantial reduction in waiting time and repetitive onboarding work.
Follow-up 3. Curveball. A team wants to use a new programming language that your Backstage template does not support yet. How do you respond?
Answer: I would explain that our golden paths currently support our core languages to guarantee operational readiness and security scanning. I would encourage them to prototype the service independently, and if the language proves valuable, collaborate with them on building a fully supported template.
37. Tell me about a time you simplified a complicated developer workflow.
Answer: developers were struggling with local Kubernetes testing, often scripting their own port forwards and managing local clusters, which created configuration drift and environment discrepancies. I replaced that workflow with an automated remote development environment using isolated per-developer namespaces. Developers could edit code locally, while changes were synchronized into their remote environment with automatic rebuilds and reloads, reducing the need to manage local clusters.
Follow-up 1. How did you prevent these remote development namespaces from consuming excessive cloud compute costs?
Answer: I implemented automatic environment suspension based on inactivity, rather than treating every workload the same. Stateless deployments were scaled down, while persistent resources followed separate lifecycle policies. The environment controller restored the required workloads when the developer returned, significantly reducing idle compute consumption.
Follow-up 2. Why did not you just standardize the local cluster setup instead of moving the workload to the cloud?
Answer: local Kubernetes environments were consuming significant CPU and memory on developer laptops and created frequent differences between local and deployed configurations. The remote environment gave developers a standardized runtime closer to our deployed platform, while freeing local resources for editing and compilation.
Follow-up 3. Curveball. The remote development cluster goes down, and developers complain they are completely blocked from writing code. How do you mitigate this dependency?
Answer: I would acknowledge the single point of failure and communicate the immediate recovery timeline transparently. Long-term, I would ensure our platform still provides a fallback container compose workflow so developers can test core business logic locally when cloud environments are temporarily unavailable.
38. Tell me about a time you had to balance developer freedom with platform standards.
Answer: we enforced a strict platform standard, requiring applications to use our managed database offering. However, a data engineering team requested an unsupported graph database for a critical feature. Instead of rigidly blocking them, I established a paved road versus off-road model. I granted them the infrastructure freedom they needed, provided they explicitly accepted operational ownership, PagerDuty, and disaster recovery responsibilities for that specific data store.
Follow-up 1. How did you monitor the security and compliance of an infrastructure component your team did not actively manage?
Answer: we required their custom deployment to hook into our standard platform observability and security scanning modules, even though they managed the database engine independently. Our automated compliance checks still rigorously audited their network policies and encryption at rest configurations to ensure enterprise compliance.
Follow-up 2. Did this exception create a flood of other teams asking to bypass platform standards and run custom infrastructure?
Answer: no, because we made the operational requirements for going off-road intentionally rigorous. Once other product teams realized they would have to take on round-the-clock on-call responsibilities for custom infrastructure, the vast majority happily chose our supported, fully managed golden paths.
Follow-up 3. Curveball. 6 months later, the data team's custom database crashes, and they escalate to your platform team for help. What do you do?
Answer: I would immediately jump on the incident bridge to help them restore service, using my general infrastructure expertise to assist. During the postmortem, I would gently reiterate our operational boundaries and help them review their disaster recovery processes to prevent a recurrence.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
39. Tell me about a time A development team bypassed your platform.
Answer: I discovered a product team had bypassed our centralized ingress controller and manually provisioned cloud load balancers to route traffic to their service. They bypassed the platform because our standard ingress pipeline required a manual security review that took days. I worked with security to automate those review checks into our CI pipeline, brought the team's service back behind our ingress, and permanently eliminated the bottleneck.
Follow-up 1. What specific security controls were they bypassing by provisioning their own public load balancers?
Answer: by routing around the standard ingress, they bypassed our centralized web application firewall, edge threat protection controls, standardized TLS handling, and network policy enforcement. That meant the service was operating outside several controls required by our platform's security baseline.
Follow-up 2. How did you approach the team without sounding like you were just policing their infrastructure choices?
Answer: I approached them with curiosity rather than authority. I asked them exactly why our platform failed their delivery timeline, validated their frustration over the manual delays, and partnered with them to fix the underlying platform friction rather than just deleting their cloud resources.
Follow-up 3. Curveball. The team refuses to migrate back to the platform ingress, stating their custom setup is already in production and working fine. What do you do?
Answer: I would clearly document the severe security and compliance risks of their unmanaged setup and escalate to engineering leadership for a formal risk acceptance decision. If leadership accepts the risk, I step back. If they do not, leadership mandates the migration.
40. Tell me about a time you convinced developers to adopt a new platform capability.
Answer: we introduced a modern tracing library that provided deep insights into microservice latency. But adoption stalled because developers resisted refactoring their codebases. Instead of pushing top-down mandates, I selected a single high-visibility application struggling with performance issues. I submitted a pull request to instrument their service, used the traces to identify a massive database bottleneck, and let that success story drive organic adoption across the company.
Follow-up 1. How did you minimize the code refactoring required for teams to adopt the tracing library?
Answer: I packaged the common tracing configuration into a standard platform library and provided framework-specific integrations where possible. Application teams only needed a small initialization change, while the platform handled exporter configuration, sampling defaults, and common metadata. This kept the application-side adoption effort small, without hiding the operational controls.
Follow-up 2. How did you measure the success of the adoption campaign beyond just counting integrated services?
Answer: I tracked the reduction in mean time to resolution for performance-related incidents. As more teams adopted the tracing capability, we saw a highly measurable decrease in engineering time spent isolating latency bottlenecks across distributed service boundaries.
Follow-up 3. Curveball. A team adopts the tracing library but misconfigures it, sending massive amounts of span data that threatens to max out your observability licensing cost. How do you handle it?
Answer: I would immediately apply collector-side sampling and rate controls to protect the observability budget while preserving error and high latency traces. I would then work with the team to identify the noisy instrumentation, tune sampling, and exclude low-value telemetry such as repetitive health checks.
41. Tell me about a time you received negative feedback from developers.
Answer: after we rolled out strict policy as code deployment checks, developers complained that the error messages from the policy engine were cryptic, causing them to waste hours debugging rejected deployments. I took this feedback seriously, intercepted the policy engine output, and rewrote the pipeline step to provide human-readable errors with direct links to our internal documentation explaining exactly how to fix the specific violation.
Follow-up 1. What technical mechanism did you use to translate cryptic policy engine output into developer-friendly feedback?
Answer: I wrote a custom webhook service that parsed the raw JSON violations from the policy engine. It mapped specific constraint IDs to customized markdown templates and posted the formatted, highly actionable feedback directly as a comment on the developer's pull request.
Follow-up 2. How did you follow up with the developers to see if your fix actually resolved their frustration?
Answer: I organized a targeted focus group with the most vocal critics from the survey. I walked them through the new error formatting, gathered live feedback, and actively tracked a sharp decrease in support channel questions related to deployment rejections over the next month.
Follow up 3 curveball. A developer tells you that even with clear errors, the policies are simply too restrictive, and they want to bypass them entirely. How do you respond?
Answer: I would ask them for a specific example of a valid engineering workflow being blocked by our policies. If the policy is genuinely overly broad, I would adjust the rule. If it enforces a non-negotiable security standard, I would clearly explain the risk justification.
42. Tell me about a time you had to say no to a development team's request.
Answer: a product team requested that we add a highly specialized NoSQL database engine to our officially supported platform catalog. After evaluating the request, I had to say no because we lacked the operational expertise to maintain it reliably at scale. I explained that supporting it would divert resources from our core reliability initiatives, but I offered to help them provision it in an isolated account under a self-managed model.
Follow up 1. What specific criteria did you use in your evaluation to determine that the platform team could not support the database?
Answer: I evaluated the database against our operational readiness checklist, looking at high availability patterns, backup automation tooling, and our team's existing skill sets. The specialized engine lacked mature Kubernetes operators, meaning it would introduce massive manual toil for our on-call engineers.
Follow up 2. How did you deliver the no without alienating the product team or making them feel completely unsupported?
Answer: I delivered the decision in a live meeting rather than a cold ticket update. I validated their technical use case, transparently shared our team's capacity constraints, and focused the conversation on enabling them to self-manage the tools safely rather than just blocking them.
Follow up 3 curveball. The product team escalates your no to the CTO, arguing that their feature will generate significant revenue and strictly requires platform support. How do you handle the executive pressure?
Answer: I would present my operational readiness assessment to the CTO, outlining the hidden maintenance costs and reliability risks of supporting the tool. I would ask the CTO to prioritize this against our current roadmap, adjusting our team's capacity if it becomes a business imperative.
43. Tell me about building or improving self-service capabilities with appropriate guardrails.
Answer: developers were frustrated by waiting days for cloud infrastructure to be provisioned via ticketing. I led the development of a self-service Terraform module library that allowed teams to provision their own databases and caches. To keep the self-service model safe, I embedded guardrails into the modules, restricting instance sizes, enforcing private networking, and requiring automated backup metadata. This empowered developers while keeping infrastructure compliant.
Follow up 1. How did you ensure developers could not just modify the Terraform modules locally to bypass your embedded guardrails?
Answer: I restricted direct infrastructure provisioning permissions, so developers could not apply Terraform from arbitrary local environments. Deployments had to pass through our controlled CI and CD path, where policy as code validated networking, instance sizing, encryption, and required metadata. The versioned module registry provided the supported building blocks, while the policy layer enforced the non-negotiable guardrails.
Follow up 2. How did you handle existing legacy infrastructure that did not match the new self-service guardrail standards?
Answer: we adopted a forward-looking enforcement strategy. We applied the strict guardrails to all newly provisioned resources immediately, and then worked closely with teams to retroactively audit and migrate their legacy infrastructure to the new modules over a 3-month transition period.
Follow up 3 curveball. A developer complains that your guardrails are too rigid because they need a larger database instance size that the module blocks. What is your process for handling this?
Answer: I would review their performance telemetry to confirm the actual resource bottleneck. If the larger size is genuinely required, I would update the module's approved size range through the normal review process or grant a scoped, temporary policy exception through a tracked, architectural decision record.
44. Tell me about measuring and improving developer satisfaction for the platform.
Answer: when I joined the platform team, we had no consistent way to measure developer experience. I introduced a short quarterly developer satisfaction survey alongside operational metrics such as build time, deployment frequency, and support ticket volume. The results showed that local development performance was a major source of friction, which we validated against our build telemetry. We prioritized remote caching, measured the improvement against the baseline, and saw both build times and developer satisfaction improve.
Follow-up 1. Why did you combine qualitative survey data with quantitative system metrics, like build times?
Answer: surveys explain how developers experience the platform, but they are subjective and can be influenced by recent incidents. Quantitative telemetry gives us behavioral evidence such as build time, deployment frequency, and support volume. Using both lets us identify whether reported friction corresponds to a measurable platform bottleneck before prioritizing engineering work.
Follow-up 2. How did you ensure developers actually took the time to fill out the surveys thoughtfully?
Answer: we kept the survey short, ran it on a predictable quarterly cadence, and made responses easy to submit without interrupting engineering workflows. We also published what we learned and the actions we were taking from the previous survey, showing developers that feedback resulted in visible changes was the biggest factor in maintaining meaningful participation.
Follow-up 3. Curveball. Your latest survey returns terrible scores, and developers leave comments saying the platform team is totally disconnected from their reality. How do you respond to this harsh feedback?
Answer: I would share the results openly with the platform team and leadership, rather than becoming defensive. I would run focused listening sessions with the teams reporting the strongest friction, identify the top recurring problems, and rebalance our roadmap toward those issues where the data shows the greatest developer impact. I would then publish measurable improvement targets and track them in the next survey cycle.
Category 4. Key takeaways for platform engineers.
Before moving forward, here are the key takeaways from Category 4. 1. Platform as a product. Always interview developers and understand their underlying pain points before building new platform capabilities. 2. Paved roads over mandates. Drive platform adoption through low-friction golden paths rather than top-down executive mandates. 3. Empathy and feedback. Transform cryptic error messages and negative developer feedback into clear, actionable platform improvements. Now, let us transition to Category 5.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire master vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 4 to Category 5.
We just wrapped up Category 4, where the focus was on developer experience and building collaborative platform tools. But even the best developer experience leads to heated friction when architectural visions clash across teams. That brings us to Category 5. We are stepping out of product design and entering the meeting room to navigate conflict, technical disagreements, and organizational politics.
Category 5. Conflict and Technical Disagreement.
In Category 5, we cover conflict and technical disagreements. We will break down how to handle architectural opposition, resolve conflicting team requirements, manage pushback from managers, handle organizational politics, and change your own technical stance when presented with superior data.
Category 5. Conflict and Technical Disagreement. The 10 questions you must know.
Here are the top 10 conflict and technical disagreement questions that you are going to master in Category 5. 45. Tell me about a technical disagreement with another engineer. 46. Tell me about a disagreement with an application team. 47. Tell me about a disagreement with your manager. 48. Tell me about a time someone strongly opposed your architecture. 49. Tell me about a time you had to convince others to change their approach. 50. Tell me about a time you changed your position after hearing another engineer's argument. 51. Tell me about a situation where 2 teams wanted incompatible platform capabilities. 52. Tell me about a time organizational politics affected a technical decision. 53. Tell me about a time you had to choose between 2 strong technical opinions. 54. Tell me about a time you had to work with someone you strongly disagreed with. Let's dive into question 45.
45. Tell me about a technical disagreement with another engineer.
Answer. A senior front-end engineer advocated for a micro front-end architecture for our developer portal, while I favored a monolithic application to minimize operational complexity. Rather than debating theoretical principles in meetings, I proposed a short spike where we benchmarked build pipelines, deployment overhead, and bundle sizes. The data showed micro front-ends added substantial build complexity for our current team size, So we agreed on a modular monolith with clear domain boundaries.
Follow-up 1. How did you design the benchmarking spike to ensure fair criteria that both of you agreed on upfront?
Answer: we defined 3 explicit evaluation metrics together before writing any code: pipeline build time, local environment setup complexity, and production deployment risk. Agreeing on the evaluation framework beforehand ensured we evaluated the spike objectively rather than fighting over opinions.
Follow-up 2. How did you preserve your working relationship after proving that their proposed architecture introduced unnecessary complexity?
Answer: I framed the outcome as a shared discovery rather than a personal victory. I explicitly credited them for highlighting front-end modularity, and we incorporated their domain-driven architectural patterns directly into our monolithic application design.
Follow-up 3. Curveball. The engineer refuses to accept the benchmark results, claiming your criteria were biased toward monolithic setups. How do you resolve this impasse?
Answer: I would invite a neutral staff engineer to review our benchmarking methodology and test data. If the peer still holds their stance, I would propose a modular monolith with explicit domain boundaries and well-defined interfaces, preserving an architectural path to split selected domains later, if the scale or organizational needs justify micro frontends.
46. Tell me about a disagreement with an application team.
Answer: an application team demanded a dedicated Redis cluster for their new service, arguing that a multi-tenant shared cluster introduced noisy neighbor risks. My platform team wanted to maintain multi-tenancy to minimize cloud costs and operational sprawl. I met with their tech lead, reviewed their throughput requirements, and created a dedicated instance policy specifically for workloads exceeding high throughput thresholds. This satisfied their isolation need, while establishing clear criteria for future exceptions.
Follow-up 1. What specific performance and throughput metrics did you define to govern when a team qualifies for a dedicated cluster?
Answer: we established an explicit threshold requiring a service to demonstrate sustained throughput exceeding 10,000 operations per second, or a documented sub-millisecond latency requirement under its production workload. Services below those telemetry thresholds were required to use our managed multi-tenant Redis clusters.
Follow-up 2. How did you prevent other application teams from using this compromise as a precedent to demand dedicated clusters unnecessarily?
Answer: I published the dedicated cluster criteria transparently in our platform architecture RFCs. Whenever other teams requested dedicated resources, we pointed directly to their live telemetry metrics, showing whether their service met the objective threshold required for an exception.
Follow-up 3. Curveball. The application team provisions a dedicated Redis cluster directly in their cloud account without telling you, bypassing the evaluation framework. How do you handle it?
Answer: I would not delete the resource immediately during an active release. I would reach out to their tech lead to understand the urgency, explain that unmanaged data stores lack platform backup and security monitoring, and help them bring the cluster under platform management through a formal exception.
47. Tell me about a disagreement with your manager.
Answer: my manager wanted us to manually migrate 50 microservices to a new Kubernetes cluster over a weekend to meet an executive milestone. I strongly disagreed because manual migrations created significant human error risk and were difficult to repeat consistently. I demonstrated that writing automated migration tooling would take 3 extra days upfront, but dramatically reduce execution effort and improve repeatability. My manager agreed to adjust the schedule, and we completed the migration through controlled waves without customer impacting downtime.
Follow-up 1. How did you present the timeline trade-offs to your manager without sounding like you were refusing their deadline?
Answer: I avoided saying no directly. Instead, I presented a risk comparison matrix showing the high probability of human error during a manual weekend push versus the predictable, repeatable nature of scripted automation, framing it as protecting their commitment to leadership.
Follow-up 2. What fallback plan did you put in place in case your automated migration scripts failed during the actual rollout window?
Answer: we built automated validation and rollback gates into the migration workflow. Each service was validated through health checks and synthetic transactions before progressing to the next migration wave, with traffic routing able to return to the previous cluster if validation failed. This gave us a controlled exit path throughout the rollout.
Follow-up 3 curveball. Your manager listens to your risk presentation, but still orders you to execute the manual migration over the weekend anyway. What do you do?
Answer: I would respect their decision as a manager, but take steps to mitigate the risk. I would write a detailed step-by-step checklist, organize peer verification pairs for every manual step, and document the agreed risk profile in our incident response channel before starting.
48. Tell me about a time someone strongly opposed your architecture.
Answer: a principal architect strongly opposed my proposal to introduce a service mesh for MTLS and traffic splitting, arguing that sidecar resource overhead was unacceptable. Instead of arguing in architecture review meetings, I scheduled a dedicated deep dive. I presented benchmarking data showing our workload latency impact was negligible and offered to run a limited canary pilot on non-critical services. This incremental approach addressed their risk concerns and secured their approval.
Follow-up 1. What specific telemetry metrics did you measure during the canary pilot to prove sidecar overhead was within acceptable limits?
Answer: I measured 99th percentile request latency, CPU usage per proxy container, memory consumption, and error rates under representative load. We compared the canary workloads against equivalent services without the mesh, and found that the proxy overhead remained within the latency and resource budgets we had agreed on beforehand.
Follow-up 2. How did you keep the conversation focused on objective architectural trade-offs rather than hierarchy or authority during the review?
Answer: I anchored every discussion strictly around empirical data and risk isolation by focusing on measurable metrics like latency and proposing a low-risk canary rollout. I removed emotion and authority from the evaluation process.
Follow-up 3 curveball. During the canary pilot, a minor latency spike occurs. The principal architect uses it to demand an immediate cancellation of the service mesh project. How do you respond?
Answer: I would agree to pause the rollout to investigate. I would analyze the distributed traces to determine if the spike was caused by sidecar proxy configuration or an underlying network issue, presenting the transparent root cause analysis to the architect before deciding next steps.
49. Tell me about a time you had to convince others to change their approach.
Answer: product teams were accustomed to SSing directly into production instances to inspect raw log files, which violated security controls and created operational risk. I had to convince 10 engineering leads to adopt centralized logging. Rather than relying only on security mandates, I demonstrated how centralized search, structured fields, and correlation IDs allowed them to investigate failures across multiple services without accessing individual hosts. Showing the reduction in debugging effort helped the teams voluntarily move away from direct SSH access.
Follow-up 1. How did you handle edge cases where centralized logging lacked specific low-level system logs that developers relied on?
Answer: I partnered with those teams to configure host-level log agents that collected the specialized system logs they depended on and routed them into the central platform. This preserved access to the required low-level information without requiring engineers to access production hosts directly.
Follow-up 2. How did you track the adoption curve across teams to know when it was safe to permanently revoke SSH permissions?
Answer: I monitored active SSH session metrics per server alongside log platform query volumes per team. Once telemetry showed teams were actively utilizing the central platform for daily debugging, we scheduled the formal revocation of SSH keys with security.
Follow-up 3 curveball. A senior developer bypasses central logging and uses a backdoor script to tail live production logs during a critical release. How do you handle it?
Answer: I would prioritize keeping the release stable and avoid confronting the developer publicly during the incident. After the release, I would speak with them privately to understand what gap in the central logging platform forced them to use the backdoor script. I would then address that limitation, while separately reinforcing the approved production access policy.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
50. Tell me about a time you changed your position after hearing another engineer's argument.
Answer: I initially advocated for Pulumi because I believed allowing developers to use TypeScript would improve infrastructure adoption. A senior platform engineer presented evidence that our existing Terraform ecosystem already had mature policy as code controls, standardized modules, established review workflows, and stronger team familiarity. I recognized that introducing a new IAC ecosystem would create unnecessary operational and governance overhead, changed my position publicly, and backed the Terraform standardization.
Follow-up 1. What specific pipeline security, auditing limitations in Pulumi convinced you that Terraform HCL was safer for your platform?
Answer: they showed that our existing Terraform pipeline already had mature policy checks, module standards, security scanning, and review workflows integrated into the deployment process. Replicating that governance model for a second IAC ecosystem would have created additional maintenance and policy coverage overhead. That organizational and operational evidence was what changed my position.
Follow-up 2. How did you communicate your change of stance to the engineering team without losing credibility as a technical lead?
Answer: I addressed the team openly in our architecture forum. I explained the exact security and static analysis trade-offs the peer highlighted, demonstrating that changing one's mind in the face of superior technical evidence is a strength, not a weakness.
Follow-up 3. Curveball. Developers expressed disappointment over your decision, claiming TypeScript IAC was the main feature they were excited about. How do you address their feedback?
Answer: I would validate their enthusiasm for TypeScript and acknowledge that developer ergonomics matter. I would explain that the decision was based on our existing governance and operational maturity, rather than claiming TypeScript IAC is inherently inferior. I would then invest in higher-level Terraform modules and self-service interfaces, so developers still get a simple experience.
51. Tell me about a situation where two teams wanted incompatible platform capabilities.
Answer: our security team demanded read-only container file systems across all production pods, while the SRE team needed temporary write access for diagnostic tooling during live incidents. The two requirements were directly incompatible. I mediated by designing an ephemeral break glass debugging workflow using Kubernetes ephemeral containers. This allowed SREs to attach dynamic diagnostic sidecars on demand, without ever altering the underlying immutable application container images.
Follow-up 1. How did you audit and log the break glass debugging sessions to satisfy security's compliance requirements?
Answer: I enabled Kubernetes API audit logging, so every ephemeral container request recorded the requesting identity, target workload, timestamp, and authorization decision. We also required the debugging container to use approved images and routed host or session-level audit telemetry through our existing security tooling, where command-level accountability was required.
Follow-up 2. How did you validate that ephemeral containers did not introduce secondary security vulnerabilities on host worker nodes?
Answer: we restricted ephemeral container capabilities using pod security standards, ensuring attached debugging sidecars could not run as root or access underlying host namespaces without explicit, time-bound security overrides.
Follow-up 3. Curveball. Security insists that even ephemeral containers create an unacceptable attack surface and demands a 24-hour approval delay for break glass access. How do you negotiate?
Answer: I would explain that a 24-hour approval delay destroys incident response MTTR during SEV1 outages. I would propose automated, pre-approved break glass access that requires dual authorization from an on-call manager during active incidents instead.
52. Tell me about a time organizational politics affected a technical decision.
Answer: an executive championed adopting a costly commercial observability vendor due to enterprise relationship ties, even though our open-source Prometheus setup met all technical requirements. Realizing a direct confrontation would fail, I focused on technical integration feasibility. I conducted an objective evaluation showing the SaaS vendor lacked support for our multi-cloud deployment architecture. By focusing strictly on technical compatibility rather than politics, I helped leadership choose a hybrid model that preserved our core architecture.
Follow-up 1. How did you maintain professional neutrality when writing the evaluation report for an executive's favored vendor?
Answer: I focused purely on verifiable facts, benchmarks, and integration matrices. I highlighted the vendor's genuine strengths in high-level executive dashboards, while objectively documenting the technical gaps in multi-cloud telemetry ingestion.
Follow-up 2. How did you structure the hybrid observability model so it did not double your team's maintenance overhead?
Answer: we kept Prometheus-based collection and alerting for core infrastructure and service telemetry, while forwarding selected aggregated telemetry to the commercial platform for the executive dashboards and use cases it supported well. This kept our core operational workflows independent while still making use of the vendor investment.
Follow-up 3. Curveball. The executive ignores your technical evaluation and signs the vendor contract anyway. How do you adapt your platform strategy?
Answer: I would accept the business decision professionally. I would focus my team on building automated telemetry pipelines to feed the vendor tool cleanly, ensuring we minimize maintenance toil while maximizing the value of the executive investment.
53. Tell me about a time you had to choose between two strong technical opinions.
Answer: our platform team was split down the middle between Argo CD and Flux for our GitOps engine, with senior engineers passionately defending both tools. To break the deadlock, I established a multi-weighted decision framework focused on RBAC granularity, multi-cluster management, and UI visibility for application developers. I assigned team members to evaluate both tools against these exact criteria in staging. After scoring both tools against the agreed weighting, Argo CD produced the stronger overall result for our platform requirements, particularly around developer-facing visibility and operational workflows. The evidence gave the team a defensible decision, rather than leaving the choice to individual preference.
Follow-up 1. What specific developer UI capabilities in Argo CD tipped the balance over Flux during your evaluation?
Answer: Argo CD provided a visual, real-time resource dependency tree and direct sync status visibility that allowed application developers to self-diagnose deployment failures without needing cluster-level kubectl permissions.
Follow-up 2. How did you keep the team aligned and motivated after one group's favored tool was rejected?
Answer: I publicly commended the Flux advocates for their thorough evaluation work. I involved them directly in leading the Argo CD architecture rollout, ensuring their deep GitOps knowledge was fully utilized in designing our production delivery pipelines.
Follow-up 3. Curveball. The lead engineer who championed Flux threatens to leave the platform team because their technical recommendation was overridden. How do you handle it?
Answer: I would have a private one-on-one to validate their expertise. I would explain that the decision was driven by developer experience requirements rather than technical superiority, and offer them ownership of key architectural components in our new GitOps pipeline.
54. Tell me about a time you had to work with someone you strongly disagreed with.
Answer: I was paired with a principal SRE on a cloud migration who strongly preferred writing custom bash scripts over using Terraform modules. Our technical philosophies were completely opposite. Rather than fighting over methodology, I agreed on clear boundary deliverables. I wrote the foundational Terraform infrastructure modules, while they wrote the host-level bootstrap scripts. By focusing on API contracts between our components rather than personal styles, we delivered the migration successfully.
Follow-up 1. How did you ensure their custom bash bootstrap scripts were maintainable and testable by the rest of the team?
Answer: I convinced them to integrate shell checklinting and automated unit testing into our CI pipeline, ensuring their bash scripts met strict quality, error handling, and documentation standards before execution.
Follow-up 2. What did you learn from working with this engineer that improved your own approach to system automation?
Answer: I gained a deeper appreciation for lightweight host-level bootstrapping. When Terraform abstractions become overly complex, it taught me to evaluate low-level tooling pragmatically rather than insisting on infrastructure as code for every edge case.
Follow-up 3. Curveball. Mid-migration, one of their bash scripts fails silently in production, causing node drift. How do you handle the situation without saying "I told you so"?
Answer: I would focus entirely on fixing the production incident alongside them. Post-incident, I would collaboratively add explicit error handling, strict shell execution settings, structured logging, automated tests, and telemetry alerts to the script so future failures become visible quickly. I would treat the incident as a shared engineering improvement, rather than an opportunity to revisit our earlier tooling disagreement.
Category 5. Key takeaways for platform engineers.
Before moving forward, here are the key takeaways from Category 5. Data over debate. Use objective spikes, telemetry benchmarks, and POCs to resolve technical arguments rather than debating theoretical preferences. Empathy for boundaries. Respect domain ownership and application requirements, while protecting core platform security and compliance boundaries. Pragmatic compromise. Choose operational safety, business continuity, and developer flow over personal technical preferences or architectural purity. Now, let us transition to Category 6.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 5 to Category 6.
We just wrapped up Category 5, where the focus was entirely on navigating technical disagreements, architectural opposition, and organizational politics. But winning technical arguments is pointless if nobody adopts what you build. That brings us to Category 6. We are stepping out of the debate room and adopting a product manager mindset to treat our infrastructure as a product and our developers as customers.
Category 6. Developer Demand Platform as a product and internal developer portals.
In Category 6, we cover platform as a product and internal developer portals. We will break down how to gather user feedback, drive platform adoption, measure non-technical success metrics, prioritize features under capacity constraints, and reduce developer cognitive load through single pane of glass portals.
Category 6. Platform as a product and IDPs, the 14 questions you must know.
Here are the top 14 platform as a product and developer portal questions that you are going to master in Category 6. 55. Tell me about a platform capability you built based on developer demand. 56. Tell me about a platform feature that nobody wanted to use. 57. Tell me about a time platform adoption was lower than expected. 58. Tell me about a time you measured the success of a platform beyond pure technical metrics. 59. Tell me about a time you prioritized one platform feature over another. 60. Tell me about a time you gathered requirements from platform users. 61. Tell me about a time you reduced developer cognitive load. 62. Tell me about a time you created or improved a golden path. 63. Tell me about a time you treated an infrastructure capability like a product. 64. Tell me about a time you had to balance platform standardization with developer flexibility. 65. Tell me about designing effective guardrails or policy as code that developers didn't hate. 66. Tell me about reducing cognitive load through better abstractions, documentation, or templates. 67. Tell me about your experience rolling out or driving adoption of an internal developer portal, IDP, or service catalog. 68. Tell me about a time you consolidated fragmented documentation, scaffolding, and operational metrics into a single developer pane of glass. Let's dive into question 55.
55. Developer demand.
Answer. Developers expressed frustration over managing complex, multi-environment preview setups for front-end pull requests. Based on this direct user feedback, we built an automated preview environment platform integrated into GitHub Actions. Whenever a pull request is opened, our platform provisions an ephemeral namespace with isolated ingress and synthetic test data, allowing developers to share live previews with product managers before merging code.
Follow-up 1. How did you engineer the ephemeral namespace cleanup mechanism so inactive preview environments did not bloat cloud costs?
Answer. We built a lightweight controller that monitored pull request state. When a pull request was merged or closed, or if the preview remained idle for more than 2 hours, the controller automatically deleted the ephemeral namespace and reclaimed cloud resources.
Follow-up 2. How did you validate that this developer requested capability actually improved engineering velocity?
Answer. We tracked pull request review cycle time before and after the rollout across 20 product teams. Review turnaround decreased by roughly 30%, and developer interviews confirmed that product managers were able to validate UI changes directly from the preview links instead of requiring local setup. We used both the telemetry and user feedback to assess the impact.
Follow-up 3. Curveball. Security flags that preview environments expose unauthenticated staging APIs to the public internet. How do you handle this security risk?
Answer. I would immediately restrict public access to the preview environments and preserve access only for authenticated users. I would then update the preview platform to enforce centralized identity-aware access controls, Isolate preview data from production data, and add automated security validation before a preview. Environment becomes externally reachable.
56. Tell me about a platform feature that nobody wanted to use.
Answer: we spent 2 months building a custom CLI tool designed to help developers inspect pod logs and restart services directly from their terminal. However, adoption was near zero because developers preferred using their existing IDE plugins and terminal tools. Instead of forcing adoption through mandates, I acknowledged the product market fit failure, sunsetted the CLI tool, and refactored our efforts into building light plugins for the IDEs developers were already using.
Follow-up 1. Why did your team spend 2 months building a feature without realizing developers would reject the CLI interface?
Answer: we relied on assumptions from senior platform engineers rather than conducting early developer interviews. We made the classic mistake of building what we thought was cool instead of observing actual developer workflows in their day-to-day environments.
Follow-up 2. How did you present this sunset decision to engineering leadership without making the project look like a complete waste of resources?
Answer: I presented a transparent postmortem showing near zero active usage and explained why the interface had failed to match developer workflows. I also demonstrated that a large portion of the underlying API and service logic could be reused in the new IDE integrations. So the engineering investment was not discarded even though the original product direction was wrong.
Follow-up 3. Curveball. An executive who funded the CLI project demands that you mandate its use to justify the investment. How do you respond?
Answer: I would present our user retention metrics and explain that forcing an unwanted CLI will increase developer frustration and reduce productivity. I would demonstrate how integrating the same backend logic into IDEs delivers the executive's vision while respecting developer workflows.
57. Tell me about a time platform adoption was lower than expected.
Answer: we launched a new automated database migration tool, but 3 months post-launch, only 15% of application teams had adopted it. I conducted user feedback sessions and discovered that developers found our configuration documentation confusing and feared the automated tool would corrupt production databases. I restructured the onboarding documentation, recorded video walkthroughs, and offered pair programming sessions for first-time migrations, which drove adoption to 80% within 2 quarters.
Follow-up 1. What specific safety features did you add to the migration tool to address developers' fear of database corruption?
Answer: we added a dry run mode that showed the planned schema changes before execution and automatically verified that required backups or snapshots existed before production changes were allowed. We also validated migration and recovery procedures in staging using production-like schemas, giving developers evidence that the workflow had a controlled recovery path.
Follow-up 2. How did you incentivize hesitant application teams to prioritize migrating to the new tool over their regular feature work?
Answer: I partnered with engineering directors to establish technical health goals. We showed team leads how the tool could reduce recurring manual migration work and give developers a safer, repeatable workflow, making the one-time onboarding effort worthwhile compared with the ongoing cost of manual migrations.
Follow-up 3. Curveball. A critical application team flatly refuses to adopt the tool, claiming their legacy schema is too unique for automated migrations. How do you handle it?
Answer: I would offer to pair with their lead engineer on a migration dry run in staging. If their schema exposes genuine tool limitations, I would update the platform engine to handle those edge cases before asking them to migrate.
58. Tell me about a time you measured the success of a platform beyond pure technical metrics.
Answer: historically, our platform team only measured technical metrics like uptime and build speed, which failed to reflect actual business value. I established a balanced scorecard tracking developer lead time, onboarding duration, support ticket resolution time, and developer satisfaction scores. Correlating these product-level metrics with our technical SLOs gave us clear visibility into developer experience, allowing us to prioritize features that directly reduced cognitive load and waiting friction.
Follow-up 1. How did you instrument your platform pipelines to track developer lead time accurately from commit to production?
Answer: we integrated deployment events from version control, CI and CD, artifact repositories, and production deployment systems. Each change was associated with its commit or change identifier and linked to the resulting build artifact and deployment events. This allowed us to calculate lead time from the change being committed through its first successful production deployment.
Follow-up 2. How did you use these developer experience metrics to defend your team's quarterly budget and staffing requests to leadership?
Answer: I presented data showing that reducing onboarding lead time from 5 days to 2 hours saved thousands of engineering hours annually. I framed platform investment in terms of engineering capacity, unlocked rather than server infrastructure costs.
Follow-up 3. Curveball. Leadership demands that you tie platform success directly to company revenue growth. How do you handle this expectation?
Answer: I would explain that platform engineering usually influences revenue indirectly, rather than owning revenue directly. I would connect platform metrics to measurable business outcomes such as faster feature delivery, shorter experimentation cycles, and reduced engineering waiting time, while avoiding claims that platform improvements alone caused revenue growth.
59. Tell me about a time you prioritized one platform feature over another.
Answer: our platform team had to choose between building automated multi-region failover and a self-service Redis caching catalog. Developer feedback showed that manual caching setup was creating frequent daily delays, while our existing single-region recovery process still met the current RTO and RPO requirements for the affected services. I prioritized the caching catalog first because it removed a recurring developer bottleneck without immediately violating our reliability objectives. We then scheduled the multi-region initiative as the next major reliability investment.
Follow-up 1. What prioritization framework did you use to evaluate user friction against long-term reliability infrastructure?
Answer: I used RICE to quantify developer reach, impact, confidence, and engineering effort, but I applied reliability requirements as a separate constraint. The caching catalog scored strongly on immediate developer impact, while the multi-region work remained mandatory once required RTO and RPO targets could no longer be met by the existing architecture.
Follow-up 2. How did you communicate this prioritization decision to senior architects who were pressing for the multi-region failover feature?
Answer: I shared the RICE scoring matrix, developer ticket telemetry, and the existing reliability objectives transparently in our architecture guild. I showed that the caching catalog addressed a recurring developer bottleneck, while the current recovery architecture still met its agreed RTO and RPO targets. That evidence helped us align on deferring the multi-region work without treating reliability as optional.
Follow-up 3. Curveball. A minor regional cloud outage occurs while multi-region failover is deferred, causing leadership to question your prioritization. How do you respond?
Answer: I would acknowledge that the outage provides new evidence and avoid defending the previous decision reflexively. I would review the actual customer impact, recovery time, and business risk against our RTO and RPO objectives, then update the prioritization using the new evidence. If the incident exposed a reliability gap, I would accelerate the multi-region work even if that required moving other roadmap items.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview, and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
60. Tell me about a time you gathered requirements from platform users.
Answer. When designing our next-generation continuous delivery pipeline, I avoided writing a technical specification in isolation. I established a platform advisory council consisting of 6 engineers from different product teams. I conducted contextual inquiry sessions, watching them execute deployments to observe unstated pain points. This research revealed that status visibility and rollback confidence were their primary concerns, directly shaping our pipeline UI and automated canary rollback design.
Follow-up 1. What is contextual inquiry? And how did observing developers in their live environment reveal requirements that surveys missed?
Answer. Contextual inquiry involves observing developers perform real tasks in their normal environment. Surveys told us that deployment visibility was a problem, but observing live deployments showed that engineers often lacked useful progress information during long-running stages and sometimes retried or aborted healthy deployments unnecessarily. That revealed a usability problem the survey responses alone did not fully explain.
Follow-up 2. How did you ensure the Platform Advisory Council did not turn into a feature request committee with endless scope creep?
Answer. I established clear governance boundaries. The council provided qualitative feedback and usability testing, while the platform team retained ownership of prioritization, technical architecture, and the final delivery roadmap based on organization-wide metrics.
Follow up 3 Curveball. 2 advisory council members represent conflicting product needs and demand incompatible pipeline features. How do you resolve it?
Answer: I would first separate the requirements that are genuinely different from those that only appear different because of team-specific workflows. If both use cases are valid, I would keep a common deployment core and expose configuration points for the small number of meaningful differences. I would avoid creating separate pipeline implementations unless the workflows truly require different execution models.
61. Tell me about a time you reduced developer cognitive load.
Answer: application developers were overwhelmed by having to configure complex Kubernetes manifests, ingress annotations, and cloud provider IAM policies just to ship a simple microservice. I led an initiative to reduce cognitive load by introducing abstract application manifests using SCORE and internal Golden Path templates. Developers only needed to define basic service dependencies and resource sizes, while our platform automation rendered the compliant, low-level Kubernetes and cloud resources automatically behind the scenes.
Follow up 1. How did you balance high-level manifest abstraction with granting advanced developers access to raw Kubernetes parameters when necessary?
Answer: we provided controlled extension points rather than unrestricted access to raw Kubernetes configuration. Standard fields covered the common deployment cases, while advanced teams could request supported overrides through version configuration options. Where a requirement became common across multiple teams, we promoted it into the abstraction instead of allowing every team to maintain its own low-level customization.
Follow up 2. How did you evaluate whether the abstraction layer actually reduced cognitive load rather than creating a leaky abstraction?
Answer: we measured configuration effort alongside developer outcomes rather than using line count alone. We tracked time to create a new service, support questions related to deployment configuration, onboarding completion time, and the frequency of teams needing platform assistance. These measures showed whether the abstraction actually simplified the developer workflow rather than merely hiding configuration.
Follow up 3 Curveball. A developer troubleshooting a production issue claims your abstraction layer hides critical pod error details, making debugging harder. How do you respond?
Answer: I would review their debugging workflow and update our internal developer portal to display underlying Kubernetes pod events and container logs directly alongside the high-level application views, ensuring abstractions never obscure diagnostic telemetry.
62. Tell me about a time you created or improved a golden path.
Answer: our application teams were repeatedly creating their own Kubernetes deployment pipelines, resulting in inconsistent security controls, deployment configurations, and observability defaults. I created a golden path that provided a supported repository structure, CI and CD workflow, deployment configuration, security checks, and standard operational telemetry. Teams could start from the template and reach a production-ready deployment without rebuilding the platform integration themselves. We measured adoption and support requests after rollout and iterated on the path based on recurring developer feedback.
Follow up 1. How did you decide what belonged inside the golden path versus what should remain configurable?
Answer: I separated non-negotiable platform requirements from team-specific implementation choices. Security controls, required telemetry, deployment health checks, and approved runtime configurations were enforced centrally, while application-specific settings remained configurable through documented interfaces. We reviewed recurring exceptions to determine whether they represented legitimate flexibility or gaps in the golden path itself.
Follow up 2. How did you prevent the golden path from becoming outdated as platform standards changed?
Answer: we treated the golden path as a version product rather than a static template. Changes to the underlying CI and CD components and deployment modules went through normal testing and release processes, while new services received the current supported version. We also tracked adoption of newer versions and communicated breaking changes with migration guidance, instead of silently changing existing workloads.
Follow-up 3 curveball. An experienced team says the golden path is slowing them down, and they want to build their own pipeline. How do you respond?
Answer: I would first understand which part of the golden path is creating the friction, rather than immediately blocking their request. If their requirement is legitimate, I would determine whether the path needs a supported extension point or whether an exception is appropriate. If they still choose an off-road implementation, I would make the operational ownership, security requirements, and support boundaries explicit.
63. Tell me about a time you treated an infrastructure capability like a product.
Answer: our internal Kubernetes platform was technically reliable, but developers experienced it as a collection of infrastructure components rather than a usable product. I introduced a product-oriented approach by defining target users, supported use cases, service-level expectations, onboarding journeys, and a roadmap based on developer problems. We tracked adoption, support demand, and time to first successful deployment alongside platform reliability metrics. This changed our planning conversations from what infrastructure should we build to what developer problem are we solving.
Follow-up 1. How did you identify who your platform's actual customers were?
Answer: I segmented users by their interaction with the platform, rather than treating every engineering team identically. Application developers, service owners, security teams, and engineering leaders had different needs and success criteria. We combined interviews, support ticket analysis, platform usage data, and deployment workflows to identify the highest impact customer problems.
Follow-up 2. What changed in your roadmap after adopting this product mindset?
Answer: we stopped prioritizing capabilities simply because they were technically interesting or architecturally modern. Roadmap items were evaluated against developer reach, business impact, reliability requirements, adoption potential, and engineering effort. This moved several low-usage infrastructure enhancements behind improvements that reduced onboarding time and recurring developer support work.
Follow-up 3 curveball. Leadership says platform engineering should be measured only by uptime and infrastructure cost. How do you defend the product approach?
Answer: I would explain that uptime and cost are necessary but incomplete measures, because a platform can be highly available and still create significant developer friction. I would connect platform metrics to measurable outcomes such as deployment lead time, onboarding duration, support demand, and adoption. I would not replace reliability metrics. I would add product metrics that demonstrate whether the platform is actually creating engineering value.
64. Tell me about a time you had to balance platform standardization with developer flexibility.
Answer: we standardized application deployments around a common Kubernetes platform, but several teams had legitimate requirements that did not fit the default runtime configuration. Instead of creating separate platforms for every exception, I defined a supported baseline and a controlled extension model. Teams could customize approved parameters while security, networking, observability, and compliance requirements remained enforced centrally. This gave developers meaningful flexibility, without allowing every team to create its own unsupported platform.
Follow-up 1. How did you determine whether a team's request deserved an exception?
Answer: we evaluated the request against business need, workload characteristics, security impact, operational cost, and whether the requirement was temporary or likely to become common. A legitimate performance or compliance requirement could justify an exception, while preferences that simply differed from the standard usually did not. We documented approved exceptions, so they remained visible and reviewable.
Follow-up 2. What did you do when exceptions started becoming common?
Answer: repeated exceptions were treated as product feedback, rather than permanent one-off approvals. I analyzed the common requirements and worked with the platform team to determine whether they should become supported configuration options or a new golden path capability. This allowed the platform to evolve without creating an uncontrolled collection of special cases.
Follow-up 3 curveball. A senior developer says your standards are preventing them from using a technology that would give their service a major performance advantage. How do you respond?
Answer: I would ask them to demonstrate the performance requirement with representative workload data, rather than rejecting the technology based on platform preference. If the benchmark shows a material business benefit, I would evaluate the operational and security implications and determine whether the technology can be supported safely. If it cannot, I would explain the constraint and work with them on the closest supported alternative.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
65. Tell me about designing effective guardrails or policy as code that developers didn't hate.
Answer: our security policies initially blocked deployments with generic error messages, so developers treated the controls as obstacles rather than useful safeguards. I redesigned the policy workflow to provide actionable feedback explaining what violated the policy, why it mattered, and how to fix it. We also moved predictable checks earlier into the development workflow, so developers could identify violations before reaching the deployment stage. Adoption improved because the guardrails became part of the developer workflow instead of a final stage surprise.
Follow-up 1. How did you prevent developers from simply bypassing the policy checks?
Answer: we separated informative feedback from non-negotiable enforcement. Developers could see policy results early during pull requests, but production deployment still required the enforced control to pass through the approved CI and CD path. Where legitimate exceptions existed, we created a documented, time-bound approval process rather than allowing teams to disable the policy themselves.
Follow-up 2. How did you decide which policies should block deployments versus only generate warnings?
Answer: we classified policies based on potential business impact and the likelihood of causing security, compliance, or operational harm. High-risk violations such as prohibited public exposure or missing encryption controls were blocking policies, while lower-risk recommendations could initially generate warnings. We reviewed warning trends over time to determine whether any should become mandatory.
Follow-up 3. Curveball. A new policy blocks a critical production deployment during a Sev1 incident. What do you do?
Answer: I would not simply disable the policy globally under incident pressure. I would use the approved break glass process if the deployment is genuinely required for service recovery, ensuring the exception is authorized, time-bound, and auditable. After stabilization, I would review why the policy blocked the emergency change and determine whether the rule or emergency workflow needs improvement.
66. Tell me about reducing cognitive load through better abstractions, documentation, or templates.
Answer: developers were repeatedly searching across separate wiki pages, repository examples, and old onboarding documents to understand how to deploy a standard service. I consolidated the common workflow into a supported template with embedded documentation, sensible defaults, and links to the deeper technical references when needed. The goal was not to hide complexity completely, but to make the common path obvious while preserving access to the underlying details. This reduced onboarding questions and the amount of platform assistance required for routine deployments.
Follow-up 1. How did you prevent the new abstraction from hiding information developers needed for troubleshooting?
Answer: we designed the abstraction in layers. The default experience exposed the small number of decisions developers normally needed, while advanced views linked directly to generated configuration, deployment events, logs, and platform documentation. Developers could stay at the high-level interface for routine work, but still reach the underlying implementation when diagnosing an unusual problem.
Follow-up 2. How did you know the documentation and templates actually reduced cognitive load?
Answer: we compared onboarding duration, repeated support questions, template usage, and the number of manual steps required for a standard deployment before and after the change. We also interviewed developers about where they still became confused. The combination of behavioral metrics and direct feedback helped us identify whether we had genuinely simplified the workflow or merely moved complexity somewhere else.
Follow-up 3. Curveball. A senior engineer says your simplified documentation is too basic and removes important technical detail. How do you handle it?
Answer: I would explain that the goal is progressive disclosure rather than removing technical depth. The default documentation should answer the common questions quickly, while advanced architecture details, configuration references, and troubleshooting guides remain available through linked sections. If experienced engineers consistently need information that is difficult to find, I would improve the navigation rather than making every developer read the advanced material.
67. Tell me about your experience rolling out or driving adoption of an internal developer portal or service catalog?
Answer: our engineering teams had services documented across spreadsheets, wikis, repository files, and tribal knowledge, making ownership and operational discovery difficult. I helped roll out an internal developer portal with a service catalog that provided service ownership, repository links, deployment information, documentation, and operational metadata in one place. We started with a small set of high-value services, validated the workflow with developers, and expanded coverage based on adoption feedback. This phased approach helped us prove value before attempting organization-wide rollout.
Follow-up 1. How did you prevent the service catalog from becoming another manually maintained spreadsheet?
Answer: we automated metadata ingestion wherever possible from source control repositories, CI and CD systems, Kubernetes workloads, and ownership configuration. Teams were responsible only for information that could not be reliably derived from system data, such as business ownership or service criticality. We also monitored stale metadata and surfaced ownership gaps, instead of assuming that catalog entries remained accurate forever.
Follow-up 2. How did you drive adoption when developers already had their own tools?
Answer: we avoided positioning the portal as a mandatory replacement for every existing tool. Instead, we focused the portal on workflows where a centralized service view provided clear value, such as ownership discovery, operational links, documentation, and service health context. We onboarded influential teams first, used their feedback to improve the experience, and expanded adoption through demonstrated usefulness rather than a top-down mandate.
Follow-up 3. Curveball. Leadership wants 100% service registration within 1 quarter. Developers say the portal is not valuable enough to justify the work. What do you do?
Answer: I would explain the difference between registration coverage and meaningful adoption. I would identify the minimum metadata required for useful ownership and operational discovery, automate as much registration as possible, and prioritize high-risk or high-value services first. If adoption remains low, I would use the feedback to improve the portal rather than treating 100% registration as proof that the product is successful.
68. Tell me about a time you consolidated fragmented documentation, scaffolding, and operational metrics into a single developer pane of glass.
Answer: developers had to move between the wiki for documentation, GitHub for repositories, the CI and CD system for deployments, Kubernetes dashboards for runtime status, and separate monitoring tools for operational health. I helped consolidate these workflows into a developer portal that linked service ownership, documentation, repository and pipeline information, deployment status, and operational signals from one service-centric view. We deliberately integrated existing systems rather than rebuilding every capability. The result was a single starting point for service discovery and operations, without forcing teams to abandon the tools they already used.
Follow-up 1. How did you decide which information belonged on the service's main portal page?
Answer: we prioritized information based on the tasks developers performed most frequently during development and operations. Ownership, repository, deployment status, recent changes, documentation, and key operational links formed the core view, while deeper logs and metrics remained accessible through linked integrations. We used developer interviews and usage analytics to remove low-value information that added visual noise.
Follow-up 2. How did you integrate information from multiple systems without creating another fragile platform dependency?
Answer: we treated the portal primarily as an integration and discovery layer, rather than making it the system of record for every data type. Existing systems remained authoritative for source code, CI and CD execution, Kubernetes state and observability data. The portal consumed supported APIs or events and displayed the information with clear links back to the source systems, reducing unnecessary duplication and synchronization risk.
Follow-up 3. Curveball. During a Sev1 incident, the developer portal itself goes down. Teams argue that the portal has become a critical dependency. What do you do?
Answer: I would ensure that incident responders can reach the underlying source systems directly, and that critical operational links are documented outside the portal itself. I would treat the portal outage as a reliability issue for the platform product, but not allow it to become a single point of failure for incident response. After recovery, I would review the portal's availability objectives, dependency model, and fallback mechanisms.
Category 6. Key takeaways for platform engineers.
A modern platform engineer is not just building infrastructure. The platform itself is an internal product. 1. Build for real developer problems. Start with observed developer friction instead of assuming what teams need. 2. Create paved roads, not rigid roads. Standardize the common path while providing controlled extension points for legitimate requirements. 3. Treat adoption as a product metric. A platform feature has little value if developers do not use it. 4. Reduce cognitive load. Hide unnecessary implementation complexity while keeping advanced details available when needed. 5. Measure developer outcomes. Track onboarding time, deployment lead time, support demand, adoption, and developer satisfaction. 6. Keep the platform from becoming a bottleneck. Developers should always have safe fallback paths when the portal or platform interface is unavailable. The best platform is not the one with the most features. It is the one developers willingly use because it makes their work easier.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 6 platform product to Category 7 automation.
We have now looked at how platform engineers build platforms developers actually want to use. But a good platform should do more than provide interfaces and golden paths. It should continuously remove repetitive human work. That brings us to automation, operational toil, and the growing role of AI in modern platform engineering.
Category 7. Automation, Toil, and AI.
Automation is not simply about replacing a manual command with a script. Strong platform engineers identify recurring operational work, understand why it exists, measure its cost, and decide where automation creates enough value to justify its complexity. Modern platforms also introduce AI-assisted development, AI-driven operational workflows, and infrastructure capable of supporting large-scale AI and machine learning workloads.
Category 7. Automation, operational toil, and AI integration, the 13 questions you must know.
Here are the top 13 automation, operational toil, and AI integration questions that you are going to master in Category 7. 69. Tell me about a repetitive task you automated. 70. Tell me about the most valuable automation you built. 71. Tell me about a manual operational process you eliminated. 72. Tell me about a time automation significantly reduced deployment time. 73. Tell me about a time automation introduced a new failure mode. 74. Tell me about a time you automated something that initially seemed impossible to automate. 75. Tell me about a time you had to decide whether automation was worth the effort. 76. Tell me about a time you replaced a manual infrastructure process with self-service. 77. Tell me about a time you reduced operational toil for another team. 78. Tell me about an automation you would not automate again. 79. Tell me about a time you integrated AI-assisted tools like GitHub Copilot, internal LLMs into the developer workflow or platform. 80. Tell me about a time you used AI and LLMs to automate platform toil, generate infrastructure code, or assist in incident response. 81. Tell me about a time you had to adapt your platform architecture to host, scale, or support heavy AI and ML workloads or GPU provisioning. The goal is not maximum automation. The goal is maximum useful automation with controlled risk. Let's dive into question 69.
69. Tell me about a repetitive task you automated.
Answer. Our application teams repeatedly requested the same Kubernetes namespace setup, service accounts, secrets configuration, resource quotas, and baseline monitoring. The platform team was manually processing these requests through tickets, which created unnecessary waiting time and inconsistent configurations. I turned the workflow into a self-service automation that collected the required inputs, generated the approved configuration, and applied the standard controls automatically. This removed repetitive platform work while giving developers a faster and more consistent onboarding experience.
Follow-up 1. How did you decide this task was worth automating?
Answer. I looked at the request volume, average handling time, error rate, and how consistently the same steps were being repeated. The work was frequent, predictable, and based largely on predefined rules, which made it a strong automation candidate. I also estimated the implementation effort against the recurring engineering hours we could eliminate.
Follow-up 2. What controls did you put around the automation?
Answer: I made the automation operate only within approved namespaces, resource limits, and configuration templates. Inputs were validated before execution, privileged operations were restricted, and every request produced an auditable record of who requested it and what was created. We also added failure reporting, so a partially completed workflow could not silently appear successful.
Follow-up 3. Curveball. The automation occasionally fails and creates more support tickets than the original manual process. What do you do?
Answer: I would compare the failure rate and support cost against the original manual baseline, rather than defending the automation simply because it was my design. I would identify whether the failures come from poor input validation, unreliable dependencies, or an overly complex workflow. If the automation is not yet providing net value, I would simplify it or temporarily narrow its scope until reliability improves.
70. Tell me about the most valuable automation you built.
Answer: the most valuable automation I built removed a manual production readiness process that required engineers to review infrastructure configuration, monitoring, security controls, and deployment settings before every service launch. I converted those checks into automated validation within the delivery pipeline, with blocking controls for critical requirements and actionable feedback for lower-risk issues. This allowed teams to perform the checks consistently without waiting for a platform engineer. The value was not only time saved, it also made the platform standards repeatable and measurable.
Follow-up 1. How did you prove this was your most valuable automation?
Answer: I compared the engineering hours previously spent on manual reviews with the automated workflow's execution time and support demand. I also tracked the number of configuration issues detected before production and the percentage of releases passing the automated checks without manual intervention. The combination of time savings and earlier defect detection showed the broader value.
Follow-up 2. What did you deliberately leave out of the automation?
Answer: I avoided automating decisions that required business context or architectural judgment. The automation focused on deterministic checks such as required security controls, approved configurations, resource limits, and deployment prerequisites. Human review remained available for genuinely exceptional cases, rather than becoming part of every routine deployment.
Follow-up 3. Curveball. A senior engineer says the automation is replacing valuable engineering judgment. How do you respond?
Answer: I would agree that automation should not replace judgment where context matters. I would show that the workflow removes repetitive verification while leaving architectural decisions and legitimate exceptions with engineers. If the automation is preventing engineers from applying necessary judgment, I would treat that as a design problem and introduce an explicit override or review path.
71. Tell me about a manual operational process you eliminated.
Answer: our operations team manually reviewed application certificate expiration dates every week and created renewal tickets when certificates were approaching expiry. I replaced that process with automated certificate discovery, expiration monitoring, and renewal workflows for supported certificate types. The platform automatically renewed eligible certificates and alerted engineers when a certificate required manual intervention. This eliminated a recurring operational task while reducing the risk of certificates being missed during busy periods.
Follow-up 1. How did you make sure the automation did not create a false sense of security?
Answer: we monitored the certificate inventory independently from the renewal workflow and alerted when certificates were approaching their expiration threshold without a successful renewal event. Renewal failures were treated as explicit failures rather than silently falling back to manual operation. We also periodically tested the renewal path, so we knew the automation still worked before a real expiration event occurred.
Follow-up 2. What happened to certificates that could not be automatically renewed?
Answer: they were placed into a clearly identified manual exception workflow with ownership and deadlines attached. The automation reported the reason for failure and created the appropriate operational task rather than repeatedly retrying indefinitely. This allowed engineers to focus only on certificates that genuinely required human intervention.
Follow-up 3 curveball. The security team says automated renewal could accidentally issue a certificate for the wrong domain. How do you address that risk?
Answer: I would make domain ownership and certificate scope explicit inputs to the workflow and validate them against approved service metadata before requesting renewal. The automation would reject unexpected domains rather than attempting to infer intent. I would also keep issuance and renewal events auditable, so security could trace exactly which service requested each certificate.
72. Tell me about a time automation significantly reduced deployment time.
Answer: a standard application deployment required engineers to manually provision infrastructure, configure deployment settings, create monitoring resources, and perform several validation steps before releasing the service. I converted the workflow into a reusable deployment pipeline with infrastructure provisioning, policy validation, deployment, and automated health checks. What previously took several hours could be completed through a repeatable workflow in a fraction of the time. More importantly, the process became consistent across teams instead of depending on individual engineers remembering every step.
Follow-up 1. How did you make sure the faster deployment was still safe?
Answer: we did not remove validation simply to improve speed. Security and policy checks remained mandatory, while automated health checks and progressive rollout controls verified the deployment before broader traffic exposure. We compared failure rates and rollback frequency before and after automation to confirm that faster delivery was not coming at the expense of reliability.
Follow-up 2. Which part of the process produced the biggest time reduction?
Answer: the largest improvement came from eliminating the waiting time between infrastructure provisioning, configuration review, and deployment preparation. Previously, engineers moved between several systems and often waited for another team to complete a manual step. The automated workflow performed deterministic tasks in parallel and provided a single execution path with visible progress.
Follow-up 3 curveball. Product leadership asks you to make the pipeline even faster by removing security scans. What do you do?
Answer: I would quantify where the pipeline is actually spending time before removing a security control. If scanning is the bottleneck, I would optimize it through caching, parallel execution, incremental analysis where supported, or risk-based scanning, rather than simply deleting the control. I would only change a blocking security requirement through the appropriate security and risk acceptance process.
73. Tell me about a time automation introduced a new failure mode.
Answer: we automated infrastructure cleanup to remove unused cloud resources and reduce unnecessary spend. The initial version relied too heavily on resource age and activity metadata, and it incorrectly identified a small number of resources used by a scheduled business process as inactive. The cleanup caused an unexpected service interruption before we stopped the workflow. I disabled the automation, identified the classification gap, and redesigned it around explicit ownership metadata, protection tags, and a dry run review before destructive actions.
Follow-up 1. Why did your initial automation design fail?
Answer: the design assumed that inactivity was a reliable proxy for being unused, but scheduled workloads naturally have long periods with little or no activity. We had optimized for eliminating cloud waste without modeling the operational context of the resources. The incident showed that destructive automation needs stronger ownership and protection signals than activity metrics alone.
Follow-up 2. What safeguards did you add before re-enabling it?
Answer: we introduced explicit resource ownership, protected resource tags, dry run reporting, and a quarantine stage before permanent deletion. The automation first produced a candidate list and allowed owners or the platform team to review resources that matched ambiguous criteria. Only resources that passed the required checks could proceed to deletion.
Follow-up 3 curveball. Finance says the cleanup must resume immediately because the company is under a major cloud cost reduction target. What do you do?
Answer: I would acknowledge the cost target, but would not restore an automation that can still cause production outages. I would re-enable only the low-risk portion using conservative criteria and explicit protection metadata, while the broader workflow is redesigned. I would communicate the expected savings, remaining risk, and timeline so the cost objective and operational risk are both visible.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
74. Tell me about a time you automated something that initially seemed impossible to automate.
Answer: generating strict least privilege IAM policies for microservices initially seemed difficult because developers rarely knew every cloud API action their applications required. They often responded by requesting broad wildcard permissions to avoid breaking workloads. I introduced a workflow that exercised the application in a controlled environment, captured the resulting AWS API activity through CloudTrail, and used IAM Access Analyzer to generate a policy baseline from the observed actions. We then reviewed and refined that baseline before promoting it into version-controlled infrastructure code.
Follow-up 1. How did you ensure the generated policies did not break edge cases that were not exercised?
Answer: we treated the generated policy as a baseline rather than assuming observed activity, represented every required permission. Integration tests covered expected application paths, and the generated policy went through validation before deployment. We also monitored production access denied events and used those findings to expand test coverage or explicitly add justified permissions.
Follow-up 2. How did you package this so developers actually used it?
Answer: we integrated the workflow into the CI and CD process for new services. After the service was exercised in the controlled environment, the workflow generated the IAM policy baseline and surfaced the proposed changes as part of the infrastructure review process. Developers could review and adjust the generated policy through the normal pull request workflow, instead of manually constructing permissions from scratch.
Follow-up 3. Curveball. Security says the generated policies are still too broad because the test environment invokes unnecessary APIs. What do you do?
Answer: I would acknowledge that policy generation is only as precise as the activity used to generate it. I would improve the test workload to exercise only legitimate application behavior, add policy validation and maximum permission guardrails, and require review for sensitive actions. I would not allow the generator to become an authority that can automatically grant whatever permissions happen to appear in test activity.
Follow-up 4. Curveball. A critical production path fails because a required permission was never exercised during testing. What do you do?
Answer: I would first restore the service through the approved emergency change process, rather than weakening the entire policy generation workflow. After recovery, I would identify why the test coverage missed that access path and add the missing scenario to the validation suite. I would also review whether the permission should be explicitly documented as a known exception, rather than relying solely on observed activity.
Question 74. Key lesson. What did this experience teach you about automating security decisions?
Answer: it taught me that automation can dramatically reduce the effort required to reach least privilege, but it cannot prove that the observed workload represents every legitimate future behavior. The right approach was to automate evidence collection and policy generation while keeping validation, exception handling, and final authorization under controlled engineering processes. That gave us a scalable starting point without treating automation as infallible.
75. Tell me about a time you had to decide whether automation was worth the effort.
Answer: a team was spending several hours each month manually generating environment configuration for a relatively small number of lower frequency services. The obvious solution was to automate it, but the workflow had many exceptions and would have required significant engineering effort to maintain. I analyzed the request volume, manual effort, error frequency, and expected lifetime of the process before deciding not to build a full automation. Instead, I simplified the existing template and documentation, which removed most of the friction at a fraction of the implementation cost.
Follow-up 1. What factors did you use to calculate whether automation was worthwhile?
Answer: I considered execution frequency, engineering hours consumed, error rates, business impact, expected lifetime of the process, and the complexity of maintaining the automation. I also considered whether the workflow was stable enough to automate or likely to change frequently. The goal was to compare the total cost of automation with the recurring cost and risk of leaving the process manual.
Follow-up 2. What would make you reverse that decision later?
Answer: if request volume increased significantly, the process became a recurring source of production errors, or the workflow stabilized enough to support reliable automation, I would reassess it. I would also reconsider if the manual process started consuming engineering capacity that could otherwise be spent on higher value work. Automation decisions should be revisited when the economics or operational risk changes.
Follow-up 3 curveball. Your manager says platform engineers should automate everything possible. How do you defend choosing not to automate?
Answer: I would explain that automation has an ownership and maintenance cost. So automating every possible task can create more platform complexity than value. I would show the expected engineering effort, recurring savings, risk reduction, and maintenance burden for this particular workflow. I would still automate deterministic, high-value work, but I would avoid building permanent infrastructure for a process that has little volume or a short remaining lifespan.
76. Tell me about a time you replaced a manual infrastructure process with self-service.
Answer: developers previously opened tickets whenever they needed a standard cloud database, and platform engineers manually provisioned the instance, networking, access controls, backups, and monitoring. I converted the process into a self-service workflow where developers selected an approved database configuration, and the platform provisioned it through infrastructure as code. The workflow automatically applied security and operational defaults, while exposing only the configuration choices developers actually needed. This reduced platform ticket volume and allowed teams to provision standard infrastructure without waiting for an engineer.
Follow-up 1. How did you prevent self-service from becoming uncontrolled infrastructure provisioning?
Answer: the catalog exposed only approved configurations and enforced limits around sizing, networking, encryption, backups, and access. Provisioning happened through the controlled deployment workflow rather than directly from a developer laptop. Every request was authenticated, authorized, recorded, and linked to an owning team so the platform retained operational accountability.
Follow-up 2. What happened when developers requested a configuration that the catalog did not support?
Answer: we first determined whether the requirement represented a legitimate recurring use case or a one-off preference. Legitimate recurring requirements became candidates for new supported catalog options, while exceptional cases went through a documented review process. We avoided continuously expanding the catalog with one-off options because that would eventually recreate the complexity the self-service model was designed to remove.
Follow-up 3 curveball. A developer accidentally provisions an expensive database configuration and finance asks you to disable self-service immediately. What do you do?
Answer: I would contain the immediate cost exposure without removing the entire capability. I would identify the configuration that caused the unexpected spend, add appropriate sizing limits or approval thresholds, and review whether the catalog gave developers enough cost visibility before provisioning. Once the guardrails were corrected, I would restore self-service rather than reverting permanently to a ticket-based process.
77. Tell me about a time you reduced operational toil for another team.
Answer: a security operations team was manually reviewing platform-generated alerts that were repeatedly triggered by known deployment patterns and expected infrastructure changes. I worked with them to understand which alerts represented genuine risk and which could be safely correlated or suppressed. We moved the deterministic filtering and enrichment into the platform workflow while preserving the high-risk alerts for human investigation. This reduced repetitive triage work for the security team without simply lowering the alert volume blindly.
Follow-up 1. How did you make sure you were not simply hiding legitimate security alerts?
Answer: we reviewed historical alerts and correlated them with confirmed incidents and analyst dispositions before changing the detection workflow. Suppression was based on explicit conditions such as known deployment identity, expected resource scope, and approved change windows rather than broad pattern matching. We monitored the resulting alert population and kept the ability to reverse the filtering if detection quality degraded.
Follow-up 2. How did you measure the toil reduction?
Answer: we measured analyst review volume, average triage time, repeated alert categories, and the number of alerts requiring escalation before and after the change. We also checked that confirmed security incidents were still being detected at the expected rate. The objective was not simply fewer alerts. It was fewer low-value manual investigations while preserving meaningful detection coverage.
Follow up 3 curveball. The security team says they do not trust the automation and wants every alert reviewed manually again. How do you respond?
Answer: I would not dismiss the concern because the automation affects security operations. I would review the evidence with them, identify which correlation or suppression rules they are uncomfortable with, and run the workflow in observation mode if necessary before enforcing it. We would agree on measurable detection quality criteria and expand automation only as confidence was established.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip: whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
78. Tell me about an automation you would not automate again.
Answer: I once automated an operational approval workflow that routed infrastructure changes through several automatic decision rules. It looked efficient on paper, but the underlying process contained too many contextual exceptions, so the automation required constant rule changes and generated frequent false positives. Eventually, maintaining the automation consumed more engineering time than the manual review it replaced. I would not automate that workflow in the same way again. I would automate evidence collection and routine validation while keeping the contextual approval decision with an engineer.
Follow-up 1. What did you learn about automation from that experience?
Answer: I learned that a process being repetitive does not automatically make the decision within that process deterministic. The workflow had recurring steps, but the final decision depended heavily on context that changed from case to case. I now separate deterministic execution from judgment-heavy decisions before deciding how much of a workflow should be automated.
Follow-up 2. What would you automate if you had to redesign it today?
Answer: I would automate collecting the change context, validating standard prerequisites, checking policy compliance, and presenting the relevant evidence to the reviewer. I would keep exceptional risk decisions with an authorized engineer. That would remove repetitive preparation work without pretending that every approval decision can be reduced to a fixed rule.
Follow-up 3. Curveball. Leadership says admitting that an automation failed makes the platform team look ineffective. How do you respond?
Answer: I would explain that hiding an ineffective automation creates a larger operational risk than acknowledging it. I would present the measured cost, what failed in the original design, what we changed, and what we would automate differently next time. Platform maturity means knowing when automation is creating value and when it has become an expensive abstraction that should be redesigned.
79. Tell me about a time you integrated AI-assisted tools, such as GitHub Copilot or internal LLMs, into the developer workflow or platform.
Answer: developers were spending significant time writing repetitive infrastructure configuration, documentation, and operational queries. So we introduced an AI-assisted workflow using an approved enterprise coding assistant and internal knowledge sources. We focused the initial rollout on low-risk tasks such as generating Terraform or Kubernetes scaffolding, explaining configuration, and drafting documentation rather than allowing unrestricted production changes. We added guidance around sensitive data, code review, and validation so AI-generated output remained subject to the same engineering controls as human-written code. Adoption was expanded after measuring usage and developer feedback.
Follow-up 1. How did you prevent developers from blindly trusting AI-generated infrastructure code?
Answer: we treated AI output as generated suggestions rather than trusted production configuration. Generated Terraform or Kubernetes changes still pass through version control, code review, policy as code, security scanning, and normal deployment validation. We also documented common failure patterns such as incorrect resource dependencies, insecure defaults, and hallucinated provider or API fields.
Follow-up 2. How did you measure whether the AI integration actually improved developer productivity?
Answer: we compared task completion time for representative infrastructure and documentation tasks before and after adoption, and combined that with developer feedback. We also looked at acceptance and rework rates for AI-generated suggestions, rather than counting generated lines of code. The goal was to determine whether engineers were completing useful work faster, without increasing review or operational burden.
Follow-up 3. Curveball. Security discovers developers are pasting sensitive infrastructure information into a public AI tool. What do you do?
Answer: I would immediately contain the exposure by restricting the affected tool and following the organization's security incident process. I would determine what information was shared, assess whether credentials or sensitive data were exposed, and rotate secrets where required. Going forward, I would provide an approved enterprise AI path with appropriate data controls, logging, access policies, and clear guidance on what information may be submitted.
80. Tell me about a time you used AI or LLMs to automate platform toil, generate infrastructure code, or assist in incident response.
Answer: our platform team spent significant time investigating recurring operational alerts that required engineers to gather logs, recent deployment information, configuration changes, and known remediation steps before deciding what to do. I introduced an internal LLM-assisted workflow that collected approved operational context and generated a structured incident summary with likely causes, relevant evidence, and suggested next actions. The model did not execute production changes. Engineers reviewed the recommendations before taking action. This reduced the time spent gathering information while keeping operational decisions under human control.
Follow-up 1. How did you prevent the LLM from hallucinating incident information?
Answer: the model was grounded on retrieved operational data rather than being asked to answer from general knowledge alone. We provided explicit source references for logs, deployment events, configuration changes, and approved runbooks, and instructed the workflow to distinguish observed evidence from hypotheses. Engineers could trace recommendations back to the underlying data before acting on them.
Follow-up 2. Did you allow the AI system to execute production remediation automatically?
Answer: no, not initially. We treated the AI component as an analysis and decision support layer, while deterministic automation handled any approved remediation steps. High-impact production actions required explicit human authorization, and the workflow maintained an audit trail of the evidence, recommendation, and final action. We would only consider greater autonomy for narrowly scoped, low-risk actions after demonstrating predictable behavior.
Follow-up 3. Curveball. During a Sev1 incident, the LLM recommends a remediation that appears correct, but has never been tested. What do you do?
Answer: I would not execute an untested high-impact remediation simply because the model sounds confident. I would validate the recommendation against known runbooks, system state, recent changes, and the expected blast radius, then use an approved remediation path if one exists. If no safe path exists, the incident commander and appropriate engineers would make the final decision based on evidence and risk.
81. Tell me about a time you had to adapt your platform architecture to host, scale, or support heavy AI or ML workloads, or GPU provisioning.
Answer: our existing Kubernetes platform was designed primarily for CPU-based services, but an AI team needed to run GPU-intensive training and inference workloads. I worked with them to introduce GPU-aware scheduling, appropriate node pools, resource requests, workload isolation, and monitoring for GPU utilization and capacity. We also addressed image size, startup time, and scheduling constraints because GPU workloads were expensive and could not be treated like ordinary application pods. The platform gave the ML team a standardized way to request GPU capacity without giving every team unrestricted access to specialized infrastructure.
Follow-up 1. How did you prevent expensive GPUs from being wasted?
Answer: we monitored GPU utilization, pending workload time, node idle periods, and workload duration to identify underutilized capacity. We used dedicated GPU node pools, appropriate resource requests, scheduling constraints, and lifecycle policies for workloads that did not need persistent GPU access. Where the workload allowed it, we also used queuing or scheduled capacity, rather than keeping expensive GPU nodes running unnecessarily.
Follow-up 2. What was different about operating GPU workloads compared with normal Kubernetes workloads?
Answer: GPU workloads introduced specialized scheduling, hardware capacity constraints, longer startup times, larger container images, and significantly higher infrastructure costs. A workload could be healthy from a Kubernetes perspective, while still wasting expensive GPU capacity through low utilization. We therefore added GPU-specific telemetry and capacity planning, rather than relying only on normal CPU and memory metrics.
Follow-up 3. Curveball. The AI team demands dedicated GPUs for every workload because sharing causes scheduling delays. Finance rejects the additional capacity. What do you do?
Answer: I would first measure the actual queue time, GPU utilization, workload priority, and business impact, rather than accepting either team's position without evidence. I would separate latency-sensitive inference from batch training and evaluate scheduling priorities, dedicated capacity for critical workloads, and shared capacity for lower priority jobs. If additional GPUs were still required, I would present the measured utilization and business impact so the capacity decision could be made transparently.
Category 7. Key takeaways for platform engineers.
Modern platform engineering is not about automating everything. It is about automating the right things safely and removing meaningful operational toil. 1. Automate repetitive work. Target frequent, predictable tasks where automation produces measurable value. 2. Measure automation value. Compare engineering effort, time saved, error reduction, and maintenance cost before and after automation. 3. Treat automation as production software. Automation needs validation, observability, access controls, failure handling, and rollback. 4. Know what not to automate. Context-heavy decisions may be better supported by automation than completely replaced by it. 5. Build safe self-service. Give developers speed while keeping security, cost, and operational guardrails enforced. 6. Use AI with engineering controls. Treat AI-generated code and recommendations as untrusted output that still requires validation. 7. Design AI infrastructure deliberately. GPU workloads introduce specialized scheduling, capacity, utilization, and cost challenges. The best automation is not the one that removes the most human steps. It is the one that removes the most valuable toil without creating a larger operational risk.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, They all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Transition from Category 7 Automation to Category 8 Engineering Judgment.
Automation can remove enormous amounts of operational toil, but platform engineers rarely have unlimited time, people, or budget. The harder challenge is deciding what deserves to be built, what can wait, what should be simplified, and where the platform must accept a trade-off. That brings us to prioritization, trade-offs, and build versus buy decisions.
Category 8 Prioritization, Trade-offs, and Build versus Buy.
Senior platform engineers constantly make decisions with incomplete information and competing demands. Reliability competes with feature delivery. Security competes with developer experience. Cost competes with resilience. And standardization competes with flexibility. Strong candidates do not pretend every decision has a perfect answer. They explain the constraints, evaluate the consequences, make the best available decision, and know when to revisit it.
Category 8 Prioritization, Trade-offs, and Build versus Buy. The 15 questions you must know.
Here are the top 15 prioritization, trade-off, and build versus buy questions that you are going to master in Category 8. 82. Tell me about a time you had more platform work than engineering capacity. 83. Tell me about a time you had to choose between reliability and feature delivery. 84. Tell me about a time you prioritized technical debt over a new feature. 85. Tell me about a time you had to deliver a platform capability under severe time pressure. 86. Tell me about a time you deliberately chose a less technically elegant solution. 87. Tell me about a time you had to balance cost against reliability. 88. Tell me about a time you had to balance security against developer experience. 89. Tell me about a time you had to choose between standardization and flexibility. 90. Tell me about a time you had to prioritize one team's needs over another's. 91. Tell me about a time you had to make a decision with insufficient data. 92. Tell me about a time organizational or business priorities forced a difficult platform trade-off. 93. Tell me about designing multi-tenancy or isolation trade-offs in the platform. 94. Tell me about a time you had to evaluate whether to build a custom platform tool, adopt an open-source CNCF project, or buy a vendor SaaS. 95. Tell me about a time you had to manage or rein in tool sprawl across multiple engineering teams. 96. Tell me about a time an open-source tool you relied on had a critical bug, lacked a required feature, or changed its licensing model. Let's dive into question 82.
82. Tell me about a time you had more platform work than engineering capacity.
Answer: our platform team had more demand than we could realistically deliver. with competing requests around developer self-service, observability, security controls, and infrastructure reliability. I consolidated the requests into a visible roadmap and evaluated them using business impact, developer reach, operational risk, urgency, and engineering effort. We committed to a smaller number of high-impact initiatives instead of spreading the team across every request. I also communicated what we were deliberately not doing so stakeholders understood the trade-offs.
Follow-up 1. How did you decide which work to defer?
Answer: I looked at the consequences of delaying each item, rather than simply ranking requests by who asked first or who had the most influence. Reliability and security commitments were treated as constraints, while discretionary improvements were compared using impact, reach, effort, and urgency. We documented the reasoning so deferred work could be revisited when capacity changed.
Follow-up 2. How did you handle stakeholders whose requests were not prioritized?
Answer: I explained the decision using the same criteria applied to the rest of the roadmap, rather than presenting it as a personal preference. I showed where their request ranked, what higher priority work was consuming capacity, and when we could reassess it. Where possible, I also suggested an interim workaround that reduced the immediate impact without creating permanent platform debt.
Follow-up 3. Curveball. An executive bypasses your prioritization process and demands their team's request be delivered immediately. What do you do?
Answer: I would not ignore the executive request, but I would make the trade-off explicit rather than pretending the work is free. I would clarify the business urgency, identify what committed work would need to move, and communicate the resulting impact to the affected stakeholders. If leadership accepts that trade-off, I would replan the roadmap and execute the decision transparently.
83. Tell me about a time you had to choose between reliability and feature delivery.
Answer: a product team wanted to release a major feature, while our platform was experiencing elevated error rates and an unresolved capacity constraint. Rather than treating the feature deadline as automatically more important, I worked with the team to assess the expected traffic, failure modes, and current reliability objectives. We agreed to delay the broader rollout and release through a limited canary, while the platform issue was addressed. This allowed us to continue making progress without exposing the full customer base to an avoidable reliability risk.
Follow-up 1. How did you convince the product team to accept the delay?
Answer: I translated the platform risk into customer and business impact, rather than presenting it as an infrastructure preference. We reviewed the current error rate trend, expected feature traffic, available capacity, and rollback readiness together. That gave the product team enough evidence to understand why a controlled delay or limited rollout was safer than proceeding with the full release.
Follow-up 2. What if the business deadline could not move?
Answer: I would look for ways to reduce the reliability exposure, rather than treating the decision as simply ship or cancel. Options could include a smaller customer cohort, feature flags, rate limits, additional capacity, reduced functionality, or a controlled canary. If the residual risk still exceeded our agreed reliability objectives, I would escalate the decision with the evidence and required risk acceptance.
Follow-up 3. Curveball. The product executive says missing the launch date will cost the company a major customer. What do you do?
Answer: I would acknowledge the commercial impact and immediately reassess what minimum scope and rollout strategy could satisfy the customer without creating unacceptable platform risk. If leadership chooses to accept a known reliability risk, I would ensure the decision is explicit, time-bound, and supported by a rollback and monitoring plan. I would not silently absorb the risk as a platform engineer.
84. Tell me about a time you prioritized technical debt over a new feature.
Answer: our platform team had an aging deployment component that was increasingly difficult to upgrade and had accumulated several unsupported dependencies. At the same time, stakeholders wanted a new developer-facing platform feature. I used maintenance effort, security exposure, incident history, and the risk of delaying future upgrades to demonstrate that the underlying debt was becoming a delivery constraint. We prioritized the modernization work first, which reduced operational risk and made the later feature easier to deliver.
Follow-up 1. How did you quantify technical debt for leadership?
Answer: I connected the debt to measurable consequences such as engineering hours spent maintaining it, delayed upgrades, security findings, incident frequency, and the increasing effort required for changes. Instead of describing it as code that was simply old, I showed how the debt was affecting reliability, delivery capacity, and future engineering cost.
Follow-up 2. What if the technical debt had no immediate production impact, would not lie prioritize it, just because it was automatically prioritize it technically, just because it was technically undesirable?
Answer: would not lie prioritize it just because it was automatically prioritize it technically just because it was technically undesirable. I would evaluate the probability and impact of future failure, the cost of continued maintenance, and whether the debt was blocking strategic platform work. If the risk remained low and the work had little leverage, I would defer it in favor of higher value initiatives.
Follow-up 3. Curveball. Product leadership says technical debt is invisible to customers and refuses to fund it. How do you respond?
Answer: I would translate the debt into outcomes leadership already cares about, such as slower feature delivery, engineering capacity, security exposure, or incident risk. If the evidence still showed that the debt was low impact, I would accept the decision and document the risk. If the consequences were material, I would make the trade-off explicit rather than repeatedly describing the work as technical housekeeping.
85. Tell me about a time you had to deliver a platform capability under severe time pressure.
Answer: the organization needed a new deployment capability before a major business launch, but the normal platform delivery timeline was much longer than the available window. I reduced the scope to the minimum capability required for the launch and reused existing, proven platform components, rather than introducing new infrastructure. We implemented the highest risk controls first, tested the critical path, and released the capability through a controlled rollout. After the launch, we scheduled the deferred hardening and broader automation as follow-up work.
Follow-up 1. How did you prevent time pressure from causing shortcuts?
Answer: I explicitly separated essential controls from enhancements that could safely follow later. Security, access control, rollback capability, monitoring, and basic failure handling remained mandatory, while cosmetic improvements and lower priority automation were deferred. This gave us a smaller delivery scope, without turning the emergency timeline into an excuse for uncontrolled risk.
Follow-up 2. How did you decide what to cut from the original scope?
Answer: I focused on the minimum user journey required to support the business objective and removed capabilities that were not necessary for that outcome. Each proposed cut was evaluated for operational, security, and reliability consequences. We also documented the deferred items, so temporary simplifications did not silently become permanent platform debt.
Follow-up 3. Curveball. Leadership tells you there's no time for a proper security review. What do you do?
Answer: I would not bypass mandatory security requirements simply because the schedule is tight. I would involve the security team immediately, narrow the scope to the minimum viable capability, and use existing approved patterns wherever possible. If a genuine risk acceptance is required, I would escalate it to the authorized decision maker rather than making that decision unilaterally.
86. Tell me about a time you deliberately chose a less technically elegant solution.
Answer: we needed to provide a short-term integration between an internal platform and a legacy deployment system that was scheduled for retirement. I could have introduced a cleaner event-driven architecture, but that would have required significant development and created a new long-term dependency for a system with a limited remaining lifespan. Instead, I chose a simpler, well-understood integration with clear operational boundaries and an explicit retirement date. It was less elegant architecturally, but it minimized unnecessary complexity and delivered the required business outcome.
Follow-up 1. How did you prevent the temporary solution from becoming permanent?
Answer: we documented the decision, assigned an owner, defined the expected retirement date, and tracked the dependency as explicit technical debt. I also avoided building additional capabilities on top of the temporary integration that made the exit path visible, instead of allowing the workaround to quietly become part of the permanent architecture.
Follow-up 2. How did you explain the decision to architects who preferred the cleaner design?
Answer: I agreed with the architectural advantages of the cleaner design, but showed the implementation cost, expected lifetime of the system, operational risk, and retirement timeline. The discussion became a trade-off between lifecycle economics and architectural elegance, rather than an argument about whose design was better. We documented the reasoning so the decision could be revisited if the retirement timeline changed.
Follow-up 3 curveball. 6 months later, the legacy system's retirement is canceled, and the temporary integration becomes strategic. What do you do?
Answer: I would reassess the original decision using the new lifecycle assumptions rather than defending the workaround indefinitely. If the system had become strategic, I would evaluate the cost, reliability, security, and scaling limitations of the temporary integration and create a migration plan toward the more sustainable architecture. The original decision was correct for the information available at the time, but the changed business context would justify revisiting it.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect, We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
87. Tell me about a time you had to balance cost against reliability.
Answer: our platform had an expensive high availability configuration that provided more resilience than some workloads actually required. Rather than applying the same cost reduction to every service, I classified workloads by business criticality, recovery objectives, and actual availability requirements. Lower criticality workloads moved to a more economical architecture, while critical services retained stronger redundancy. This reduced infrastructure cost without treating reliability as a universal setting that could simply be turned down.
Follow-up 1. How did you determine how much reliability each workload actually needed?
Answer: we used business criticality, documented RTO and RPO requirements, customer impact, dependency relationships, and historical availability expectations. The architecture was then mapped to those requirements, rather than assuming every workload needed the same resilience level. Where requirements were unclear, we worked with service owners and business stakeholders to establish them before changing the infrastructure.
Follow-up 2. How did you prove the cost reduction did not create unacceptable risk?
Answer: we modeled the expected failure scenarios and compared the proposed architecture against the service's recovery objectives. We also validated backup, restoration, monitoring, and failover procedures before changing production workloads. After the change, we tracked availability and recovery performance to verify that the new architecture remained within the agreed reliability boundaries.
Follow-up 3. Curveball. Finance demands a 30% infrastructure reduction across the platform immediately. What do you do?
Answer: I would avoid applying an arbitrary reduction uniformly, because that could remove critical resilience from the most important workloads. I would identify the largest cost drivers, separate waste from intentional reliability spend, and build a savings plan based on workload criticality and utilization. If the target still required a meaningful reliability trade-off, I would make the affected business risks explicit and obtain the appropriate leadership decision.
88. Tell me about a time you had to balance security against developer experience.
Answer: our security team wanted to require several manual approval steps before developers could provision standard cloud resources. But the process was creating significant delays for routine development. I worked with security to identify which controls genuinely required human review and which could be enforced automatically through policy as code. We moved deterministic security checks into the self-service workflow, while keeping manual approval for higher-risk exceptions. This preserved the security requirements, while making the common developer workflow much faster.
Follow-up 1. How did you convince security that automation was safe?
Answer: I mapped each manual control to the risk it was intended to address and demonstrated which risks could be enforced consistently through automated policy. We tested the policies against representative workloads and reviewed false positives and false negatives with the security team before enabling enforcement. This changed the discussion from removing security controls to changing how those controls were implemented.
Follow-up 2. What security controls did you keep behind human approval?
Answer: we kept decisions involving unusual data access, elevated privileges, production exceptions, and significant compliance implications subject to human review. Routine controls such as encryption requirements, approved regions, network restrictions, and resource policies could be enforced automatically. The principle was to automate predictable risk controls while preserving human judgment for genuinely exceptional cases.
Follow-up 3 curveball. Security says developers are intentionally avoiding the controls because they make the platform too difficult to use. What do you do?
Answer: I would treat that as both a security signal and a platform usability problem. I would identify exactly where developers are bypassing the workflow, determine whether the friction is necessary for the underlying risk, and work with security to simplify the safe path. If a control must remain strict, I would improve the developer experience around it rather than weakening the security requirement without evidence.
89. Tell me about a time you had to choose between standardization and flexibility.
Answer: we wanted to standardize how services handled ingress, observability, deployment configuration, and operational ownership across the platform. Several teams, however, had workloads with different traffic patterns and integration requirements. Rather than forcing every service into an identical architecture, I defined a supported platform baseline and documented the dimensions where teams could choose differently. This gave us consistent security and operational foundations, while allowing legitimate workload-specific architecture decisions.
Follow-up 1. How did you decide which parts had to be standardized?
Answer: we standardized areas where inconsistency created significant security, operational, or support risk, such as identity integration, required telemetry, network controls, and ownership metadata. We allowed flexibility where workload characteristics genuinely affected the technical design, such as scaling patterns or certain application-specific integrations. The boundary was based on risk and operational cost, rather than simply enforcing uniformity.
Follow-up 2. What happened when teams wanted to use completely different technology?
Answer: I first evaluated whether the alternative solved a real workload requirement or simply reflected team preference. If the technology provided measurable business or technical value, I assessed whether it could fit within the platform's security and operational boundaries. If it could not be supported safely, I explained the constraint and offered the closest supported alternative, rather than creating an unmanaged parallel platform.
Follow-up 3 curveball. A high-performing engineering team says your standards are slowing their innovation and threatens to build its own platform.
Answer: I would avoid turning the disagreement into a standards versus innovation argument. I would understand which standards are actually creating friction and determine whether the team has a legitimate requirement that should become a supported extension. If they still choose an off-road architecture, I would make the security, reliability, and operational ownership expectations explicit, while using their feedback to improve the common platform.
90. Tell me about a time you had to prioritize one team's needs over another's.
Answer: two engineering teams needed the platform team's help at the same time, but we had capacity to deliver only one request immediately. One request supported a business-critical launch with a fixed external commitment, while the other would improve developer productivity but could safely be delayed. I prioritized the launch-related work and communicated the decision and expected timeline to the other team. I also identified a temporary workaround, so their team was not completely blocked while waiting for platform capacity.
Follow-up 1. How did you make sure the decision was fair?
Answer: I used the same prioritization criteria for both requests: business impact, customer impact, reliability or security risk, urgency, reach, and engineering effort. I documented the reasoning and shared it with both teams rather than making the decision privately. This made the outcome explainable, even though one team necessarily received less immediate attention.
Follow-up 2. What if the second team had a larger number of developers affected?
Answer: I would not use team size alone as the deciding factor. I would compare the scale of the impact against urgency, business consequences, risk, and the cost of delay. A larger affected population could increase priority, but it would still need to be evaluated against the complete set of competing constraints.
Follow-up 3 curveball. The lower priority team's director complains directly to your VP and says your prioritization process is biased.
Answer: I would respond with the decision criteria and evidence, rather than becoming defensive or escalating the disagreement personally. I would show the relative business impact, urgency, risk, and capacity constraints that led to the decision, and invite the leadership team to challenge the assumptions if they had new information. If leadership changed the priority, I would replan transparently rather than treating the escalation as a personal conflict.
91. Tell me about a time you had to make a decision with insufficient data.
Answer: we had to decide whether to increase platform capacity before a major traffic event, but historical usage data was incomplete and the expected workload was new. Waiting for perfect information would have left too little time to react. So I identified the assumptions that mattered most and modeled several demand scenarios. We provisioned a conservative amount of additional capacity, added real-time monitoring and scaling controls, and defined thresholds for taking further action. This allowed us to make a reversible decision while reducing the risk created by uncertainty.
Follow-up 1. How did you decide what assumptions were acceptable?
Answer: I separated assumptions by their potential impact and reversibility. Assumptions that could create significant customer or reliability consequences received conservative treatment, while lower impact assumptions could tolerate more uncertainty. I also identified what telemetry would allow us to validate or invalidate the assumptions once the workload became active.
Follow-up 2. What if the decision had been wrong?
Answer: I would make sure the decision included a clear rollback or adjustment path before committing to it. We defined capacity thresholds, monitoring signals, and escalation conditions in advance, so we were not deciding from scratch during the event. The objective was not to predict perfectly, but to make the uncertainty manageable and the downside controlled.
Follow-up 3. Curveball. Your manager says you should wait for better data because the capacity increase is expensive.
Answer: I would quantify both sides of the uncertainty, the cost of provisioning additional capacity versus the potential customer and revenue impact of insufficient capacity. If the decision remained genuinely uncertain, I would look for a smaller reversible capacity increase, temporary reserved capacity, or stronger auto-scaling, rather than choosing blindly between full expansion and doing nothing.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
92. Tell me about a time, organizational or business priorities, forced a difficult platform trade-off.
Answer: the company shifted its strategic focus toward a major product launch, which meant the platform team had to redirect engineers away from planned reliability improvements and toward launch enablement. I worked with leadership to identify which reliability work was genuinely mandatory and which could be deferred without violating our service objectives. We protected critical reliability commitments while reducing the scope of several lower priority improvements. The trade-off was documented, so everyone understood the reliability debt we were intentionally accepting.
Follow-up 1. How did you decide which reliability work could be deferred?
Answer: we evaluated each item against current SLOs, known failure modes, customer impact, regulatory or security requirements, and the probability of a significant incident. Work that protected mandatory reliability or security objectives remained committed. Lower risk improvements were deferred with explicit owners and review dates rather than disappearing from the roadmap.
Follow-up 2. How did you prevent deferred reliability debt from being forgotten?
Answer: we recorded the deferred work as explicit roadmap items with owners, risk statements, and target review dates. We also tracked the relevant reliability indicators so that deterioration could trigger reprioritization earlier. This made the trade-off visible rather than allowing temporary business pressure to permanently hide the underlying risk.
Follow-up 3. Curveball. A major incident occurs because one of the deferred reliability items was never completed. How do you respond?
Answer: I would focus first on restoring the service and understanding the actual failure mechanism, rather than blaming the person who made the prioritization decision. Afterward, I would review whether the risk had been correctly assessed, whether the deferral had remained visible, and whether our prioritization process needed stronger reliability gates. If the business had explicitly accepted the risk, that decision should be documented, but we would still learn from the outcome.
93. Tell me about designing multi-tenancy or isolation trade-offs in the platform.
Answer: we needed to support multiple engineering teams on a shared Kubernetes platform, without allowing one team's workload to create unacceptable security, performance, or operational impact for others. I evaluated namespace isolation, network policies, resource quotas, workload identity, and node-level isolation against the cost and operational complexity of stronger separation. We used shared infrastructure for lower-risk workloads, while providing stronger isolation for workloads with higher security or performance requirements. The architecture was based on workload classification, rather than assuming every tenant needed the same isolation level.
Follow-up 1. How did you prevent a noisy tenant from affecting others?
Answer: we used resource requests and limits, namespace quotas, appropriate scheduling controls, and monitoring of resource saturation. For workloads with stronger isolation requirements, we used dedicated node pools or other placement controls rather than relying only on namespace boundaries. We also tracked tenant-level resource consumption, so capacity problems could be attributed to the correct workload.
Follow-up 2. When would you choose dedicated infrastructure instead of shared infrastructure?
Answer: I would consider dedicated infrastructure when the workload had materially different security requirements, strong compliance isolation needs, predictable high resource consumption, specialized hardware requirements, or a blast radius that could not be safely contained through logical controls. The decision would also consider utilization, because dedicated infrastructure has a direct cost and capacity efficiency trade-off.
Follow-up 3. Curveball. A high-value customer workload experiences noisy neighbor impact on the shared platform and demands dedicated infrastructure immediately.
Answer: I would first confirm the actual contention and determine whether the impact could be eliminated through quotas, scheduling, capacity changes, or workload placement. If the workload genuinely requires stronger isolation, I would provide a dedicated capacity option with the associated cost and operational implications clearly documented. I would avoid creating a permanent architecture exception based only on the customer's status, without understanding the underlying technical requirement.
94. Tell me about a time you had to evaluate whether to build a custom platform tool, adopt an open-source CNCF project, or buy a vendor SaaS.
Answer: we needed a centralized capability for service discovery and platform workflows, and the team had several options: build internally, adopt an established open-source project, or purchase a SaaS product. I evaluated functional fit, integration effort, security, operational ownership, community or vendor maturity, roadmap alignment, total cost of ownership, and exit strategy. We selected the option that provided the strongest fit with the least long-term platform ownership burden, rather than choosing based purely on licensing cost or technical popularity. The decision was documented with explicit trade-offs and revisit criteria.
Follow-up 1. When would you choose to build instead of adopting an existing tool?
Answer: I would build when the capability represented a meaningful differentiator. Existing solutions could not meet critical requirements, or the integration and customization cost of an existing product exceeded the cost of owning the solution ourselves. I would also consider whether we had the long-term engineering capacity to maintain it. A small initial build can become expensive if the platform team becomes its permanent product owner.
Follow-up 2. How did you evaluate total cost of ownership?
Answer: I considered licensing or hosting cost, implementation effort, ongoing upgrades, security maintenance, operational support, integration work, training, and eventual migration or exit costs. For open source options, I also considered the maturity of the community and how much engineering effort we would need to contribute ourselves. The cheapest acquisition price was not necessarily the cheapest long-term platform option.
Follow-up 3. Curveball. Your CTO strongly prefers the vendor SaaS because it has executive support, while your engineers prefer the open-source option.
Answer: I would avoid turning the decision into a popularity contest between executives and engineers. I would present the same evaluation criteria to both sides, including operational ownership, security, integration, total cost, roadmap, and exit risk. If the vendor option still won under those criteria, I would support it. If not, I would make the gaps and associated risks explicit and let the appropriate decision maker resolve the remaining business trade-off.
95. Tell me about a time you had to manage or rein in tool sprawl across multiple engineering teams.
Answer: different teams had adopted multiple CI and CD systems, observability tools, deployment frameworks, and infrastructure utilities that solved similar problems but created duplicated support and inconsistent operational practices. I first mapped the tools against actual use cases and identified where the duplication created measurable cost or reliability risk. We defined a supported platform stack, migration paths, and clear criteria for introducing additional tools instead of banning everything immediately. This reduced unnecessary variation, while allowing legitimate specialized use cases to remain supported.
Follow-up 1. How did you convince teams to migrate away from tools they preferred?
Answer: I avoided arguing that the standard tool was simply better. I showed the duplicated maintenance, training, integration, security, and operational burden created by the existing toolset, and compared that with the supported platform option. We also provided migration assistance and clear timelines, so teams were not being asked to absorb the entire transition cost themselves.
Follow-up 2. How did you avoid replacing tool sprawl with a single overly rigid platform?
Answer: we define the problem as unnecessary duplication, rather than the existence of multiple tools itself. A specialized tool could remain supported when it addressed a genuine requirement that the standard platform could not meet. We focused on reducing overlapping capabilities and establishing a clear exception process rather than enforcing one technology everywhere.
Follow-up 3. Curveball. A team refuses to migrate because its existing tool is technically superior for its specific workload.
Answer: I would first validate that claim using the workload's actual requirements and measurable outcomes. If the tool provides a meaningful capability that our standard does not, I would consider keeping it as an approved exception with clear ownership and support boundaries. If the advantage is marginal, I would quantify the organization-wide cost of maintaining another tool and work with the team on a migration plan.
96. Tell me about a time an open-source tool you relied on had a critical bug, lacked a required feature, or changed its licensing model.
Answer: we relied heavily on an open-source platform component when a major version introduced a critical compatibility issue with one of our production integrations. Because the component was part of our platform foundation, simply upgrading or replacing it immediately was not realistic. I first assessed the affected versions and production exposure, then evaluated available patches, supported versions, community activity, and viable alternatives. We applied the lowest risk supported mitigation while creating a migration plan that reduced our dependency risk over time.
Follow-up 1. How did you decide whether to patch, fork, downgrade, or replace the tool?
Answer: I compared the severity and exploitability of the issue, support status of available versions, compatibility impact, maintenance burden, and expected time to a sustainable solution. A temporary downgrade might reduce immediate disruption, but could increase long-term security or support risk, while a fork could create permanent maintenance ownership. I selected the option that reduced immediate risk without creating an unacceptable future dependency.
Follow-up 2. How did you protect the platform from becoming too dependent on one open-source project?
Answer: we documented critical dependencies, ownership, supported versions, upgrade paths, and exit strategies for foundational components. For higher-risk dependencies, we avoided unnecessary customization and tracked upstream project health, release activity, security advisories, and community maturity. We also considered portability and replacement cost when making future architecture decisions.
Follow-up 3. Curveball. The open-source project changes its license, and the legal team says you cannot deploy future versions. What do you do?
Answer: I would immediately determine which existing versions and deployments are affected and work with legal and security teams to establish the allowed operating boundary. I would avoid making an impulsive replacement decision during the initial assessment and instead evaluate supported alternatives, migration effort, operational risk, and exit timelines. If the current version could remain legally and securely supported for a defined period, I would use that window to execute a controlled migration rather than creating another rushed platform change.
Category 8. Key takeaways for platform engineers.
Senior platform engineers are constantly making decisions where every option has a cost. Strong engineering judgment means making those trade-offs explicit. 1. Prioritize by impact, not noise. Use business impact, reliability risk, urgency, reach, and engineering effort to decide what deserves capacity. 2. Protect reliability deliberately. Feature delivery, should not silently override agreed reliability and recovery objectives. 3. Make technical debt visible. Connect debt to delivery capacity, security exposure, operational risk, and future engineering cost. 4. Choose pragmatism over elegance when appropriate. The simplest sustainable solution can be better than the most sophisticated architecture. 5. Match reliability to business requirements. Do not spend for maximum resilience when the workload does not require it, but do not remove critical protections blindly. 6. Standardize where it reduces risk. Preserve flexibility where workload requirements genuinely justify it. 7. Evaluate build, open source, and buy holistically. Consider total cost of ownership, operational burden, maturity, integration, roadmap, and exit strategy. 8. Control tool sprawl. Reduce unnecessary duplication without forcing every engineering team into an inflexible single-tool architecture. 9. Make uncertainty manageable. When data is incomplete, use assumptions, reversible decisions, monitoring, and explicit thresholds rather than waiting indefinitely for perfect information. Strong platform engineers do not eliminate trade-offs. They make the trade-offs visible, measurable, and defensible.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Category 8 to Category 9 transition, from engineering judgment to organizational influence.
We have looked at how platform engineers prioritize work, balance competing constraints, and make difficult technical decisions. But even the best platform strategy fails if engineers cannot bring other teams and leaders along. At senior levels, the ability to influence without authority becomes just as important as the technology itself. That brings us to leadership, culture, and organizational influence.
Category 9, leadership, culture, and organizational influence.
Modern platform engineers operate across organizational boundaries. They influence application teams, security, operations, architecture, product, and leadership without necessarily managing any of them. The strongest candidates demonstrate that they can build alignment, mentor engineers, communicate risk, lead through incidents and change, and improve engineering culture beyond their immediate team.
Category 9, leadership, culture, and organizational influence. The 12 questions you must know.
Here are the top 12 leadership, culture, and organizational influence questions that you are going to master in Category 9. 97. Tell me about a time you influenced engineers without having authority over them. 98. Tell me about a platform initiative you had to drive across multiple teams. 99. Tell me about a time you mentored another engineer or grew platform skills in others. 100. Tell me about a time you helped a team adopt a new engineering practice. 101. Tell me about a time you led an incident without being the formal incident commander. 102. Tell me about a time you coordinated multiple teams during a major change. 103. Tell me about a time you had to communicate a technical risk to leadership. 104. Tell me about a time you convinced management to invest in reliability. 105. Tell me about a time you had to defend an unpopular technical decision. 106. Tell me about a time you improved engineering practices beyond your immediate team. 107. Tell me about building a culture of ownership, blameless postmortems, or continuous improvement. 108. Tell me about improving hiring, onboarding, or knowledge sharing for the platform team. Let's dive into question 97.
97. Tell me about a time you influenced engineers without having authority over them.
Answer. Several application teams were reluctant to adopt our new platform deployment standards because they believed the changes would slow their delivery. I avoided using organizational authority and instead demonstrated the concrete problems the standards were solving, including inconsistent security controls and repeated deployment issues. I worked with early adopter teams, incorporated their feedback, and used measurable improvements from those teams to build broader confidence. Adoption increased because teams could see the value rather than being told they had to comply.
Follow-up 1. What did you do when engineers disagreed with your proposal?
Answer. I first tried to understand whether the disagreement was about the underlying goal, the proposed implementation, or the impact on their workflow. I asked for concrete examples and adjusted the design where the feedback exposed a legitimate problem. When the underlying requirement remained valid, I used evidence and trade-offs to explain the decision rather than relying on my position or title.
Follow-up 2. How did you know your influence was actually working?
Answer. I looked beyond verbal agreement and measured behavioral adoption. Teams began using the standard workflows without repeated platform intervention. Support requests around the old process declined, and other teams started asking how they could adopt the same approach. That was stronger evidence of influence than simply having stakeholders agree during meetings.
Follow-up 3 curveball. A highly respected senior engineer publicly challenges your proposal during a technical review, and several engineers support them.
Answer: I would not turn the discussion into a contest of seniority. I would ask them to identify the specific assumptions or risks they believe are wrong and work through those points using evidence. If their objections were valid, I would change the proposal. If they were not, I would explain the reasoning clearly and let the technical merits of the decision speak for themselves.
98. Tell me about a platform initiative you had to drive across multiple teams.
Answer: we needed to establish a consistent platform deployment model across several application teams that had different pipelines, infrastructure patterns, and release processes. I started by aligning the teams on the common outcome, rather than immediately prescribing a technical implementation. We created a phased adoption plan, identified team-specific dependencies, and used early adopters to validate the approach before expanding it. Regular checkpoints made blockers visible and allowed the platform design to evolve without losing the overall objective.
Follow-up 1. How did you handle teams moving at different speeds?
Answer: I avoided forcing every team into the same migration timeline when their starting points were materially different. We defined a common target state, but allowed teams to progress through migration stages based on their dependencies and readiness. Teams with fewer blockers moved first and helped validate the approach, while more complex teams received additional support.
Follow-up 2. What did you do when one team became a major blocker?
Answer: I first identified whether the blocker was technical, resource-related, or caused by an unresolved business requirement. If the issue could be solved centrally, I worked with the platform team to remove it. If it required team-specific work, we agreed on ownership and a realistic timeline. I also protected the overall initiative by continuing progress with teams that were ready, rather than allowing one dependency to stop everyone.
Follow-up 3 curveball. Leadership wants every team migrated by the same deadline, but 2 teams say the timeline is unrealistic.
Answer: I would provide leadership with the actual dependency and capacity data, rather than simply accepting or rejecting the deadline. If the deadline is immovable, I would identify the minimum viable migration scope and the additional resources or risk acceptance required. If the deadline can move, I would propose a phased plan with measurable milestones, rather than an arbitrary organization-wide date.
99. Tell me about a time you mentored another engineer or grew platform skills in others.
Answer: I worked with an engineer who was strong in application development, but had limited experience with infrastructure and platform operations. Rather than simply completing platform tasks for them, I paired with them on real work involving deployment pipelines, observability, and infrastructure as code, and gradually transferred ownership of those areas. I used design discussions, code reviews, and targeted learning goals to build their confidence. Over time, they were able to independently handle platform responsibilities and became a contributor others could rely on.
Follow-up 1. How did you tailor your mentoring approach?
Answer: I first identified the engineer's existing strengths and the specific gaps that prevented independent ownership. I used real platform work, rather than assigning only theoretical exercises, and gradually reduced my involvement as their confidence increased. The level of guidance changed based on their demonstrated ability, rather than staying at the same level throughout.
Follow-up 2. How did you know the mentoring was successful?
Answer: the clearest signal was independent ownership. The engineer began making design decisions, troubleshooting issues, reviewing changes for others, and handling platform tasks without needing constant guidance. I also looked for whether the knowledge had become reusable within the team, rather than remaining dependent on one person.
Follow-up 3 curveball. The engineer you are mentoring keeps making mistakes in production. What do you do?
Answer: I would first protect the production environment by ensuring appropriate review and operational controls are in place, rather than allowing the learning process to create repeated incidents. I would review the mistakes with the engineer without blame, identify whether the issue is a knowledge gap or a process weakness, and increase supervision temporarily where necessary. The goal would be to build competence while maintaining production safety.
100. Tell me about a time you helped a team adopt a new engineering practice.
Answer: a development team was manually validating infrastructure changes before deployment, which created inconsistent checks and late discovery of configuration problems. I helped introduce infrastructure as code reviews, automated policy validation, and standardized pull request checks into their workflow. Rather than imposing the complete process immediately, we started with a small set of high-value checks and expanded coverage as the team became comfortable. The practice became part of their normal development workflow, instead of remaining a separate platform requirement.
Follow-up 1. What resistance did you encounter?
Answer: the team initially viewed the additional checks as extra work that would slow their delivery. I focused on demonstrating how the checks caught problems earlier and reduced manual verification later in the release process. We also tuned noisy policies and removed low-value checks, so the workflow provided useful feedback rather than becoming another source of friction.
Follow-up 2. How did you make the practice sustainable?
Answer: we embedded the checks into the existing development workflow, instead of relying on engineers to remember a separate process. Ownership was clearly assigned, documentation explained failure messages, and the platform team monitored false positives and adoption. The practice was also versioned, so improvements could be introduced without creating uncontrolled changes across teams.
Follow-up 3. Curveball. After rollout, developers begin finding ways to bypass the new checks because they consider them too restrictive.
Answer: I would treat bypass behavior as evidence that either the controls are too restrictive or the workflow is too difficult to use. I would analyze the bypass patterns, review the underlying risks with the team, and simplify or redesign controls where appropriate. For genuinely mandatory requirements, I would move enforcement to a trusted platform boundary rather than relying on voluntary compliance.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details: 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire master vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
101. Tell me about a time you led an incident without being the formal incident commander.
Answer. During a major production incident, another engineer was acting as the formal incident commander, while I took ownership of the technical investigation. I coordinated the engineers working on application, infrastructure, and observability layers, kept the incident commander updated with evidence and hypotheses, and made sure parallel investigations did not duplicate effort. I focused the team on restoring service first and left broader coordination and stakeholder communication with the incident commander. This allowed the technical response to move quickly without creating competing command structures.
Follow-up 1. How did you avoid undermining the incident commander?
Answer. I made the incident command structure explicit and kept my role focused on technical leadership. I provided concise updates, surfaced decisions that required escalation, and did not issue conflicting organizational instructions. When the technical team needed a decision outside my scope, I routed it through the incident commander rather than creating a parallel chain of command.
Follow-up 2. What did you do when engineers disagreed about the technical hypothesis?
Answer. I separated facts from hypotheses and asked engineers to validate competing explanations against observable evidence. Where possible, we ran low-risk tests or compared telemetry rather than debating based on intuition. I also made sure the incident commander understood the confidence level and potential impact of each proposed action before we proceeded.
Follow-up 3. Curveball. The incident commander becomes overwhelmed and starts giving conflicting instructions to the technical teams.
Answer. I would avoid publicly challenging them during the incident, unless the confusion created immediate operational risk. I would help simplify the technical picture, propose a clear next action sequence, and ask the incident commander to confirm the priorities. If the command structure genuinely became unsafe or ineffective, I would use the established incident management process to transfer command, rather than creating an informal takeover.
102. Tell me about a time you coordinated multiple teams during a major change.
Answer. We had to execute a major platform change that affected application teams, security, networking, operations, and release management. I created a dependency map showing which teams owned each prerequisite, defined the sequence of changes, and established a shared communication and rollback plan. we used rehearsals and readiness checkpoints to identify blockers before the production window. During the change, each team had a clearly defined responsibility and escalation path, which reduced coordination gaps and kept the rollout controlled.
Follow-up 1. How did you identify dependencies between teams?
Answer: I mapped the end-to-end change flow and asked each team to identify what it needed before it could execute its part, and what downstream teams depended on its completion. We converted those relationships into explicit prerequisites and owners, rather than relying on assumptions. The dependency map was reviewed during readiness checkpoints and updated as the implementation plan evolved.
Follow-up 2. What did you do when one team was not ready?
Answer: I first determined whether the dependency was genuinely on the critical path, or whether the change could be staged differently. If it was critical, we either resolved the blocker or moved the affected step rather than proceeding blindly. The change window was considered ready only when the required prerequisites and rollback conditions were satisfied.
Follow-up 3. Curveball. During the change, one team reports that their part succeeded, but the dependent team says the expected behavior is not working.
Answer: I would stop the rollout at the appropriate control point, rather than assuming one team must be wrong. We would validate the interface between the two changes, compare the expected and actual state, and determine whether the issue was sequencing, configuration, or an unexpected dependency. If the failure threatened the change objective or rollback criteria, I would trigger the agreed rollback path while the teams investigated.
103. Tell me about a time you had to communicate a technical risk to leadership.
Answer: we identified a platform dependency that had become a significant single point of failure, but the risk was difficult to explain because there had not yet been a major outage. I translated the technical failure mode into business impact, including affected services, potential customer impact, recovery limitations, and the likelihood of the scenario. I presented the risk with concrete evidence and several mitigation options, rather than simply asking for more engineering work. Leadership was able to make an informed decision because the technical uncertainty had been translated into business consequences.
Follow-up 1. How did you communicate the risk without making it sound like a disaster was guaranteed?
Answer: I separated known facts, assumptions, probability, and potential impact, instead of presenting the worst-case scenario as certain. I explained what controls already existed, where the remaining exposure was, and what evidence supported the risk assessment. This allowed leadership to understand the risk without creating unnecessary alarm.
Follow-up 2. What if leadership decided not to fund your recommended mitigation?
Answer: I would document the decision, the assumptions behind it, and the residual risk rather than repeatedly escalating the same recommendation without new evidence. I would continue monitoring the relevant indicators and define the conditions that would trigger reassessment. If the risk materially changed, I would bring the updated evidence back to leadership.
Follow-up 3. Curveball. An executive asked you to give a simple yes or no answer on whether the platform is safe.
Answer: I would avoid giving an absolute assurance that the evidence cannot support. I would state whether the platform is within its agreed risk and reliability objectives, identify the most significant residual risk, and explain what would change my assessment. That gives the executive a clear decision-oriented answer without pretending complex risk can be reduced to safe or unsafe.
104. Tell me about a time you convinced management to invest in reliability.
Answer: our platform had recurring reliability issues that were consuming engineering time, but management was hesitant to invest because the proposed work did not create a visible customer feature. I analyzed incident frequency, engineering recovery effort, customer impact, and the recurring cost of the existing architecture. I presented the reliability investment as a way to reduce operational risk and recover engineering capacity, rather than as purely technical improvement. Management approved the work after seeing the measurable cost of continuing with the existing design.
Follow-up 1. How did you calculate the business value of reliability work?
Answer: I connected reliability problems to measurable outcomes such as incident frequency, downtime exposure, engineer hours spent on recovery, delayed releases, and customer impact. Where direct financial attribution was difficult, I used ranges and clearly stated assumptions rather than inventing precise numbers. The objective was to show the cost of the current state and the expected risk reduction from the investment.
Follow-up 2. What if management still says the investment is too expensive?
Answer: I would compare alternative levels of investment rather than presenting only an all-or-nothing solution. We could address the highest risk failure modes first, introduce incremental controls, or accept explicitly documented residual risk. If the business still chose not to invest, I would record the decision and continue monitoring the indicators that could justify revisiting it.
Follow-up 3. Curveball. Management asks you to prove the reliability investment will prevent future incidents.
Answer: I would explain that reliability engineering can reduce probability and impact, but cannot guarantee that incidents will never occur. I would define measurable objectives such as reduced incident frequency, improved recovery performance, lower change failure rate, or increased resilience against known failure modes. That frames the investment around measurable risk reduction, rather than an unrealistic promise of zero incidents.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
105. Tell me about a time you had to defend an unpopular technical decision.
Answer: I recommended retiring a widely used platform component, even though several engineers were comfortable with it and preferred to keep it. The component had become difficult to maintain, had limited upstream support, and was creating increasing security and upgrade risk. I presented the evidence, migration cost, alternatives, and consequences of continuing with the existing technology. The decision was unpopular initially, but after we demonstrated a phased migration path and reduced the immediate migration risk, the teams aligned behind the change.
Follow-up 1. How did you distinguish a technically unpopular decision from a genuinely bad decision?
Answer: I looked for evidence that challenged my own recommendation rather than only collecting supporting arguments. We compared operational history, security exposure, maintenance cost, alternative options, and migration risk against the expected benefits. If the evidence showed that the existing solution remained acceptable, I would have been willing to change the recommendation.
Follow-up 2. What did you do when senior engineers still disagreed?
Answer: I asked them to identify the specific assumptions or risks they believed were incorrect and address those points directly. Where the disagreement involved legitimate architectural trade-offs, I documented both options and their consequences rather than trying to force consensus. Once the appropriate decision-maker chose a direction, I supported the decision and focused the team on executing it well.
Follow-up 3. Curveball. After the migration begins, you discover that your original technical assessment was partially wrong.
Answer: I would surface the new evidence immediately rather than defending the original decision, because work had already started. I would reassess the architecture, migration plan, and remaining risks using the updated information, and recommend changing course if the economics or risk had materially shifted. Being accountable for a decision includes being willing to revise it when the facts change.
106. Tell me about a time you improved engineering practices beyond your immediate team.
Answer: our platform team had developed a more consistent approach to infrastructure reviews, deployment safety, and operational ownership, but the practices were not being applied consistently across engineering. I worked with engineers from other teams to turn the useful parts into reusable standards, templates, and documentation, rather than simply asking everyone to copy our team's process. We introduced the practices gradually through pilot teams and used their feedback to improve them. The result was broader adoption of common engineering practices, without requiring a centralized team to control every implementation.
Follow-up 1. How did you avoid appearing to impose your team's practices on everyone else?
Answer: I focused on the problem the practice solved rather than presenting our team's workflow as the only correct implementation. I invited engineers from other teams to review the proposed standard and identify where it did not fit their context, where the underlying goal was valuable but the implementation was too specific. We generalized the practice before promoting it more broadly.
Follow-up 2. How did you know the practice had actually spread?
Answer: we looked for adoption in engineering workflows rather than simply counting documentation views. Teams began using the templates and standards independently. Similar issues appeared less frequently in reviews, and engineers started contributing improvements back to the shared approach. Those behaviors showed that the practice had become part of the broader engineering culture.
Follow-up 3 curveball. Another team adopts your practice, but implements it incorrectly and causes a production problem.
Answer: I would focus first on resolving the production impact and understanding where the practice or its documentation allowed the misunderstanding. I would not blame the team for adopting something we promoted broadly. If the guidance was ambiguous, I would improve the template, validation, or documentation and communicate the correction to other adopters.
107. Tell me about building a culture of ownership, blameless postmortems, or continuous improvement.
Answer: our incident reviews were becoming focused on identifying who made the mistake rather than understanding why the system allowed the failure to occur. I helped shift the discussion toward timelines, contributing factors, detection gaps, recovery effectiveness, and systemic improvements. We made action items explicit, assigned owners, and reviewed recurring themes across incidents, rather than treating each postmortem as an isolated event. Over time, engineers became more willing to surface weaknesses early because the process focused on learning and improving the system rather than assigning blame.
Follow-up 1. How do you keep blameless postmortems from becoming consequence-free?
Answer: blameless does not mean accountability-free. We distinguish between honest mistakes within a reasonable process and deliberate or reckless behavior that requires a different management response. For normal incidents, accountability comes through concrete corrective actions, owners, deadlines, and verification that the underlying risk was actually reduced.
Follow-up 2. What did you do when the same type of incident happened repeatedly?
Answer: repeated incidents were treated as evidence that the corrective actions had not addressed the underlying problem. I looked for common contributing factors across postmortems and prioritized systemic fixes, such as better automation, guardrails, observability, or process changes. We also tracked recurring incident themes, so they remained visible instead of disappearing into separate postmortem documents.
Follow-up 3 curveball. An engineer makes the same mistake twice and argues that the postmortem process protects them from accountability.
Answer: I would separate the individual's behavior from the blameless incident review process. I would examine whether the first incident produced a clear corrective action and whether the engineer followed the expected process afterward. If there was negligence or deliberate disregard for controls, that should be handled through the appropriate management process, while the technical postmortem remains focused on learning and system improvement.
108. Tell me about improving hiring, onboarding, or knowledge sharing for the platform team.
Answer: new engineers joining the platform team were taking too long to become productive because critical knowledge was distributed across senior engineers, old documentation, and individual repositories. I helped create a structured onboarding path covering platform architecture, operational procedures, development environments, incident practices, and progressively harder hands-on tasks. We also converted recurring questions into reusable documentation and examples, so new engineers were not dependent on one person for every answer. This reduced onboarding friction and made platform knowledge more resilient as the team changed.
Follow-up 1. How did you prevent onboarding documentation from becoming stale?
Answer: we treated important onboarding material as part of the platform's maintained documentation rather than a one-time training document. Changes to architecture and operational workflows triggered corresponding documentation updates, and engineers were encouraged to fix documentation as part of normal work. We also used onboarding feedback to identify instructions that were unclear or no longer accurate.
Follow-up 2. How did you know the onboarding process had improved?
Answer: we tracked time to first meaningful contribution, time to independent operational work, recurring onboarding questions, and feedback from new engineers and their mentors. We also looked at whether new engineers were able to navigate the platform and complete common tasks without relying heavily on a single senior engineer. The goal was measurable independence rather than simply completing an onboarding checklist.
Follow-up 3 curveball. A senior engineer says documenting their knowledge is a waste of time because they can simply teach new hires directly.
Answer: I would acknowledge the value of direct mentoring, but explain that relying on one person's availability creates a scalability and continuity risk. I would capture the repeatable knowledge in documentation while keeping direct mentoring for architecture, judgment, and context that is difficult to document. This allows experienced engineers to spend more time teaching higher value concepts instead of repeatedly answering the same operational questions.
Category 9. Key takeaways for platform engineers.
Senior platform engineers create impact through influence, leadership, and organizational alignment, not just through technical execution. 1. Influence without authority. Build alignment through evidence, trust, collaboration, and demonstrated value rather than relying on organizational position. 2. Drive cross-team initiatives. Establish a common outcome, clarify ownership, manage dependencies, and keep teams moving toward the same goal. 3. Grow other engineers. Transfer knowledge and ownership instead of becoming the permanent person everyone depends on. 4. Lead through incidents and change. Provide technical direction while respecting established command structures and keeping communication clear. 5. Translate technology into business impact. Explain technical risk through customer impact, financial exposure, delivery consequences, and measurable outcomes. 6. Defend decisions with evidence. Be willing to challenge assumptions, accept disagreement, and change direction when new evidence proves the original decision wrong. 7. Build blameless ownership. Learn from incidents without creating a culture of fear, while still maintaining clear accountability for actions and follow through. 8. Scale knowledge and engineering culture. Improve practices, onboarding, documentation, and knowledge sharing, so the organization becomes less dependent on individual experts. The strongest platform engineers scale their impact through people, decisions, and culture, not just infrastructure.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Category 9 to Category 10 transition, from organizational influence to security and trust.
Platform engineers influence how organizations build and operate technology, but that influence also carries responsibility for security and trust. Modern platforms sit directly in the path of identity, infrastructure, software delivery, and supply chains. A security or compliance requirement can therefore reshape the platform itself. The next category focuses on security, compliance, software supply chain protection, and how platform architecture responds when a serious vulnerability emerges.
Category 10, security, compliance, and software supply chain.
Security is no longer a separate layer that can simply be handed to another team. Platform engineers increasingly build the controls that enforce identity, secure software delivery, protect infrastructure, and provide evidence for compliance. The challenge is implementing those controls without turning engineering workflows into unnecessary bottlenecks, and being able to respond quickly when a critical vulnerability affects the infrastructure underneath them.
Category 10, security, compliance, and software supply chain. The 4 questions you must know.
Here are the top 4 security, compliance, and software supply chain questions that you are going to master in Category 10. 109. Tell me about a security or compliance requirement that forced significant platform changes. 110. Tell me about a time security requirements conflicted with developer productivity. 111. Tell me about a time you implemented or improved software supply chain security, for example, SBOMs, image signing, Zero Trust CI and CD without breaking workflows. 112. Tell me about a time a major infrastructure zero-day vulnerability hit your organization and how your platform design impacted the response. Let's dive into question 109.
109. Tell me about a security or compliance requirement that forced significant platform changes.
Answer. Our organization introduced a requirement to eliminate long-lived static credentials in production. I worked with security to implement a workload identity model using short-lived, federated tokens tied directly to the platform's compute orchestration. We updated deployment templates to inject identity automatically, removed embedded credential patterns, and added policy as code validation to prevent static keys from returning. This turned the compliance requirement into a repeatable platform capability, rather than a manual audit exercise.
Follow-up 1. How did you prevent the change from breaking existing workloads?
Answer. We inventoried how existing services were obtaining credentials and piloted the workload identity federation with lower risk, modern services first. For legacy applications that could not adopt the new identity model immediately, we provided a secure, monitored vault injection path as an interim step rather than forcing an uncontrolled cutover that would break production.
Follow-up 2. How did you prove compliance after the platform changes?
Answer: we added automated checks that identified workloads still using prohibited credential patterns and reported their ownership and migration status. The platform also produced evidence showing which workloads were using the approved identity mechanism. This made compliance continuously measurable instead of depending on a periodic manual audit.
Follow-up 3. Curveball. A critical legacy application cannot support the new identity mechanism before the compliance deadline.
Answer: I would not silently exempt the application from the requirement. I would work with security and the application owner to document the limitation, define compensating controls, and obtain an explicit time-bound exception if the governance process allows it. At the same time, I would create a migration plan so the exception does not become a permanent bypass.
110. Tell me about a time security requirements conflicted with developer productivity.
Answer: security required additional controls around production access and infrastructure changes, but the initial implementation introduced several manual approvals that significantly slowed routine engineering work. I worked with the security team to separate high-risk actions from predictable low-risk workflows and automated the controls that could be enforced consistently. Developers received faster self-service for standard operations, while sensitive production actions retained stronger authorization. This allowed us to improve security without making every engineering change a manual security review.
Follow-up 1. How did you decide which activities required stronger controls?
Answer: we evaluated privilege level, production impact, data sensitivity, reversibility, and the potential blast radius of each activity. Low risk, repeatable operations could use automated policy enforcement, while privileged or high-impact actions required stronger authorization and auditability. The control level was therefore based on risk rather than applying the same approval process to every developer action.
Follow-up 2. What if security refused to reduce the manual approvals?
Answer: I would not frame the discussion as security versus developers. I would bring evidence showing the operational cost of the manual process and propose ways to preserve the same control objective through automation, stronger identity controls, or risk-based approvals. If security still required the manual process, I would respect the control while working on a safer and more efficient implementation for future iterations.
Follow-up 3. Curveball. Developers begin creating unofficial workarounds because the approved security workflow is too slow.
Answer: I would treat the workaround behavior as a serious security signal rather than simply punishing the developers. I would identify what legitimate workflow is being blocked, measure where the friction occurs, and work with security to create a faster approved path. At the same time, I would close unauthorized access paths and make the supported workflow easier to use so security does not depend on developers voluntarily tolerating unnecessary friction.
111. Tell me about a time you implemented or improved software supply chain security, such as SBOM, image signing, or Zero Trust CI and CD, without breaking workflows.
Answer: we needed stronger assurance that production workloads were built from approved source code and trusted dependencies, but simply adding multiple blocking security checks to the existing pipeline would have created significant delivery friction. I introduced the controls incrementally, starting with SBOM generation, vulnerability visibility, and image provenance, before enforcing image signing and deployment verification for critical workloads. We integrated the checks directly into the existing CI and CD workflow and provided actionable remediation feedback. This allowed the security posture to improve without forcing developers into a completely separate delivery process.
Follow-up 1. How did you prevent supply chain controls from making deployments unnecessarily slow?
Answer: we measured pipeline execution time before introducing each control and optimized expensive steps through caching, parallel execution, and appropriate scan scopes. Non-critical findings initially provided actionable feedback, while high-risk policy violations remained blocking. This allowed us to improve security while continuously monitoring the delivery time impact of the controls.
Follow-up 2. What happened when a production deployment used an image that failed signature verification?
Answer: the deployment was automatically blocked by the cluster admission controller. We then traced the artifact to determine whether it was a genuinely unauthorized image, or if a valid build simply bypassed the signing step in the pipeline. If the artifact was built outside the trusted CI and CD path, the rejection operated exactly as designed to protect the cluster.
Follow-up 3. Curveball. A critical production release is blocked because the software supply chain scanner reports a vulnerability that security has not yet classified.
Answer: I would first determine the actual exploitability and exposure, rather than treating every scanner finding as equally dangerous. If the release is business critical, I would use the established security exception or risk acceptance process, while investigating whether a safer dependency or configuration is available. The decision would be explicit, time-bound, and documented rather than silently bypassing the control.
112. Tell me about a time a major infrastructure zero-day vulnerability hit your organization and how your platform design impacted the response.
Answer: a critical vulnerability was disclosed in an infrastructure component used across multiple production environments, requiring rapid assessment and remediation. Because our platform maintained centralized inventory, version metadata, ownership information, and deployment automation, we could identify affected workloads and prioritize remediation based on exposure and business criticality. We used the existing deployment mechanisms to roll out the patched versions in controlled waves while monitoring for regressions. The incident demonstrated that platform standardization and centralized visibility significantly reduced the time required to respond to a widespread vulnerability.
Follow-up 1. How did you identify which workloads were actually affected?
Answer: we correlated the vulnerability-affected versions with our infrastructure and workload inventory, rather than relying on teams to manually report exposure. Ownership metadata allowed us to identify responsible teams, while environment and workload information helped us prioritize internet-facing and business-critical systems first. We continuously reconciled the inventory with deployment state, so remediation status remained visible.
Follow-up 2. What if some teams could not patch immediately because of compatibility issues?
Answer: we classified those workloads separately and applied compensating controls where possible, such as reducing exposure, restricting network paths, disabling vulnerable functionality, or increasing monitoring. We documented the residual risk and established a remediation deadline rather than treating the exception as resolved. This allowed the organization to reduce exposure immediately, while giving teams time to perform a safe upgrade.
Follow-up 3. Curveball. The vulnerability is actively being exploited in the wild, and leadership wants every affected workload patched immediately, but the automated rollout could cause a platform-wide outage.
Answer: I would not choose between patch everything blindly and wait until the risk is gone. I would prioritize the most exposed workloads, use controlled rollout waves, validate the patch on representative systems, and maintain rollback capability where technically safe. For systems that cannot tolerate the automated change immediately, I would apply temporary compensating controls and escalate the residual risk while the patch is validated.
Category 10. Key takeaways for platform engineers.
Modern platform security is not a separate gate placed in front of engineering. It must be built into the platform itself. 1. Make security a platform capability. Embed identity, policy, supply chain security, and compliance controls into reusable platform workflows. 2. Use risk-based controls. Apply stronger controls to high-impact operations instead of slowing every developer workflow equally. 3. Eliminate long-lived credentials. Prefer workload identity and short-lived credentials over embedded or manually managed static secrets. 4. Secure the software supply chain. Establish trusted build paths, artifact provenance, SBOM visibility, signing and deployment verification. 5. Keep security controls usable. When developers repeatedly bypass a control, investigate the friction instead of assuming the problem. is simply non-compliance. 6. Designed for rapid vulnerability response. Centralized inventory, ownership metadata, standardized deployment, and automation dramatically reduce enterprise-wide remediation time. 7. Use compensating controls intelligently. When immediate remediation is impossible, reduce exposure while maintaining a documented path to permanent remediation. The strongest platform security is not the security that blocks the most work. It is the security that makes the safe path the easiest path.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass. You send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
Category 10 to Category 11 transition. From security controls to platform judgment.
Security is one dimension of platform engineering, but senior platform engineers constantly make decisions across competing dimensions: ownership, technology adoption, migration risk, compatibility, cost, scale, and business value. The challenge is no longer simply asking whether something can be built. It is deciding whether it should belong on the platform, whether it is worth adopting, what it should cost, and how it will behave as the organization grows.
Category 11 modern platform judgment, FinOps and scale.
Modern platform engineers are expected to think beyond today's architecture. They must decide what the platform should own, which technologies deserve adoption, when a shared capability should be replaced, how migrations affect developers, and how infrastructure economics change at scale. This category tests the judgment required to build platforms that remain technically sustainable, financially responsible, and aligned with the business.
Category 11 modern platform judgment, FinOps and scale, the 14 questions you must know.
Here are the top 14 modern platform judgment, FinOps and scale questions that you are going to master in Category 11. 113. Tell me about a time you decided what should belong in the platform versus what developers should own. 114. Tell me about a time you decided not to adopt a new cloud-native technology. 115. Tell me about a time you replaced or deprecated a widely used platform technology. 116. Tell me about a time you managed a difficult platform migration. 117. Tell me about a time you had to maintain compatibility between different versions of a shared platform component. 118. Tell me about a time you reduced cloud or platform costs without compromising reliability. FinOps. 119. Tell me about a time you had to balance platform team goals against business priorities. 120. Tell me about a platform decision that had an unexpected long-term consequence. 121. Tell me about the platform engineering decision you're most proud of and what you would change about it today. 122. Tell me about a large platform migration you led and how you managed developer impact. 123. Tell me about deprecating a popular platform capability or tool and how you handled the transition. 124. Tell me about capacity planning or load testing that avoided a major outage. 125. Tell me about a time you engineered a platform to support multi-region, multi-cloud, or global scale. 126. Tell me about a time you optimized platform workloads for sustainability or green ops, reducing carbon footprint or idle infrastructure. Let's dive into question 113.
113. Tell me about a time you decided what should belong in the platform versus what developers should own.
Answer. We were receiving increasing requests for the platform team to own application-specific deployment logic, monitoring configuration, and operational workflows. I evaluated each request based on whether it was a reusable cross-team capability or something tightly coupled to an individual application's business logic. We kept common infrastructure, security controls, deployment foundations, and operational guardrails in the platform while leaving application-specific behavior with development teams. This prevented the platform from becoming a centralized bottleneck while still giving developers a reliable paved road.
Follow-up 1. What criteria did you use to decide whether something belonged in the platform?
Answer. I looked for capabilities that were common across teams, difficult to implement consistently, and important for security, reliability, or operational efficiency. Application-specific business logic generally remained with the owning team. I also considered whether centralizing the capability would reduce duplication, or instead, create a platform dependency for every future change.
Follow-up 2. What if developers insist the platform should own a capability because they do not want to maintain it?
Answer. I would first determine whether the request represents legitimate platform leverage or simply a desire to transfer operational responsibility. If the capability is common and can be standardized safely, I would consider bringing it into the platform. Otherwise, I would provide reusable templates, automation, or documentation that reduces the maintenance burden without taking ownership away from the application team.
Follow-up 3 curveball. A critical application fails because developers misunderstood how to operate a platform-owned capability. Who owns the problem?
Answer: I would treat ownership as shared across the interface, rather than immediately assigning blame. The application team owns correct use of the capability, while the platform team owns making the interface understandable, observable, and appropriately guarded. We would determine whether the failure came from misuse, inadequate platform documentation, poor defaults, or an actual platform defect, and improve the boundary accordingly.
114. Tell me about a time you decided not to adopt a new cloud-native technology.
Answer: a new cloud-native technology generated significant interest because it promised improvements in developer productivity and platform flexibility. Instead of adopting it based on industry momentum, I evaluated its maturity, operational burden, security model, integration requirements, community or vendor support, and whether it solved a problem we actually had. The existing platform already met our requirements with lower operational risk, so we decided not to adopt the technology at that time. We documented the decision and defined conditions that would justify reconsidering it later.
Follow-up 1. How did you avoid becoming resistant to new technology?
Answer: the decision was not never adopted. It was not yet, based on our current requirements and maturity. We identified the specific capabilities that would justify adoption and monitored the technology's roadmap, ecosystem, and operational maturity. This allowed us to remain open to the technology without introducing it simply because it was fashionable.
Follow-up 2. What would have changed your decision?
Answer: a significant improvement in maturity, strong evidence of adoption in comparable environments, a clear business requirement, or a measurable advantage over our existing platform could have changed the decision. I would also reconsider if the operational burden of the existing solution increased enough to change the total cost and risk comparison.
Follow-up 3 curveball. Your CTO wants the technology adopted because competitors are already using it.
Answer: I would acknowledge the strategic concern, but separate competitive positioning from technical adoption risk. I would present a controlled evaluation or limited pilot that tests the specific capabilities the organization cares about without committing the entire platform. That provides evidence quickly, while preventing a company-wide dependency from being created purely by competitive pressure.
115. Tell me about a time you replaced or deprecated a widely used platform technology.
Answer: we had a widely used platform component that had become increasingly expensive to maintain and difficult to upgrade, while a newer supported alternative provided a better long-term foundation. Because many teams depended on the existing technology, I treated the replacement as a product migration rather than simply changing the infrastructure underneath them. We defined the target state, published a deprecation timeline, provided migration tooling and documentation, and tracked adoption across teams. The old technology was retired only after the migration risks and remaining exceptions were understood.
Follow-up 1. How did you convince teams to leave a technology they were comfortable with?
Answer: I showed the operational and strategic reasons for the change, including maintenance cost, security or support risk, upgrade limitations, and the benefits of the replacement. More importantly, we reduced migration friction by providing templates, automation, documentation, and direct support. Teams were more willing to move when the platform team shared the migration burden, instead of simply announcing a deadline.
Follow-up 2. What did you do with teams that could not migrate by the deadline?
Answer: we classified exceptions based on business criticality, technical blockers, and risk, rather than treating every late migration equally. Where temporary continuation was safe, we established a time-bound exception with explicit ownership and a migration plan. For high-risk cases, we prioritized engineering support or compensating controls rather than allowing the deprecated technology to remain indefinitely.
Follow-up 3 curveball. After most teams migrate, the new platform proves less reliable than the technology you deprecated.
Answer: I would not defend the migration simply because significant effort had already been invested. I would compare the actual reliability, operational burden, and business impact of both platforms and determine whether the issue could be corrected in the new architecture. If the new solution remained materially worse, I would recommend the least risky corrective path, even if that meant revisiting the original migration decision.
116. Tell me about a time you managed a difficult platform infrastructure migration.
Answer: we needed to migrate dozens of application teams from an aging legacy infrastructure platform to a new standardized Kubernetes architecture. The biggest risk was the workloads having vastly different network dependencies, operational patterns, and levels of container readiness. I created a comprehensive migration inventory, classified workloads by complexity and risk, and divided the program into controlled deployment waves. We provided automated compatibility tooling and migration guidance, while rigorously monitoring production routing behavior after each wave, allowing us to identify edge cases early.
Follow-up 1. What made the infrastructure migration exceptionally difficult from an engineering perspective?
Answer: the main challenge was not moving the compute instances themselves, but dealing with hidden network configurations and undocumented dependencies that were not visible from the platform layer alone. Many applications possessed custom operational behavior or strict availability requirements. We therefore treated workload discovery and dependency validation as first-class migration activities, rather than assuming the migration was technically uniform.
Follow-up 2. How did you minimize the risk of a catastrophic outage during the migration cutover?
Answer: we heavily utilized pilot workloads, phased rollout waves, pre-migration validation checks, clear rollback criteria, and extensive post-migration monitoring. Higher-risk workloads were moved only after the process had been thoroughly validated on representative lower-risk systems. We also maintained clear technical ownership for each migration wave, so issues were never lost between the platform and application teams.
Follow-up 3. Curveball. Halfway through the migration, you discover that the target Kubernetes platform has a design flaw affecting a critical workload class.
Answer: I would immediately pause the affected migration wave rather than continuing blindly, just to protect the project schedule. I would isolate the affected workload class, assess the severity and scope of the design flaw, and determine whether a targeted redesign or an alternative migration path was safer. Continuing known bad migrations simply to hit a deadline can significantly increase the eventual blast radius.
117. Tell me about a time you had to maintain compatibility between different versions of a shared platform component.
Answer: different teams were running workloads on different versions of a shared platform component, but they could not all upgrade at the same time because of application dependencies. I maintained a supported compatibility window and made the version differences explicit through platform metadata and validation. We tested the shared component against the supported versions and provided a migration path toward the newer version. This allowed teams to upgrade at different speeds without forcing the platform to support an uncontrolled number of versions.
Follow-up 1. How did you prevent compatibility support from becoming permanent legacy support?
Answer: we defined a clear support window, published end-of-support dates, and tracked which teams remained on older versions. The platform validated supported combinations rather than allowing arbitrary version combinations. This gave teams flexibility within a controlled boundary, while creating pressure to migrate before support expired.
Follow-up 2. What if maintaining compatibility doubles the platform team's testing effort?
Answer: I would quantify the cost of supporting the additional version against the business value and migration constraints it addresses. If the compatibility window was justified, I would automate the compatibility testing and limit the number of supported combinations. If the cost became disproportionate, I would work with stakeholders to shorten the support window or fund the migration effort.
Follow-up 3. Curveball. A critical customer requires an old version that the platform team has officially declared unsupported.
Answer: I would not silently bring the version back into the supported matrix because of customer pressure. I would assess the security and reliability implications, determine whether a time-bound exception with compensating controls is possible, and escalate the commercial trade-off to the appropriate leadership. If the customer requirement justified continued support, that decision should come with explicit ownership and funding, rather than becoming hidden platform debt.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
118. Tell me about a time you reduced cloud or platform costs without compromising reliability.
Answer: we discovered that a significant portion of our cloud spend came from over-provisioned compute, idle non-production environments, and workloads using expensive infrastructure without corresponding utilization. I analyzed usage patterns against workload criticality and identified savings opportunities that would not affect production reliability objectives. We right-sized appropriate workloads, introduced lifecycle controls for non-production resources, and improved capacity utilization while protecting redundancy for critical services. The savings came from eliminating waste rather than simply removing resilience.
Follow-up 1. How did you make sure cost optimization did not create a reliability problem?
Answer: we classified workloads by criticality and mapped each optimization against its RTO, RPO, availability and capacity requirements. Changes were introduced gradually with monitoring and rollback options, and critical redundancy was left intact. We measured both cost and reliability indicators after each change, rather than treating the cost reduction itself as success.
Follow-up 2. How did you identify the highest value FinOps opportunities?
Answer: I looked at absolute spend, utilization, resource efficiency, idle capacity, and the business criticality of the workloads consuming the resources. High-cost resources with consistently low utilization were usually stronger optimization candidates than heavily utilized production systems. We also considered whether the optimization would create operational complexity that outweighed the savings.
Follow-up 3. Curveball. Finance demands a 25% cloud cost reduction this quarter, but engineering says any further optimization will affect reliability.
Answer: I would break the target into specific cost drivers instead of applying a blanket reduction to infrastructure. I would separate waste, inefficient capacity, and optional spend from intentional reliability investment, and identify what savings were realistically achievable without violating service objectives. If reaching the full target required a reliability trade-off, I would make that trade-off explicit to leadership rather than silently degrading the platform.
119. Tell me about a time you had to balance platform team goals against business priorities.
Answer: our platform team had planned a major internal modernization initiative, but the business prioritized a customer-facing launch that required platform capacity and engineering support. Rather than defending the original roadmap, I evaluated which platform commitments were essential for reliability and security and which could safely move. We redirected capacity toward the business-critical launch while protecting the highest-risk platform work and documenting the modernization items that were deferred. This kept the platform aligned with the organization's immediate priorities without losing visibility into the longer-term engineering work.
Follow-up 1. How did you prevent business priorities from permanently pushing platform health aside?
Answer: we separated mandatory reliability and security work from discretionary modernization and tracked the deferred items explicitly. I also communicated the consequences of continued deferral, including operational risk and future engineering cost. This allowed leadership to make conscious trade-offs rather than allowing platform health to deteriorate invisibly.
Follow-up 2. What if the business repeatedly deprioritized platform investment?
Answer: I would use accumulated evidence to show the consequences, such as rising operational toil, incident exposure, slower delivery, or increasing infrastructure cost. If the business still chose to prioritize other work, I would document the accepted risk and adjust the platform strategy accordingly. The role of the platform engineer is to make the consequences visible, not to assume the business must always choose the technical team's preferred priority.
Follow-up 3. Curveball. Your team is measured on platform modernization, but leadership asks you to spend the entire quarter supporting a business launch instead.
Answer: I would clarify the business outcome, determine the minimum platform work required to support it safely, and replan the team's objectives rather than trying to achieve both goals with the same capacity. I would explicitly document which modernization outcomes would move and why. If the new priority became the organizational priority, the team's success measures should reflect that reality rather than creating a hidden expectation to deliver the original roadmap anyway.
120. Tell me about a platform decision that had an unexpected long-term consequence.
Answer: we standardized a platform capability around a technology that initially reduced implementation effort and gave teams a consistent deployment experience. Over time, however, more teams built dependencies around its abstractions, which made the platform harder to evolve and increased the cost of changing the underlying technology. The original decision was reasonable for the requirements at the time, but the adoption pattern created unintended platform coupling. We eventually introduced clearer abstraction boundaries, documented extension points, and reduced direct dependencies so future changes would be less disruptive.
Follow-up 1. How did you recognize that the original decision was creating long-term problems?
Answer: we noticed that seemingly small platform changes were increasingly requiring coordination across many teams, and that upgrades were taking longer than expected. Teams were depending directly on implementation details that were supposed to remain internal to the platform. The increasing change cost and growing number of exceptions were signals that the original abstraction boundary was no longer working well.
Follow-up 2. Looking back, what would you have done differently?
Answer: I would have defined the platform's ownership boundary and supported extension points more explicitly from the beginning. I also would have established clearer criteria for when teams could depend on an interface versus an underlying implementation. Most importantly, I would have treated future migration cost as part of the original architecture decision, rather than focusing primarily on the immediate delivery benefit.
Follow-up 3. Curveball. The original decision saved the company significant time and money in the first 2 years, but now creates a major migration cost. Was it still a good decision?
Answer: I would evaluate it based on the information and constraints that existed when the decision was made, while acknowledging the long-term consequence. A decision can be reasonable at the time and still create debt that must eventually be addressed. The important lesson is to recognize the lifecycle trade-off and improve the decision framework, rather than judging the past decision only from today's perspective.
121. Tell me about the platform engineering decision you're most proud of and what you would change about it today.
Answer: the platform decision I am most proud of was moving teams toward a standardized self-service model with reusable infrastructure patterns, because it reduced repeated platform work while giving developers a faster path to production. The strongest part of the decision was treating the platform as a product with clear defaults and guardrails, rather than simply exposing infrastructure. Today, I would invest earlier in platform usage telemetry and stronger lifecycle management for the abstractions we introduced. That would help us identify low adoption capabilities sooner and prevent unnecessary platform complexity from accumulating.
Follow-up 1. Why are you proud of that decision?
Answer: it created leverage beyond a single technical improvement. Developers could complete common tasks without repeatedly depending on platform engineers, while security and operational controls were applied consistently through the shared workflows. The platform team also gained more capacity to focus on higher value engineering, instead of repeatedly handling the same infrastructure requests.
Follow-up 2. What would you change if you could go back?
Answer: I would introduce stronger product metrics earlier, including adoption, task completion time, support demand, and usage of individual platform capabilities. I would also define clearer criteria for deprecating capabilities that were not being used. That would help prevent the platform from growing simply because it was technically possible to add another feature.
Follow-up 3. Curveball. 6 months after launch, adoption is much lower than expected. Does that mean the platform decision failed?
Answer: not necessarily. I would first determine whether the problem was the underlying platform strategy, the developer experience, lack of awareness, missing capabilities, or poor alignment with actual developer needs. If the problem was adoption friction, I would improve the product rather than immediately abandoning the strategy. If the evidence showed that the capability solved a problem developers did not actually have, I would be willing to retire it.
122. Tell me about a large platform migration you led and how you managed developer impact.
Answer: we executed a massive migration from a legacy CI and CD system to a modern GitOps deployment model. The biggest risk was not the underlying infrastructure, but completely disrupting how hundreds of developers shipped code daily. I established a phased migration plan based on workload complexity, provided automated pipeline conversion tooling and reusable GitOps templates, and gave teams a clear staging sandbox to test their new workflows safely. We used pilot teams to identify where the new GitOps model created daily friction, significantly improving the developer experience before mandating the broader rollout.
Follow-up 1. How did you comprehensively measure developer impact during the active phases of the migration?
Answer: we actively tracked migration-related support requests, pipeline deployment failures, onboarding changes, migration duration, and direct developer feedback. We also rigorously monitored whether deployment frequency or lead time deteriorated during the migration waves. This critical telemetry helped us identify whether the technical migration was succeeding, while the developer experience was actually degrading.
Follow-up 2. What did you do when developers loudly complained that the new GitOps platform was significantly worse than the old one?
Answer: I immediately asked for highly concrete examples rather than dismissing the feedback as standard resistance to change. We identified exactly where the new platform introduced unnecessary operational friction and where the old system provided capabilities we had missed. Valid issues were prioritized into the migration backlog, while intentional workflow changes were explained with clear operational, security, and architectural rationale.
Follow-up 3. Curveball. A migration wave causes a major developer productivity drop just before a critical business deadline.
Answer: I would pause the affected migration wave and stabilize the teams already migrated rather than stubbornly continuing, just to protect the project schedule. I would determine whether a pipeline rollback was safer or whether targeted platform fixes could restore productivity quickly. The remaining migration plan would then be adjusted based on evidence, rather than forcing the timeline at the expense of the business.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip: Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip. Get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
123. Tell me about deprecating a popular platform capability or tool and how you handled the transition.
Answer: we had a widely adopted platform capability that had become expensive to maintain and was preventing us from improving the underlying platform architecture because developers actively depended on it. Simply removing it would have created significant disruption. I published a clear deprecation timeline, identified affected teams, provided an alternative path, and built migration tooling where repetitive work could be automated. We tracked adoption and exceptions throughout the transition, and only removed the capability after the supported replacement was mature enough for the majority of use cases.
Follow-up 1. How did you handle developers who strongly preferred the old capability?
Answer: I first identified whether their preference represented a legitimate requirement that the replacement failed to support. If it did, we either improved the replacement or created a documented exception with clear ownership. If the old capability was simply more familiar, we focused on migration support, documentation, and demonstrating the benefits of the new workflow.
Follow-up 2. How did you decide when it was safe to actually remove the old capability?
Answer: we used measurable migration criteria rather than an arbitrary date alone. We looked at adoption of the replacement, remaining workload count, criticality of exceptions, operational risk, and whether the migration path had been validated across representative workloads. The old capability was removed only after the remaining risk was understood and appropriately accepted.
Follow-up 3. Curveball. A critical team says the replacement will cause a major outage if they migrate before the deprecation deadline.
Answer: I would validate the claim rather than automatically extending the deadline or forcing the migration. If the risk were genuine, I would create a time-bound exception while helping the team address the blocker and documenting the residual dependency. If the evidence showed the migration was safe, I would provide additional validation or a controlled migration rather than allowing fear of change to indefinitely preserve the old platform.
124. Tell me about capacity planning or load testing that avoided a major outage.
Answer: we were preparing for a significant increase in traffic, but historical production usage was not sufficient to confidently predict how the platform would behave at the expected peak. I combined historical trends, expected business demand, dependency capacity, and controlled load testing to identify the likely bottlenecks. Testing showed that one shared infrastructure component would become saturated well before the application layer reached its expected peak. We increased capacity and adjusted the scaling behavior before the event, and production traffic remained within the tested operating range.
Follow-up 1. How did you make the load test representative of production?
Answer: we modeled realistic request patterns, concurrency, payload sizes, dependency behavior, and expected traffic distribution, rather than generating a simple high-volume synthetic load. We also validated the test environment against relevant production characteristics and focused on bottlenecks that could materially affect customer behavior. The goal was to learn how the system failed, not simply produce a large number of requests.
Follow-up 2. What did you do when the load test exposed a bottleneck?
Answer: we identified whether the constraint was compute, networking, storage, a shared dependency, or application behavior, and then tested the smallest effective mitigation. We repeated the load test after each significant change to verify that the bottleneck had actually moved or been eliminated. We also documented the tested capacity boundary, so future planning had a measurable baseline.
Follow-up 3. Curveball. The business event is tomorrow, and the load test reveals a bottleneck that cannot be fixed in time.
Answer: I would focus on reducing exposure rather than pretending the system was ready. Options could include capacity increases, traffic shaping, rate limits, reduced feature scope, staged customer rollout, or temporary dependency isolation depending on the failure mode. I would communicate the residual risk clearly and establish real-time monitoring and escalation thresholds for the event.
125. Tell me about a time you engineered a platform to support multi-region, multi-cloud, or global scale.
Answer: we needed to expand a platform beyond a single region because customer traffic and availability requirements were becoming geographically distributed. I worked through the trade-offs around data locality, failure domains, networking, observability, deployment consistency, and operational ownership rather than simply duplicating the existing environment. We standardized the platform foundation while allowing region-specific configuration where necessary. The resulting architecture provided independent failure domains and a consistent operational model without pretending that multi-region infrastructure has zero additional complexity.
Follow-up 1. What made multi-region architecture difficult?
Answer: the challenge was managing distributed failure modes rather than simply provisioning additional infrastructure. Data replication, traffic routing, consistency requirements, deployment coordination, observability, and regional dependencies all had to be considered together. We also had to define what would happen when regions could communicate with each other only partially or not at all.
Follow-up 2. How did you decide what should be global versus region-specific?
Answer: we kept globally consistent concerns such as platform standards, security policies, deployment patterns, and observability conventions centralized where practical. Region-specific concerns such as capacity, latency-sensitive configuration, and certain infrastructure dependencies remained localized. The goal was to maximize consistency without creating a single control plane dependency that could undermine regional independence.
Follow-up 3. Curveball. Leadership asks you to make the platform multi-cloud immediately to eliminate vendor lock-in.
Answer: I would challenge the assumption that duplicating the platform across cloud providers automatically reduces strategic risk. I would quantify the actual business value of multi-cloud against the additional operational complexity, duplicated tooling, skills, networking, observability, and support burden. If the organization had a genuine multi-cloud requirement, I would design for portability where it provides value, but I would avoid creating a second platform solely to satisfy an abstract anti-lock in goal.
126. Tell me about a time you optimized platform workloads for sustainability or green ops by reducing carbon footprint or idle infrastructure.
Answer: we identified significant idle infrastructure across development and non-production environments, including compute resources that remained running outside active usage periods. I worked with teams to introduce scheduling, right-sizing, auto-scaling, and lifecycle policies while preserving the environments required for testing and operational readiness. We measured utilization and infrastructure consumption before and after the changes, rather than assuming every shutdown created meaningful savings. This reduced wasted capacity while also lowering the resource footprint of the platform.
Follow-up 1. How did you balance sustainability with developer productivity?
Answer: we did not simply shut down every non-production resource on a fixed schedule. We classified environments by usage patterns and business need, then applied different lifecycle policies to development, testing, staging, and always-on environments. Developers could request or automatically trigger required capacity when needed, while genuinely idle resources were allowed to scale down.
Follow-up 2. How did you measure the sustainability improvement?
Answer: we measured resource utilization, runtime hours, capacity consumption, and infrastructure usage before and after the changes. Where reliable carbon intensity data was available, we incorporated it into the assessment. Otherwise, we used resource and runtime reductions as operational proxies. We also checked that the optimization did not increase deployment delays, test failures, or production risk.
Follow-up 3. Curveball. A development team says your green ops policies are slowing their testing because environments keep scaling down.
Answer: I would investigate the actual testing workflow and identify whether the lifecycle policy is too aggressive or the environment is genuinely idle between tests. We could adjust the idle threshold, provide on-demand wake-up mechanisms, or exempt specific workloads where the productivity impact outweighs the savings. Green ops should optimize wasted infrastructure, not create friction that costs the organization more than the resources being saved.
Category 11. Final takeaways for platform engineers.
At staff and principal level, platform engineering is ultimately about judgment. The strongest engineers think beyond individual technologies. 1. Own the right things. Keep reusable infrastructure capabilities, security controls, and platform foundations centralized while leaving application-specific decisions with developers. 2. Do not adopt technology because it is fashionable. Evaluate maturity, operational burden, business value, total cost of ownership, and long-term consequences before introducing another platform dependency. 3. Treat migrations as risk management programs. Discover hidden dependencies, migrate in controlled waves, validate continuously, and maintain credible rollback paths. 4. Design for evolution. Shared platforms need compatibility boundaries, deprecation strategies, extension points, and clear lifecycle management. 5. Optimize cost without blindly cutting resilience. Use FinOps to eliminate waste, improve utilization, and align infrastructure spending with actual business requirements. 6. Make business priorities explicit. Platform teams must understand when reliability, modernization, cost, security, or business delivery takes priority and communicate the consequences of each trade-off. 7. Plan for scale before scale becomes an emergency. Capacity planning, load testing, multi-region architecture, and operational automation should be designed around measurable failure and growth scenarios. 8. Think beyond today's architecture. Every platform decision creates future constraints, dependencies, migration costs, and organizational consequences. 9. Build sustainable platforms. Technical scalability, financial efficiency, developer productivity, security, and environmental sustainability all become part of platform engineering at scale. A great platform engineer builds infrastructure. A staff-level platform engineer builds the systems, decisions, and engineering culture that allow the organization to scale.
The real platform engineering interview.
If you remember only one thing from this entire series, remember this. Modern platform engineering interviews are not primarily testing whether you can name Kubernetes commands, cloud services, or infrastructure tools. They are testing how you think when the environment is ambiguous. The stakes are high, teams disagree, costs matter, security creates friction, and there is no perfect technical answer. The strongest answers show ownership, judgment, trade-off thinking, measurable outcomes, and the ability to influence people without authority. That is what separates someone who operates infrastructure from someone who can engineer and lead a platform at scale.
Do not just operate the platform, own the outcome.
You now have a complete behavioral framework covering platform ownership, developer experience, automation, operational toil, prioritization, leadership, security, compliance, FinOps, scale, and Modern platform judgment, but knowing the answers is only the first step. Your goal in the interview is to connect each answer to a real engineering decision you made, the problem you faced, the trade-off you accepted, and the measurable outcome you delivered. That is what makes your experience credible.
Build, scale, influence, owned.
The modern platform engineer is no longer simply the person who provisions infrastructure. You are building the internal products developers depend on, protecting the organization from operational and security risk, controlling infrastructure economics, and creating the engineering systems that allow teams to move faster safely. If you can demonstrate that mindset through real examples, you are no longer answering behavioral questions. You are demonstrating how you operate at staff level.
Good luck with your platform engineering interview.
Do not memorize these answers word for word. Use them as frameworks and replace the examples with your own incidents, decisions, failures, trade-offs, and results. The interviewer is not looking for a perfect story. They are looking for evidence that when the platform becomes complex, the business becomes demanding, and the obvious answer disappears, you can still make a sound engineering decision and take ownership of the outcome.
Are you tired of generic interview prep? You can spend weeks studying generic interview questions, only to walk into a tech interview and realize they are asking about completely different tools and real-world scenarios. A tech title means nothing. A data engineer, DevOps engineer, or SAP consultant role is completely different at every single company. If you are not studying for the exact tech stack in the job description, you are wasting your time. That is exactly the problem we solve. Whether your upcoming interview is for SAP, DevOps, Salesforce, data engineering, cloud architecture, or cybersecurity, we will build a custom interview cheat sheet designed specifically for your target role. How we build your masterclass: you send us the exact job description. We analyze the technologies, the dependencies, and the seniority level. Then, we prepare a highly customized package with predicted interview rounds, realistic mock interview scripts, and targeted technical questions and answers. Stop guessing what managers will ask. If you have an upcoming interview and would like customized mock interview scripts and targeted practice questions and answers built specifically around your job description, feel free to email me at inquiry.aceinterviews@gmail.com. Please include these 4 details. 1. Your exact job description. 2. Your target role. 3. The interview date if known. 4. Your relevant experience level. Walk in with absolute confidence. I will personally review your submission and let you know what type of preparation package would provide the most value. We will analyze the requirements and build the exact custom mock scripts and questions and answers you need to get the offer. What if you people want a continuous study instead, with most commonly asked interview questions and answers PDFs? But what if you do not have an active interview lined up right now? If you want to proactively build your skills over time, we have recently launched our Master Vault subscription model. This is an all-access pass containing most commonly asked interview questions and answers PDFs of various tech roles in every single major technology like DevOps, SAP, testing, Salesforce, data engineering, cloud, Java and Python, etc. Choose the full bundle or specific paths, but we understand that unlocking every technology at once might feel overwhelming. If you are solely an SAP consultant, a Salesforce developer, or a DevOps engineer, you do not need the entire Master Vault. We redesigned the ecosystem so you can subscribe to the unrestricted full bundle or choose individual targeted vaults tailored specifically to your career. The universal interview tip. Whenever you ask a tech VP or an industry mentor how to crack a tough interview, they all give you the exact same tip: get familiar with the most commonly asked interview questions. It sounds simple, right? But here is the problem. The search nightmare. Finding the actual most commonly asked questions for senior roles is a nightmare. Generic Google searches only give you basic textbook definitions, and those will not help you clear a lead architect or senior engineer round where production reality matters. Imagine a master vault. Now, imagine a vault where the absolute most commonly asked interview questions for your specific role are already collected for you, perfectly organized by interview rounds like 1. Most commonly asked technical-based question and answers. 2. Most commonly asked scenario-based question and answers. 3. Most commonly asked real-world problem-solving question and answers. 4. Most commonly asked system design question and answers. 5. Most commonly asked behavioral-based question and answers. Cross-domain mastery. I built the ACE Interviews Master Vault for the modern architect. We did not just do this for one role. We covered everything: SAP, cybersecurity, DevOps, software testing, data engineering, Java, and Python. The ultimate all-access deal. Instead of paying for individual PDFs, you can now unlock our entire database. Get over 1,000 plus PDFs containing 50,000 plus of the most asked question and answers for a mere 1,499 rupees a month. The elite transformation. Stop studying just to pass. Equip yourself with the cross-domain confidence of a true architect and walk out of your next interview choosing between 2 or 3 elite job offers. Unlock the vault now. The era of buying individual guides is over. Click the link in the video description below right now to unlock the Master Vault. Now, let's get back to the masterclass.
For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers. For 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.